My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm Cloud Hired.
I'm Cloud Hired.
Hey, Go Cloud Architect family. I'm Cloud Hired.
But I'm Cloud Hired, guys!
So I'll just say I'm Cloud Hired.
I'm Cloud Hired.
I'm Cloud Hired, thanks to Go Cloud Architects.
It worked for me, and now I'm Cloud Hired. Because of Google Architect program, I am Cloud Hired. See!
I am Cloud Hired. Thank you, Mike and the GlowCloud team.
Welcome everyone to our AWS Certified Solution Architect 2022 course. My name is Michael Gibbs and I'll be your instructor throughout this session. I've been working now in tech for well over 25 years. I've been an architect for over 25 years now, and I want to help you get cloud hired. That's everything we do, we get cloud hired. We have a lot of free things that we're going to talk about at the beginning of this course to not only make sure you can easily pass the AWS Solution Architect certification, but you'll be prepared and better prepared for knowing how the technology works, how to apply the technology, and to some degree what's going on under the hood. And this is an AWS full course tutorial. And the reason we do free AWS certification training is as follows. We saw the courses that were out there. They were purely the name of a service and how to configure that service. But the problem is, solution architects and cloud architects don't configure anything. It's all about designing, and you can't design what you don't understand. So we're going to make sure you understand things very, very well. And that's why we do this free AWS course, to build your cloud architect career. We'll talk about, I'm sure it'll come up, some AWS career tips. This will prepare you for the AWS SACO3 exam, the brand new exam. We've fully updated it to take care of all the things in the new course. And this is an AWS Cloud Computing full course and a Cloud Computing complete course as it relates to the AWS Certified Solution Architect Associate. We want to make sure that all of you get cloud hired. I've got a student in my cloud architect career development program that gets hired basically every single day. And my favorite thing in the world is when someone gets cloud hired. I want to help anyone in the entire world that wants to get a cloud architect job or a solution architect job, get cloud hired. Anybody that wants to earn more in tech, I want to help them do it. And I'm here to help you all get cloud hired. Give me a hashtag AWS Cloud. And then let me tell you about all the really great free things we're going to be doing along with this boot camp to make sure you can easily get cloud certified, because the AWS Certified Solution Architect Associate should be very basic and easy after this course. But I also want you to learn. My team has completely updated, and we'll tell you more about it next week, but you can be the early adopter for it right now, our AWS Certified Solution Architect Associate and Professional Exam Guide. We've had about 100 authors to put this book together with hundreds of years of total technology experience. And I want you all getting cloud hired. And that's why we're doing this. So please give me that AWS Cloud hashtag. Now, so we can focus on making sure you understand the technology. What is the technology? How does it work? How does it benefit the customer? Because you're going to need that on a cloud architect interview or a cloud engineer interview. They're not going to ask you to go configure something or the steps, but what they will ask you is how the tech works and how to apply it. And I want to make sure that you're prepared for solution architect interviews and cloud architect interviews. So here's what I want you to do. Download the completely free, or sign up for the completely free AWS lab demos. The link is in the description below. And in the description below, you can download those free lab demos. And that way you can do hands-on practice. I'm going to be focusing my time with you on making sure you understand the tech. Because I taught an 8-year-old how to configure an EC2 instance in less than 3 minutes. Taught that same 8-year-old how to do an S3 bucket in less than 5 minutes. And nobody's going to hire you just for those skills. They're going to want to know that you have it in your head. You understand what the solutions are and how they can impact business. So we're going to have a lot of fun. So please download the free lab demo videos. Sign up for them and do that on your own time. Now, this Thursday, we're going to have a completely free webinar on how to get your first cloud architect job. And in that, I will tell you everything you need to know to get hired. And while we're at it, we've got a lot of free things coming up very, very, very soon. So many things. We've got executives coming from NVIDIA to talk to you about what they want and from hiring people. We'll always have more solution architects come and talk to you. I interview CEOs constantly on what they want as part of digital transformation. So, sign up to our email list so you can find it. Now, if you can all give me a hashtag AWS Certified Solution Architect Associate, we're going to begin the class. We're going to have lots of fun. Now, I would never, ever, ever give you a class which is PowerPoint, blah, blah, blah in the background. We would never do it. We're going to have live training for 20 minutes. And then after that, you know what we're going to do? Answer your questions. Why? Because I want to make sure that you're skilled. You've got knowledge and capabilities so you can have the absolute best cloud computing career in the world. We will cover all the recent updates in the Certified Solution Architect Associate. We will also include much of the AWS Certified Solution Architect Professional in the same boot camp because the associate's just not enough. And I want you to have much more competency and much more knowledge. And that's why I'm focused on having you download or at least sign up for the free labs, which you can do on your own, and making this a real classroom that you can actually learn. I used to take these courses constantly. They were for $3,000 to $5,000 for the week for the ability to ask questions. And that's why I'm doing it completely free, because I know most people can't afford the kind of training they need. And I don't want them getting something off of Udemy, which is taught by somebody that's never done the job before. I've done it for 25 years, and I want to help all of you to get cloud hired. So that's why we're going to cover this week. We're going to start by having a lot of fun. So this week, we're going to be covering the AWS Certified Solution Architect Associate. This is a free AWS course to help with your cloud architect career. We'll cover AWS career tips and cloud architect training, which is different than Certified Solution Architect Associate training. But, we're here at Go Cloud Architects and Go Cloud Careers to help you get cloud hired. So we'll begin. Just to let you guys know, it costs about as much as a new car to produce one of these things. By the time we take into account all of the team members that we have and all the work they're doing, and we're going to do it for you to make sure you get hired. So if you think anybody needs help, guess what? Send them a tweet, make a LinkedIn post, and invite them to this free training. While we're at it, please subscribe and hit the bell to our channel, because you're going to hear a lot about new things. Like tonight, we're going to talk about how to optimize and get hired for cloud architects versus how to get hired and optimize your career for cloud engineers, because the careers are so different. Most people confuse them, and that's why they can't get hired. So we're going to be talking about that tonight to help you build the best cloud computing career. But let's begin. We're going to begin with the AWS Cloud and how it is organized. So to begin, let's talk about the AWS Cloud organization. The first thing we're going to talk about is the AWS region. Now, what is the AWS region? Think of a massive geographic area, like a continent or part of a continent. So this big global area, that's what a region is. And then we're going to be talking about availability zones. And guess what they are? Nothing more than a simple data center. So you're going to have a big, giant geographic area. And inside of these big, giant geographic areas, what are you going to have? Data centers. In the data centers, you're going to have servers and storage, physical load balancers. You're going to have firewalls, routers, and switches. Guess what? The same thing that you have in every other data center. Now, what the cloud is really? It's just renting space in somebody else's network in a data center. It's all been virtualized for you. It's nothing more than that. That's why all clouds are the same. Now, when we teach this course, we're going to try in many cases to teach the generic technology. So you know how to work with AWS, Azure, Google, Alibaba. It doesn't matter. If you understand the cloud, you understand all of them. We'll also talk about local zones, and we'll show how that can reduce latency and improve performance. And I'll show you exactly what that looks like. And we'll talk about edge locations as it pertains to the AWS Content Delivery Network called CloudFront. So let's visually look at this for a minute. Here, what you can see is the AWS Cloud and how it's organized. You can see this big, beautiful green box, which was drawn by my team. how that represents, a geography, like a whole continent or part of a continent. Now, the next thing we'll actually talk about is those availability zones. And you can see in this diagram, what do we have? We have these availability zones that are connected to each other with links. What do you think those links are? Network links, most likely fiber optic links, multiple fiber optic links, 10 gig links, 100 gig links, and link aggregation groups, or port channel, ether channel, whatever terms you want to call it. Same kind of concept where we're bundling multiple links together. These links are going to be in a highly redundant manner, and there's going to be some routing in between the availability zones. And of course, routing between regions as well. So now you can see region, large geographic area, data center availability zone. What's a data center? Again, it's just it's a room full of routers and switches and servers and storage and load balancers and firewalls, etc. So now while we're at it, let's talk about the concept of local zones and what it is. Now, when you want the most high performance in the world, you can't use the cloud. I'm going to say this again. If you're looking for ultimate peak performance, you can't use the cloud. See, in the data center, we can do many more things on the network. We can actually lock down our networks and make them more secure if we need to. But, keep this in the back of your mind. The data center will always perform better. Why? Because the storage we have in our data center is going to be far faster than block storage, because there's the latency on the wire to take you to the cloud provider. So imagine that you have a direct connection or a private line to the cloud. Basically, it's some kind of like a wire, just sort of like my iPhone cables here. Now, what happens is it takes time to transmit your information over the wire, and we're talking about milliseconds. Now, that's okay, right, for normal things? Yes, it is. But there are applications where a nanosecond can be a competitive business advantage. And when you deal with that, for example, a nanosecond being a competitive advantage, it makes things on the cloud being impractical. So that's why they're coming up with local zones, which are still never going to be as fast as your own data center, but it's a midpoint, and I'll show you why. A local zone is an extension of the region. So you can run latency-sensitive applications closer to you, the user. It enables you to put your computing power closer to the users. What'll happen is you first have to opt into local zones. Then you're going to create a subnet in the local zone. And of course, in your subnet, that's where you're going to place your systems. Your virtual machines, otherwise known as EC2 instances, your load balancers. You could be putting your containers like Elastic Kubernetes Service or any kind of container orchestration you put there, the Elastic Container Service, Kubernetes Service. We'll talk about why you probably don't want to use the Elastic Container Service as we go through this, and why the Kubernetes environment is much better, but you can still use both. Now, there are some local zones that are going to offer even more resources to you, like Elastic Map Reduce if you're trying to do some mapping and reduction to create a data lake, for example, or change information between databases. Elastic Cache, which is some basic caching, which we could talk about. Of course, you could build your own Redis cache and not use a period. RDS systems and even dedicated hosts. So that's what we're really, really talking about. So what's it look like architecturally? I'm going to show you this, and I'm going to draw it out for you to make sure it makes more sense. Local zones are realistically this way. Again, we've got this giant green box, this large geographic region. And in this region, that's where the majority of our systems are going to be. We're going to have little data centers. Now, these local zones are effectively data centers in between your data centers. So I'm going to do this. I'm going to map it out with you real time so you truly understand this. Sometimes I just love using a whiteboard. So let's look at it this way so you can understand it. In a traditional environment, you're in your data center, and everything works great in the data center. But if you wanted to use a cloud, and the cloud is nothing more than somebody else's data center, we call this the AWS cloud. It could be any cloud for that matter. What happens, as I mentioned before, is you've got this latency over your networking link. And that latency could be too much for the business application. So what a local zone really is a mini AWS data center between you and the cloud. We'll call it AWS local zone. Oops. It's a mini data center. Actually, it's not that many. And what happens is we call local zone, is we can put our latency sensitive things in between our data center and the local zone. And then of course, the local zone and all these other things will basically have communications which will be backhauled back into the cloud. And in this manner, you can actually put your low latency things closer to you. Of course, if you're looking for the ultimate in availability and the ultimate in performance, we can get rid of all this edge location stuff and just keep our critical applications in the data center and latency sensitive and critical applications in the data center and then use the cloud. Or we could take advantage of a local zone. There's benefits and detractors to do each. That's the kind of thing we could cover in our Cloud Architect Career Development Program, but there's lots of reasons to know how and when and where to design systems. But this week we're focusing on certifications. So that's what a local zone is. Now let's talk about an edge location. The edge locations are for the CloudFront Content Delivery Network. And realistically speaking, edge locations are basically going to provide user access into the content delivery network. Now we will go into depth into CloudFront and we will talk more about content delivery networks when the time progresses, but because right now we're talking about the AWS cloud and how it's organized, we talked about regions being a large geography, data centers being called availability zones, the data center between you and the cloud provider being called the local zone, and it's just another data center, nothing else, nothing fancy. Now let's talk about these edge locations. So many of you, when you go to the internet, let's say you wanted to go to www.gocloudcareers.com, what would happen is your computer would then do a DNS lookup to see who has the IP address of www.gocloudcareers.com. Then what would happen is the DNS server would give you the IP address. Then your system would look in its routing table, it would find its default router, and it would do an ARP who has the MAC address for www.gocloudcareers.com, and then the packet would be sent to the upstream router. Now, without a content delivery network, if you're in Athens, Greece, where I'm from, for example, or you're in Alexandria, Virginia, or if you're in Cambodia, Cameroon, or Chicago, basically you would have to be accessing the network over the internet coming back to my website. The problem is as follows. There's latency going from point A to point B, and the latency may kill your user's experience. So a content delivery network, and I'm going to show you how this works in a minute, is going to make your content closer to the users so the users have a better experience. Now, edge locations are where AWS puts its content caching and its private network, and I'll show you exactly what that looks like. It's really, that's all for those of you that are new to cloud but have worked in networking, it's essentially called the point of presence, where lots of people do their BGP peering and they connect to each other. For example, edge locations will increase performance and reduce latency. And key, it's not just related to traffic going across the internet and using caching. It's by using a private network, and I'll show you how. And let's look at what this actually is going to look like. First, I'll show you architecturally, and then I'm going to show you the user experience. Architecturally, here's what the AWS cloud edge locations actually look like. Now, when we're here, you can see that we've got this large region. You can see the data centers or availability zones in this region. And then you can see these edge locations. This is where your content is cached. Now, let's take it for an example of reality in real life. What's it going to look like and how does this work? Let's say we have the nice, happy blue user, the one in the upper right-hand corner of the screen. Now, this user is my wife. And she's there and she wants to go to www.gocloudcareers.com. So what does she do? She goes and types that into her browser. Now, what will ultimately happen here is as follows. If no one that day has requested information from www.gocloudcareers.com, the blue user will hit that edge location. The edge location won't have any information. The edge location would then send that information to the regional cache, which has no information, And then the traffic would be sent to the AWS source. And whether it's a static website, static files, which are an object storage like AWS S3, or a dynamic website, which has got things that are going on our virtual machines, otherwise known as our EC2 instances, that what'll happen is the user will go to the edge location. The edge location will take them right off the public internet and onto the very fast AWS private network. The source will answer. It'll hit the regional cache, the information will be stored. It'll hit the edge location, the information is going to be stored. And there you go. You've got your user. Now the next, let's say I go to the same place right after my wife went to Go Cloud Careers. And now I represent the second blue user in the upper right-hand corner. Now I type www.gocloudcareers.com into my browser. My request gets sent to the edge location. The edge location sends it immediately back to me. It's cached. And by doing this, we've got a lot of benefits. And here's the reason why. First, the web servers don't have to keep answering the request. I gotcha, I gotcha, I gotcha. So we've reduced load on the web servers. Now next, let's think about this. The web server's load is reduced, but the latency is reduced because the content is already there. Now, we'll talk about later how content delivery networks can really reduce costs, and content delivery networks can work very, very, very well to protect against DDoS attacks or distributed denial of service attacks. And when we talk about CloudFront and preventing DDoS, we'll talk about exactly why content delivery networks are good. Although generally speaking, you should use more than one content delivery network, just like you should use more than one cloud. We'll talk much more about that later. So now, actually, let's talk about the VPC and what it is. So when you deal with AWS, you're going to be dealing with something called a virtual private cloud. Now, I've built lots of private clouds. Every student in our Cloud Architect Career Development Program builds a cloud from scratch. You can't be a cloud architect if you don't know how the cloud is designed, so all of my students build a cloud. Now, what is a virtual cloud? So basically, here's what you need to understand. You need to understand that the cloud is just a data center and a network, and it's nothing more there. Nothing more than a network and data center. The virtual private cloud is they sell you virtual access to the data center. Kind of like if you checked into a hotel, you can consider the hotel to be the data center. In each room, you could look at it as your VPC or your virtual private cloud. It's your space in a public environment. Now, your space is safe and secure inside of this public environment, but you have to understand it's just your space. So let's talk about what that means. Let's actually look at it architecturally so you can see it. Sometimes visual images are helpful. Here we go in this environment. We've got the AWS cloud, which is nothing more than a bunch of data centers, okay? That's it, that are networked together. And inside of these data centers, you carve out your private space. For example, we've got VPC1, which is blue. We've got the VPC2, which is green. VPC3, which is red. And VPC4, which is yellow. All isolated from each other, all on the same cloud. And there's lots of reasons why cloud computing can be beneficial. And we'll be talking about them throughout the week when we go into auto scaling and other things that makes the cloud more agile, which makes it potentially able to perform some wonderful digital transformation. Now we're going to talk about some basic cloud architectures. We're going to talk about a hybrid cloud. Then we'll talk about a pure cloud. Then we'll talk about multi-cloud and their strengths and weaknesses for every one of these things. Let's first begin with the hybrid cloud. If you want the best performance and the highest availability, you're interested in a hybrid cloud. What is a hybrid cloud? A hybrid cloud is when an organization keeps its data center and they connect that data center to the cloud. Now, most of the time in a hybrid cloud environment, we install like an IBM OpenStack or a Nutanix cloud on these private data centers, and we get our own beautiful high-performance agile cloud, and then we can still connect to the public cloud. We can connect to the public cloud for scalability as needed, and we can use the public cloud for what it's good for, agility, auto-scaling, and all these other wonderful things. But we still have ours. This way, when the next time a cloud provider has a power failure, Not that power failures can really take out a cloud, or somebody makes a BGP misconfiguration, or the next time a cloud is hacked. No, trust me, we've had plenty of cloud hacking in the last few years. Some customers have been honest, some cloud providers have been honest about it. Other ones have had outages that are unexplainable. Who knows? But the point is cloud provider can go down, hybrid cloud can stay up, and you're still in business. So let's talk about when that's valuable. Well, imagine you've got a hospital. If you only stick them on one cloud and the cloud went down because of a security event, a network event, or a control plane failure, then you're still up. And imagine a hospital where they're all in one cloud. Cloud goes down, patients die. So that's why we need to be very good and mindful of our architectures. Hybrid clouds, I love them. Hybrid clouds can enable the low latency, ultra performance in the data center, and can allow you to scale to 1, 2, or 3 more clouds. And by doing so, wow, you're in a beautiful position. So a hybrid cloud is ideal for an organization that's got a current data center that's being well run with modern equipment. Or want somebody that needs ultra performance or ultra high availability, like a hospital or a bank. Architecturally, what's a hybrid cloud look like? It looks just like this. I'm a huge fan of hybrid clouds. I've been helping many people with hybrid clouds for as long as I can remember. And realistically speaking, the organization's got their data center, they've got a private line or some connection to the cloud, and then they use multiple availability zones in the cloud. And that way, cloud goes down, no big deal. Data center goes down, you still have the cloud. Lots of survivability, potentially huge improvements in cost performance, especially for applications that are running 24 hours a day, 7 days a week under high load. They may be cheaper in the data center, where other applications may be much cheaper in the cloud, and that's why the architects need to look at the business requirements as opposed to what's taught in the certification. So let's talk about the next kind of cloud architecture. And this is a pure cloud environment. Now, here's the thing with the cloud. You don't have to buy anything except for your routers. And in some cases, that's a great thing. Now, it may be more expensive to be on the cloud, but it may be cheaper. Again, it depends exactly on the use cases. But let's say it's a brand new organization and they don't have the capital resources to build their own data center. They can go straight to a cloud. They can build their startup things. The cloud will give them scalability, rapid deployment, enable them to connect to partner organizations, and create a really distributed environment. And guess what? I love that. But once the availability needs come better, once the business gets bigger, what do they need? Multi-clouds or a hybrid cloud. Because a single cloud has a single point of failure, no matter how many availability zones and regions you use. And we've seen this with every cloud provider that's had a major outage. But here's what a pure single cloud environment would look like. We never recommend a single cloud except for small businesses where availability is not critical. But we never recommend something like this for a bank or healthcare organization. So let's look at this. We've got, in this environment, our organization. We've got our connectivity to the cloud. And with that, we can show that our data centers are up and running. And that's how we do this. Okay, let's talk about connecting to the cloud. Connecting to the cloud.
Oh, sorry, that's the timer, Mike. You got good timing.
Timer? Okay, sounds good. So
let's ask for a hashtag in the chat box.
Give me a hashtag.
If they're having fun, that is.
If you're having fun, give me a hashtag AWS Certified Solution Architect Associate.
I'm not the Cookie Monster. I don't know if I can spell that long of a word.
If you guys can give me a hashtag AWS Solution Architect or hashtag AWS SAA, I'll be fine with either one of them. But I prefer you spell it out. Keeps the algorithms happy. There we go. You're there. You're good. If you haven't subscribed and hit the bell, please do so. Let me see if you guys are doing so. I can tell real quick. And then let's get back to the exciting content. Make sure you subscribe and hit the bell. Now let's get back into talking about content, because we want to make sure you all get the knowledge that at some point in the future, you're all getting cloud hired. So let's talk about connecting to the cloud. If you're going to put your stuff on the cloud, you got to be able to reach it. Now, most of the stuff that we care about in business is not a website which you access over the internet. It's internal stuff. Internal stuff. What do I mean by internal stuff? HR applications, internal financial applications, and all these other critical things. Keep that in the back of your mind. So once you put your data in the cloud, you got to be able to reach it, right? Because you've got your cloud here, you've got your data center here where your users are. You don't have a link between them. Guess what? You've got nothing. Something my grandmother would call bupkis. You've got nothing. So, you want to make sure that you can actually reach it. Now, when we're dealing with connecting to the cloud, your reality is you're going to have a lot of options. You're going to have SSL-based VPNs, IPsec-based VPNs, private lines, Ethernet over MPLS, software-defined networking, and SASE. But for the purposes of the AWS Certified Solution Architect Associate and the AWS Certified Solution Architect Professional and the AWS Advanced Networking, which is an intro to networking, we're going to be talking about VPNs, and we're going to be talking about private lines. So let's first start with a virtual private network. A virtual private network is really nothing more than a means to secure private network connectivity over a public internet or a public network. Now, I've been working on VPNs and clouds for 20-some years. Most VPN technologies in today's world are either an IPsec tunnel, an L2TP tunnel. It could be an MPLS BGP VPN. It could be VPLS or virtual private LAN services. But today we're going to be talking about IPsec tunnels, which is the type of VPN you're going to be using when you're dealing with cloud computing and connecting to your cloud provider. Now, you may ask, why do I need this silly VPN thing? Why can't I just use the internet? Well, a couple of things. If you're going to use the internet, you'd have to have public addresses on all of your systems, which we know is not possible because we ran out of IPv4 addresses a long time ago, and that's why we use private addressing, which we'll talk about later. Now, next on this list is the routing. If we're going to use the public internet to do all of our routing, we need to take in, say, 800,000 routes from the internet, and then all of our own routes, and we'd have to have public addresses. So we'd be dealing with $100,000 routers as opposed to maybe $5,000 routers that could handle a big full internet routing table. Now, I'm used to doing highly complex internet routing. I'm one of the first Cisco certified internet experts, and I've designed consulted on half of the world's largest internet service providers. But let me tell you, this stuff is complicated. And, it's not something that the average bear would want to be dealing with, for example. And you stick a private line and a VPN between it, and all that complicated BGP and traffic engineering and route aggregation and all that stuff, for the most part, is simplified. Address spacing with VPNs, we can pass our private addresses across the link, and we can also pass our routing across. OSPF, BGP, whatever our routing protocols are. Now that means we need to be on the same subnet on both sides. And we can't do this over the internet. But what we can do is simply as follows. We created an IPsec tunnel, both sides are on the same subnet, and now we can pass routing information. So let's look at what your VPN would look like architecturally. Realistically speaking, you're going to have your data center, you're going to have your cloud. And while we're dealing with the data center and the cloud, what you're going to be dealing with is there's a router that connects to the internet here. The virtual gateway on the AWS side is connected to the internet, and you're going to create an IPsec tunnel. Very simple. And why is this so great? Well, the internet's everywhere, right? Meaning you're already connected to the internet, and AWS is connected to the internet. Azure is connected to the internet. Google is connected to the internet. See, they're all there. And when you realize that, the ubiquity or the internet being everywhere it makes it just so easy to just create a connection between them. By doing so, guess what? You are now in a position, you've got a straight line connection across the internet. Want to create another connection to another site? Poof. Start your tunnel on both sides and you've got connectivity. So the internet is fast in terms of connections. But there's other things that we'll talk about, what, how, and why. If I can find my mouse here, I will move. Okay, so there is that. So let's talk about IPsec VPNs some more. IPsec VPNs get around the security and IP addressing challenges of the internet. IPsec realistically does this. Let's say my hand is a tunnel. You put your private traffic through the tunnel, and on the other side of the internet, it comes out of the tunnel, and then it's back on your private network. Because it's private, we can use our private information, pass our routing information. Now let's keep going while we're at it. IPsec will encrypt your traffic so that if anybody was able to get access to your traffic going over the internet, guess what? They can't do anything with it in any way, shape, or form. And that's why it's not going to be useful to them. But IPsec does a little more than that. It prevents a man-in-the-middle attack. What is a man-in-the-middle attack? So let's say I tried to create a VPN to Chow. Chow is one of my amazing cloud architects, and she's got an internet router at her house, and I've got an internet router in my house. If I connect to Chow using IPsec, I know that Chow is actually Chow. And what do I mean by that? Actually, I might even draw it out for you. What I mean by that is I need to authenticate the person on both sides. I also need to make sure that the message has not been changed. Early in my work life, when I used to practice internal medicine as a nurse practitioner, I used to write prescriptions. Now, if I had a person having a heart attack and I wrote for a 4 milligram prescription of morphine, that might be the appropriate dose for a patient having an active heart attack. But if somebody changed that 4 milligrams to 40 milligrams, that patient would overdose, stop breathing, and in most cases die. So we need to ensure the message integrity of what we're dealing with. Now, also, we need to be sure that the sender can't say they didn't send it afterwards, and that's called non-repudiation. So let's build the whiteboard. Let's whiteboard out a VPN right now. So over here, what we're going to do is we're going to have two people. I was mentioning Chow, but I think we'll go back to my favorite kind of examples, and we'll use some furry friends. So, because I always love furry friends. So let's say on this one side of this, we have my cat Cindy, and my cat Cindy is basically wants to talk to her friend over a VPN. So let's go find one of my cat Cindy's friends.
Mike, you are not sharing the screen.
Oh, thank you, Chow. See, that was the Chow I was referring to. Now, let's say by comparison, let's say that Cindy wants to talk to her friend who is a rabbit that found its way into my garage. And obviously, I put out food and water for the rabbit, and I got it outside of my house and found somebody to house the rabbit before my Cindy could terrorize this pure, beautiful, sweet rabbit. So let's say both of them are actually connected to the internet, and they wanted to have a conversation, maybe about carrots or about chasing rabbits or doing any of these things. Now, if they're already on the internet, here's all they really need to do. Now, first, Cindy, we're going to pretend she's a sweet, gentle thing and she doesn't eat rabbits, which is totally not true. But we're going to pretend right now that my Cindy is a pure angel because I'd like to believe she is. Now, each one of these has a router that connects on the internet. And let's say Cindy's a sweet little girl that does not eat rabbits. And the two of them want to have a conversation. Now, by having the two of them that wanted to have a conversation together, guess what? And I'm trying to find some more animals. Everything's going to be fine. Cindy's going to be talking to Bunny. Bunny's going to be talking to Cindy, and they're all good. Now, when the meeting is set up and this connection is set up between Cindy, guess what? We know that Cindy is talking to her friend Cutie Pie the rabbit, and everybody's happy. Now, without IPsec, here's what could happen. We could have this beautiful cat named Sunny, who's my chief operating officer, Chris's cat. Again, a wonderful cat. But let's say Sunny likes to eat rabbits. And let's say that Sunny was pretending to be Cindy, and the rabbit, Mr. Rabbit, was saying, "Hi, Sunny, my home address is here." Now that would be a problem because then Sunny the cat would eat me a beautiful rabbit and the rabbit would not be happy. So we have to first prove that the message is real, and IPsec provides that advantage. Now, secondly, IPsec uses a hashing algorithm, meaning it creates a mathematical formula to let you know that nothing has been changed. In this way, Cutie Pie Rabbit over here can verify that Cindy, the sweet little girl that I hope she is sometimes, is actually her friend. And then when she says, come to my house at this address for dinner, I've got carrots for you and spinach for you, the rabbit goes to the correct address and not the address where the scary Sonny the cat lives. Now, next, we want to make sure that when we're dealing with our cats and our rabbits and they're happy, that Cindy the cat can't say to the rabbit afterwards when the rabbit came to the house, I didn't invite you. That's called non-repudiation. So when we're dealing with IPsec, we're getting three benefits. Endpoint verification, which prevents man-in-the-middle attacks, message integrity, and something called non-repudiation. The cat can't say that I didn't invite you. So let's talk about why we love VPN so much. Because the internet's everywhere, and you can set it up in minutes, or seconds, actually, if you're good. Where when we want a private line, which we're going to talk to next, it might actually take 6, 8, 10 weeks to get your private line set up. So VPNs can be done in seconds. They're generally speaking very inexpensive, and we can create multi-point tunnels. For example, my cat Cindy could create a VPN connection to Sunny the cat and somebody else's rabbit and somebody else's cat, all through the same internet connection. It's called a point-to-multipoint connection. Beautiful, simple, and elegant. Kind of keep that in the back of your mind. Easy, easy, easy going. Now let's talk about the disadvantage of the internet. In this case, internet performance is not guaranteed. When you stick your traffic on the internet, there's no guarantee that it's going to get to the destination. Zero guarantee that it's going to get to the destination. So because of this, if you need critical performance or low latency, don't use a VPN, use a direct connection. On a direct connection, it's 2-3 hops. Although the AWS does it a funny way, it could be more than that. But on a private line, it could be 20, 30 routers or more that you're going to. And that's the key. The internet is what's called best effort. Zero guarantees of your delivery. So once it's on the internet, you don't know if it's going to get there. Private line, guaranteed latency, which is how long it's going to take to go from both sides of the wire, and guaranteed bandwidth. So when it matters, you're going to be using a direct connection. Now, an AWS VPN is typically going to be set up between the organization's data center and your VPC. It's called the site-to-site VPN. But VPNs can also be set up between multiple sites as well. The way this works is both sides are set up to terminate the VPNs. You could call it an endpoint, and each endpoint encapsulates the packets and puts them into an IPsec tunnel, which sends it to the destination in that encrypted environment, just as we described. So when these tunnels get set up, here's what happens. They have to exchange security keys. And it's called an Internet Key Exchange Security Association. What happens is each one of the routers comes up and they determine the encryption type, like SHA-256, for example, the algorithm, etc. And of course, you can set up dynamic routing over BGP, which is preferable in most cases. Or if you don't know BGP and you don't know routing and you've only got a single point of failure and a single link, of course you could set up static routing, but I strongly wouldn't recommend that. I'd recommend learning BGP and being able to use dynamic routes, just like your GPS. If you're using dynamic routing, which is effectively a GPS, and I want to go to Chris's house, and parts of I-95 are blocked off, it'll tell me rerouting to go left, go right. A static route is like an old map book. You basically write your plans out, go left, drive 20 miles, go right, go 20 miles. But if there's a roadblock, you're in trouble. So that's why you'd want to use BGP. Now, AWS will tell you that their VPNs are highly available and redundant. And this is partially true, but partially not true. And I'll show you what I mean. Because the VPN on their end is logical, they'll say that it's fully redundant, and I'll show you how they're going to say connect the two things. That's great until the router on your end links goes, or your internet connection goes, and all that goes out the window. So we'll talk a little bit more about that in a minute. But what happens is when you set up your VPN to AWS, which is a logical router, virtual router, as opposed to physical router, the virtual routers can't go down as long as the cloud's up. So what happens is a link is going to be connected to 2 availability zones, which is 2 data centers. You can be set up as active-active or active-passive. For organizations that don't know routing, active-passive will be the best strategy, and that way they don't get out-of-order packets. For organizations that have the sophistication to understand routing, you're not going to create multiple VPNs and not use them, or multiple links and not use them. You're going to route using BGP. So let's look a little bit about why I said it's partially true and partially not true regarding the single points of failure with the AWS VPN. Now, AWS would tell you this is highly available, and they'd say, look, this device and their VPN device is not going to go down. It really won't. That's not how these systems work. But the problem is, if the device on the right side in the organization's data center goes down, everything's dead. And if the internet connection the organization is using is also down, the systems are dead. So if you really want a high availability VPN architecture, the only option you really have is as follows. You can create, and let's say this is AWS over here, and this is multiple availability zones. But we're just going to make one single box. And then this is your data center, which is sitting over here. The only intelligent way to do this is to put 2 routers in your data center, R1, R2, and each one of these links should be on a separate internet service provider in case the router or the internet service provider links. And then what you're going to do is connect to 2 virtual routers on AWS. And by doing so, you can lose, bear with me. By doing so, we can lose any of the following. We can lose one of these internet links or one of the routers. And that's truly, truly, truly how you build a high availability setup. You would basically create 2 routers with 2 connections going to both places. And now you can lose a router. One of these routers can go, for example, or one of the internet connections could go, and you're still happy, and you're still connected to the AWS cloud. Kind of keep this in the back of your mind. So let's talk a little bit more. As I said, the virtual gateway router on their end is highly available, but your stuff is not. So when it comes to high availability, one cloud is not high availability no matter how many availability zones and regions you use. Single router, no matter what, is not high availability. Military adage is 1 is none, and 2 is 1, and 3 is greater than 2. 1 is none. 2 is 1, and 3 is better than 2. Critical, critical, critical for you to understand that, and critical for our world. How do you set up a VPN? It's silly easy. Basically, you're going to determine which AWS virtual gateway you're going to connect to. Pick a routing method, static routes or dynamic routes. And either you set up your tunnel configurations, or you go to the form and AWS spits out a virtual configuration for you, and that's it. But I'll give you a little more information. You can obviously do a custom setup, which is what a network architect like me would do. I'd have my network engineers really put a nice routing policy, so that way I can tune the performance and tune my traffic engineering. But if you don't know what you're doing, well, actually you shouldn't be touching this stuff at all, because you'll just be taking systems down. But if you know what needs to be done, but don't know how to configure it, which is totally fine, the AWS System Management Console will literally create an auto configuration for most VPN devices, whether it be Cisco, Juniper Networks, Palo Alto, or Fortinet. And of course, you can monitor the status of your VPN tunnels with CloudWatch on their end, but you could also look at what's going on your routers at your end. Now, since we talked about what is a VPN, which is creating a virtual network inside of a public network, let's talk about a direct connection, which is like a wire. I've always viewed a direct connection as simply a wire between 2 locations. That's the way I like to look at it, because I've been working with private lines now for a couple of decades. And let me tell you, to me, it was always easier to explain it to people in terms of simple wires. So let's talk about this. A direct connection is the equivalent almost of a private line, and we're going to walk you through it. So why would you use a private line? Well, guaranteed bandwidth, consistent latency, and it's going to be the highest availability and reliability. Less to go wrong on a wire than the entire internet. Now, when you need higher performance, you can bundle links together. Now, if you have one link that's 10 gigs, you've got 10 gigs. If you've got two links that's 10 gigs, you've got 20 gigs. If you bundle 3 links together, you've got 30 gigs. And if you bundle 4 links together, it's called 40 gigs. For those of you that have been in networking for a couple of decades like me, I'm sure you've heard of port channel, ether channel, link aggregation groups. Link aggregation groups are effectively the new de facto standard for bundling links together. We can bundle up to 4 links per link aggregation group, and obviously we can create multiple link aggregation groups across routers. So now let's, now that I mentioned that it's a logical wire, let's talk a little bit more about it. And you can think of this wire being a wire, but it's really not just a wire, and I'm going to get much more into it. Now, to connect to the cloud, you're going to be using a fiber optic connection, which is always going to be single mode fiber, because we're going over distances. And remember, it's going to be a 1 gig link, a 10 gig link, and finally, AWS supports 100 gig links. There are several steps along the way, and we're going to show you that in a minute. But before we show you that in a minute, let's talk about the key underlying technologies. Obviously, you need a router. You're not connecting to anything. The router will have to be a fiber optic port because you're not going to go more than 100 meters on a copper connection. So it's going to have to be fiber optic. Now, single mode fiber is the only thing, as I mentioned, that's going to get you the distance. So if you're dealing with 1 gig, it'll be 1000 base-LX. If it's 10 gigs, you're going to have 10 G base-LR. For your exams, you might expect to see 1000 base-LX or 10 G base-LR for 10 gig respectively. Now, for any of you that are coming from the networking world, which is like the perfect world for cloud computing, because we network people who've been working with cloud for 20 plus years, 25 years, you know that when you're dealing with a laser and you put those lasers in your fiber optic part, there's a send laser and a receive laser. Now, if your send laser is up, but your receive laser's down, in many cases, the link will stay up. The problem is your traffic won't be flowing and your traffic will be tossed apart, thrown away. So when you have multiple links, you need something that's going to let you know if one of those links is partially down to close that entire link, like a health check, which we'll talk about when we get to DNS or load balancers. AWS, like most good networking organizations have done for the last 20 years, enables something called bidirectional forwarding link detection. And that means if you've got a send and receive laser and one of these lasers goes down, it removes the entire link so you can fail over to your backup connections, which is exactly what you need to use. Now, when you purchase a direct connection, which I'm going to show you about in a few minutes, you're not exactly buying a straight wire to the cloud. It's like you're buying a wire to an internet point of presence, which then you're going to backhaul you back, and I'll show you that in a minute. So you connect to your direct connection location from your service provider, and then you get backhauled back to AWS. So, and there's going to be something called a letter of authorization required, and I'm going to walk you through that right now. So here's what it really is going to look like. To the right, we've got our on-premise environment. Got a router here, ideally multiple routers. And we're going to have a wide area network link to ideally 2 direct connection locations. So let's start with the bottom link. We have our own router sitting in a direct connection location. We buy a link to that. Now, we have to connect our router or layer 3 switch to the AWS router / layer 3 switch, and we need to run what's called the cross connect. What's a cross connect? It's a wire between our router and their device. And then the traffic is taken back over the AWS network. So think of this. On-prem is our data center. We have 1 or more routers that are connecting to each direct connection location. via a WAN link, like a 1 gig WAN link or a 10 gig WAN link or a 100 gig WAN link. We then connect to our router over the WAN link, just like we've been doing in networking forever. Nothing's new here. Between our router and the AWS router, we need to run a cable called a cross connect. And that cross connect gives you the permission, or your service provider the permission to run that cable between your device and the AWS device, because you can connect to this direct connection location to your router. You have no access to AWS that way until that router is connected to the AWS network and routing is actually established between them. So you're going to need something to enable your service provider to run this little orange cable between the customer router and the DX or the designated router, the direct connection routers for the service provider. So look on the bottom right. You can see direct connection location. You can see that little orange connection between our devices and the AWS devices. And in those particular cases, that's called your cross connect. And that's done by the letter of authorization. So you must get this letter of authorization prior to being able to run this. So let's talk about this direct connection, what this letter of authorization is. That it's the ability to connect that connection between your device and their device, just that wire. To receive this letter of authorization, you need to identify the region for which case you're going to be connecting to. Now, you'll request the letter of authorization either via the management console, the API, but also you could do it over the command line interface. And if your application is complete, what'll happen is AWS will provision the switch port on their layer 3 switch, although they're going to be laying layer 2 routing to you, and they'll let you run that cross connect. Now, what at that point is you download the letter of authorization, you hand that to your service provider, and they cross the cable for you. But remember, the cross connect's just a wire between them. Now, when we're dealing with AWS, we're going to get into concepts called public and private interfaces. Now, if any of you were involved back in 1996 working on Frame Relay, like me, or 1998 working with the ATM cloud, or 2001 dealing with the BPLS cloud, well, BGP cloud, RFC 2547 cloud, or the BPLS cloud, this is no different than the same 25-year-old networking technologies. Basically, you connect to a public virtual interface, and that will enable you access to public AWS services. Public AWS services are going to have a globally routable IP address, which means public, and you'll be exchanging information, routing information with BGP. Simple, simple, simple stuff. Now, AWS will not re-advertise your routes out, and by doing so, you don't have to worry becoming a transit ISP for the entire internet. You know, it's the same thing as setting up your routes in BGP and using the no export community so your service provider won't export your routes. Now, when you deal with AWS BGP, well, you've got some serious limitations. They won't take a lot of routes from you, basically 100, which is nothing. I connect to the internet in my house to 3 different internet service providers, and guess what? I take in 800,000 routes from each internet service provider. AWS lets you give them 100. It's nothing, nothing, nothing. So because of this, keep that in the back of your mind. So here's what I want you to understand what it's going to look like. Architecturally, I want to draw this for you. I don't want any confusion. I know many people are confused upon this, especially people who've taken others, AWS Advanced Networking courses, those that are taught by non-networking people, and they get so confused. I don't want you guys being confused. So realistically, all what's really going on is here, you've got your box over here. This is your box. So this is your data center. Then connect over here to the cloud. And what's going on is when you're connecting to, let's call it the cloud's router, you're going to connect to the virtual router in the cloud. Let's call it a virtual router, VIF, virtual interface. And now through this virtual interface, you can connect to, say, S3, or you can connect to any other multiple devices. So the way this happens, let's just see, AWS public service. Now we've got 2 S3 and another public service, SCRVICE. May not have spelled that right, it doesn't look right, but we're doing stuff live in real time. So basically what happens is we connect to this virtual interface, and they build virtual links, basically pseudo wires, for those of you that are familiar with MPLS pseudo wires, to all of their services. And in that manner, you're getting one connection to them, and they can basically create virtual circuits for you. Very reminiscent of the frame relay permanent virtual circuits or the ATM permanent virtual circuits. Same thing we're talking about. Nothing's new. But that's how these virtual interfaces work. Now the public ones, guess what? Connect you to public services. So let's talk about private virtual interfaces. Well, this is to connect you to virtual stuff inside of your VPC, your virtual private cloud, otherwise called virtual private data center. Some people like to call a VPC a virtual private network. That's insanity. Here's the reason why. It's a virtual private data center. It's not just your routing and switching and encryption in your VPC. It's where you put your servers and all the things that are part of your network, which is your data center. So of course, by using private or the private virtual interface, you can use private IP addresses. Now again, you can only advertise 100 routes over the session. So what does that mean? It means the people dealing with your IP addresses can't be like a DevOps engineer that's not a network engineer. Love DevOps engineers, but that's not their world. You need to have a really good network engineer, a really good network architect, or a really good cloud network architect set up your routing. If your routing is wrong and your IP addressing is wrong, it's going to be like a city that was planned without streets, where you're trying to stick in streets after the fact. We've all been there. We all see how bad it is. So you got to have a very senior person deal with your IP addressing, subnetting, and supernetting. We'll be doing a free AWS Advanced Networking course, and I'll teach a lot more about that. Of course, if you really want to learn that, this is the kind of stuff we teach in depth in our cloud architecture core development program, the things that are really out there in deep depth, because that's architecture, whereas this is more certification materials. So let's talk a little bit more about link aggregation groups. I love link aggregation groups for the following reasons. Link aggregation groups enable you high-speed connectivity, and they remove single points of failure. So high performance, high availability. This is about as good as it gets, everybody. So if you wanted 20 gigs of network performance and you've got a 10 gig link, well, you got a problem. Now you could take two 10 gig links and set up a beautiful BGP policy and load share one subnet on one link and another subnet on another link, and that would be perfect. Or you could put two links together as a single link. And by putting your two links together as a single link, it simplifies the routing because it's going to look like one IP address on both sides. We don't have to deal with the challenging switching things like with regards to spanning tree or rapid spanning tree to promote loop avoidance. It's quite simply basically just multiple wires bundled into a single wire. And if those of you are around long enough for ISDN and multi-link PPP, it's identical technology, but with Ethernet instead of point-to-point connections. So we can bundle links up to 4 of them as long as they have the same speed, performance, and latency. So what's it going to really look like? Here's in this environment, we've created 2 link aggregation groups across 2 routers to 2 direct connection locations. Now in this particular environment, look at it this way. If on the top link aggregation group, if either one of those links goes down, the link is still up and we still have 10 gigs of bandwidth. So in this case, we've got 20 links on the gig, 2 10 gig links on the top, and 2 10 gig links on the bottom. Lots of performance, lots of capacity, and of course, higher and higher availability. And when it comes to organizations that are totally dependent upon technology, it's all about high availability, because if the systems aren't there, we don't need them. So before we get back to the content, give me a hashtag AWS Certified Solutions Architect Associate in the chat box. That way I know you're there. If you've not subscribed and hit the bell, please do so now. If you're having a good time, please hit the like button. It'll signal the algorithm that we're doing a good job, and we can get more of our free content to those people that need it most, especially those that can't afford training. We want to make sure that we help all those that need training, that are looking to pass the AWS Certified Solution Architect 2022 free training with our free full AWS course. And now let's talk about storage on the cloud. Love talking about storage, I really do. So what is storage? It's where we keep our stuff, right? Okay, so Storage is in the environment where organizations are going to keep their data. Now, when we get into storage, we're going to be dealing with volatile storage and non-volatile storage. And I'm going to tell you right now that storage is an absolutely critical component of your virtual private cloud environment. So we're going to be talking about block storage, object storage, file storage. Instead of just going into the AWS terms, I want to make sure you understand these types of networks, because as an architect, you're going to have to architect around them and their weaknesses. And if you're a cloud engineer, it's not going to be good enough to know how to click a few buttons. Anybody can do that. You're going to have to know how do you get around the performance problems of block storage. Why can't you use object storage for attaching it to a system? Why are these services used? So I want to make sure you understand it, because I want you all to get cloud hired someday as either cloud architects or solution architects or cloud engineers. So we'll begin with block storage. Block storage is non-volatile, which means it doesn't go away with system reboot or instance termination. And why do organizations use block storage? Well, block storage is a very common type of storage area network. What is a storage area network, everybody? It's basically a network full of machines called RAID arrays filled with hard drives that are attached to a network. That's it, it's network attached storage. Now, why do organizations like block storage? Well, for a couple reasons. Block storage decouples the server and the storage environment. What do I mean by decouples? In a traditional server, your storage is limited to what's inside of those hard drives in the server. But with block storage, you can have your storage, a kilometer away, and you can have your servers over here, and they can access it via the IP network, or via fiber channel networks in the physical data centers. But by doing that, we're not limited to the storage that's inside the server. So for a cloud provider, it means they can have data centers just filled with storage and connect them to a data center filled with servers, or vice versa, or put in the stuff anywhere they need it. Now, when you're dealing with this with block storage, in the storage area network, your data is taken and broken down into little blocks. And each block is going to have an identifier. What makes it even better is your blocks can be stored anywhere on the system, anywhere on the network, which means it's going to scale fast. And it's very dependable. And being decoupled, it enables your systems to grow. So I like to look at it in this visual environment. To me, I always looked at it and pictured it kind of like a calculator in my head. What do I mean by a calculator in my head? Look, in this particular environment, we've got our systems, and our data is listed as 0, 1, 2, 3, 4, etc. And that's how we can identify our data when we need it. We'll get into the AWS specifics of these storages after we do a quick overview of the data center technology. Now, while we're at it, let's talk about object storage. Object storage is a type of storage area network where your data is taken and broken down into objects. Now, object storage is very unique storage because each object has metadata. So what's metadata? It's data actually about the data, which is so cool. So when you're dealing with object storage, if you want to find something, you can query the metadata and find it much quicker. Now, because we've got metadata, we can start thinking of big data environments, data lakes, which we'll talk about, and the ability to basically take your data, categorize your data, and query your data. And in most cases, with block storage, we can even use SQL queries like we could in a database. Now, object storage, we've got to be very clear on this, is not normal storage. We can't mount it via a regular server like we could with traditional storage. It's good for static files. The reason we can't use it by a regular computer is as follows. Every time we deal with a new modification of a file or an object, it's going to create a new version. So imagine, for example, we tried to use object storage and mount it to a server. A server with 192 cores and 6 terabytes of RAM. Now that server will have a 9 terabyte swap file. The swap file or virtual memory is typically 1.5 times the RAM, the DRAM in the system. Now that swap file may change 100,000 times per minute. So if we were to try to map a swap file on object storage, we might have 100,000 9-terabit objects per minute. Now, obviously, that would cost an organization millions of dollars a month for that kind of storage. It would bankrupt them. So object storage is good for software archival purposes, backups, static web files, static website hosting, and things. So the way I like to view it is this. Object storage is flat storage, meaning basically you got your data and something like a database pointer pointing to the data, and it looks just like this. Got a bunch of objects just sitting there with information pointing to the objects and these little pieces of metadata or data about the data, which you can see as little diamonds at the top. That's the way I visualize object storage. Now we'll talk about file storage. This is what you've got in your computer. If you're using a Windows system, it's NTFS, for example. If you're on a Mac, it's the Apple file systems, or whichever file system they're using at the time. It's traditional storage. Now also, if you've got a Windows machine and you click Share Folder, it becomes a file server. So file storage is either the hard drive that's in your systems, your physical hard drive, or you take a Linux machine and you share a folder and you create an NFS or network file system share. On a Windows system, it's a server message block share, pure file storage. And file storage is hierarchical. So typically speaking, here's the way it's going to look like. You're going to have a parent folder, and inside your folder, you're going to have another folder, and that's where you store your stuff, like many of you have them in your environment. And now let's talk about object storage on AWS. What's that called? S3. Now, I want you to understand this. This object storage is the same that you would buy from Dell EMC in your data center. It's the same stuff Microsoft calls blob. It's the same stuff that Google calls cloud storage. It's the identical technology. It's 20-plus-year-old technology. It's not new. And now you understand how you would use it on any cloud. So now let's talk about what is Amazon Simple Storage, otherwise known as S3. It's AWS branded object storage, no different than anybody else's object storage. It's integrated into a tremendous number of AWS services. AWS would call it high availability because they'd say it's 99.99%. I don't necessarily consider that to be high availability because that means you're going to have basically 50 minutes of downtime per year. So you could call that high availability. The customers that work with me would never call that high availability, but you know, it's your definition of high availability. I'm fine with 99.99% high availability for Go Cloud careers because we're not mission critical. But in a hospital or a bank, millions of dollars could be lost with this, and a hospital, people could die like this. So it depends on your needs. Now, what I will say is AWS S3's durability of your data is truly remarkable. It's 99.9999999% durable. What does that mean? It means that even if I can't access it when I need it, AWS's systems are so backed up and so well that the chances of me needing it or not being able to retrieve it later are basically zero. 99 to 0.999, 11 nines durability, which means 99.9 to 9 decimal places out available. So this is truly extraordinary. And of course, if something goes on, you'll be notified by EventBridge. So when would we use Amazon S3 or Amazon Object Storage? Well, to back up and archive our organization's data, for static website hosting, for distribution of content, media, or software, for disaster recovery planning, like I could take my whole data center, back it up to object storage, stick it in a cloud provider, or for big data analytics when we're talking with things like data lakes, future machine learning projects, et cetera, et cetera, et cetera. We're intentionally not using the branded names because I want you to know what this is no matter what cloud you are. So that's where we're going to talk about the concept, because nobody's going to care if you go on a job interview if you know the names of the services. What they are going to care is, do you understand how they work and do you know how to use them? On your exams, you need to know the name of the proprietary services. So when you're dealing with S3, you understand that basically what's happened is it's organized into buckets for you, the user, to look at it. Now, in reality, it's flat. environment where basically there's the data and a URL pointing to the data. But that's just for us. But for us, that we can put it in a bucket and make it feel good. The bucket is really just a container for our stuff that's stored on AWS 3. What'll happen is the buckets are given a top-level namespace, which is basically speaking a fully qualified domain name. ec2.gocloudcareers.com, fully qualified domain name. We'll get into that in more depth with fully qualified domain names when we talk about DNS, and we're going to cover that heavily and all the routing types when we get to that section. Now, when you name a bucket, it can have upwards of 63 characters, including letters, numbers, and hyphens and periods, so we can be pretty descriptive about it. But remember, the path where you store this stuff is not necessarily where the actual object or file is located. Now, the URL that's used to access your file, again, is just a pointer in the database to where it's truly stored. S3 is a lot like a database behind the scenes, as is all its object storage, in that you've got your data, you've got a pointer to it. And here's the good news. Because it's so much like a database, you can run SQL or structured query language type queries or searches on your data. Now, an organization can have 100 buckets per account. And if you need more than that, all you need to do is reach out to AWS support, and they'll give you a bucket increase, so you can have more buckets. So let's talk about securing your data. You're going to have two options. You can run a bucket policy, which is the preferred method, because it's very granular and it's based on identity and access permissions. What is identity and access management? Who are you? What are you allowed to do? And then logging what you did. We'll talk much more about that when we get to the security section. Or you can use those same Unix, Windows, ACL-based permissions, which are basically read, write, and full control. So it matters. I'm going to tell you right now that lack of understanding of object storage, it causes most of the hacks on the internet. 16% of all cloud hacks are related to misconfigurations. Anybody can configure this with 3 minutes of training. What they can't do is know what to configure and why they're configuring this, which is exactly why we're focused so much on the concept. Like I said, you can do those free lab downloads, sign up and do all those labs and practice them. But if you don't understand what it is, you don't pass an interview. And for the solution architect or the cloud engineer, knowledge of how the systems work is the most critical. Now we're going to talk about different storage classes on S3. And why is this? Depending upon your needs and your performance, there'll be different options for your object storage inside of S3. By doing so, the whole point is to get the lowest possible cost for your demands or your customers' demands. And in this section, we're going to be talking about a lot of object storage options. We're going to be talking about S3 standard, your highest performance. We'll talk about S3 and frequent access. Then we'll get into the scariness of S3 and frequent access one zone, which was reduced availability storage. Then we'll get into S3 intelligent tiering. Then we'll get into Amazon S3 Glacier Flexible. And of course, we'll deal with Amazon S3 Instant Retrieval as well. So what is Amazon S3 Standard? Basic, simple object storage. It's high availability, or at least 99.99% available, which some people would call high availability. It's incredibly high durability, that 99.119 durability, which means 99.9 to 11 decimal places. The performance of it is acceptably good for most applications. And it's what you use for frequently accessed data. And here's the reason. If you're going to be accessing your data, you can access it as much as you want. They don't pay you to pull your data. Once it's stored there, to put it there or pull it there. If it's transferring the network, yeah, there will be. But in this case, that's going to be your cheapest option in most cases. So while we talk about S3 storage tiers, let's talk about the next option, infrequent access. Now, again, this gives you your same availability and durability as before, and performance. Now, if you're using S3 standard and frequent access, you're going to pay a lower rate to store your data, which is great, but you're going to pay to retrieve your data, and your data is instantly available. So imagine it this way, and we'll talk about lifestyle security, lifecycle policies and why and how they can be used to optimize your customer systems. But here's what we're dealing with. S3, you pay less, but then you got to pay to retrieve your data. Now, here's the thing. If you're not retrieving your data a lot, it's cheaper to use S3. But if you're pulling your data constantly, it's too expensive. So this is for data that's infrequently accessed. And we'll show you lifecycle policies before and how you do this to really save an organization money. And this is one of the things that's transformational in the cloud. Now, the next access we're talking about is S3 and frequent access one zone. This terrifies me because now you reduce the availability of your data, which means when you need it, you're not going to find it as easily. Now, when you deal with one availability zone, you're typically dealing with 99.9% performance, which for the most part is 1 day of downtime per year. So if you can tolerate that, it's cheaper, if you can tolerate it. And that's kind of our thing. Now, while we're dealing with this, you get the cheapest pricing, but you got to pay for your data. And the availability is going to be substantially less. So keep that in the back of your mind. And then there's something called S3 intelligent tiering. This is the auto magic thing where AWS monitors your data and they automatically place your data on wherever they think it's the most cost-effective performance for you. And this is cost optimization managed by your service provider. Well, I think that's like having the fox guarding the hen house. They're going to optimize it for you, the people that are getting paid to do it. So, it's a service. It's a machine learning-based service that may not be great for you, but kind of keep that in the back of your mind. If you know your data and your usage policies, it's probably best to create something manually. Now, if you're looking for really low cost, we've got S3 Glacier, which is good for long-term storage. In fact, it's where you put your stuff and you pay less to have it there. Now, it's instantly retrievable. And as a rule, it costs 68% lower than S3. But to retrieve it, now you're dealing with some heavy-duty retrieval fees. Kind of keep that in the back of your mind. But if you don't retrieve your data for at least 98 days, then guess what you got? You've got much lower cost, up to 68% lower. Now let's talk about S3 Glacier. Flexible, that's traditional Glacier storage, meaning you pay less to keep it there, but it's not instantly available. In fact, you've got this really cool thing called the vault lock option, which makes your data immutable. So let's think about that and making your data immutable. If your data is immutable, it can't be changed. So for a bank that needs to store their customers' records, the Glacier Vault, lock option, beautiful. For a medical facility that has to store their patient records for 7 years, Glacier Vault puts it in a place where it can't be modified. Brilliant, brilliant option for the right places. Now, this is designed for information that's going to be accessed 1 to 2 times per year. If somebody needs their data, they can retrieve it in minutes to hours, and it's really low cost. It's going to be even 10% less than Glacier Instant Immediate Retrieval. And you can pay for the data retrieval, but you're going to have to request information when you're done. Now, when we're dealing with SC Glacier Deep Archive, remember, it's the lowest cost, but it's designed for stuff that you don't need within 12 to 48 hours, because that's how long it could take to get it. And your data is going to be stored in 3 or more availability zones, and it's designed for long-term storage of highly regulated industries. So let's talk about lifecycle management, and I've got a visual that we'll use for this. What are we dealing with here? Let's say an organization knows their usage flows of their data. Let's say that the organization knows they have data that they're going to frequently access for 30 days. So they're going to put it in S3. Let's say for the next 30 days, that information is going to be accessed just a little bit. Guess what? That's terrific. They can put it in infrequent access. Let's say 30 days later, they're never going to use that data ever again. But they want to store it for archival purposes, maybe future machine learning purposes, maybe, backup purposes. Maybe they need it for regulatory environments. So that's what a lifecycle policy is. We can manually set it up, minutes, it's simple to do. Stick your data on one, migrate your data to the next, and have it automatically managed to pay the lowest price based upon an organization's uses of their actual data. So, while we're at it, let's talk about S3 versioning. You gotta love when a manufacturer or a brand like AWS decides to create a feature out of the natural functionality of the technology itself. So when you're dealing with object storage, all object storage automatically creates new versions every time something's modified. Now, of course, the cloud providers have taken big gains to prevent that from happening, which basically means they know that their customers would be really upset if they filled up their systems and got multi-million-dollar bills per month because their storage got there. So they automatically delete old versions. But if you want to basically keep all copies of something, you can turn on S3 versioning, which is the default behavior of object storage anyway. So let's say I wrote an example, the CSA doc, Certified Solution Architect.doc. And let's say I worked on it for an hour, saved it, I'd have version 1. Then Alonzo from my team worked on it for an hour and it's version 2. Then Chow worked on it for an hour and it's version 3. Then Chris worked on it for an hour and it's version 4. Now Eddie, who's in Cameroon, worked on it and it's version 5. Leo, who's in Brazil, worked on it, it's version 6. By doing that, you would store each version. And why is that good? Well, if version number 642 got corrupted, you can go back to 641 and you still got something. So that's what versioning is. And it's the default behavior on all object storage platforms. Now, let's think about security of your data. Now, there's 2 ways that you can use your data. I could just let you delete a file directly from my object storage bucket. No big deal. Simple, 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 easy to do. But imagine that. So let's say we're talking about Super Chow. Chow is this rock star cloud architect on my team. She's amazing in every way. Let's say she was mad at me one day and she just wanted to delete a file. And she deleted the file. Chow would never be mad at me. She would never do this. She's amazing in every way. But, here's that. Now, if we had multi-factor authentication delete set up, Chow tried to delete a file, and I would get sent a challenge, and they would ask me for a one-time password. Now, I could provide that one-time password, and that file would be deleted, or I could not provide that one-time password, and the file stays there. So that's when it works. Multi-factor delete, multi-factor authentication, again, is nothing new, and it's done to prevent other bad actors from doing it, or you yourself. How many times have you accidentally deleted something and then I had to go into the trash can to pick it up? I've done it before. So that's the point of multi-factor authentication delete, but it also gives you protection from others. So let's talk about organizing our data into S3. When you organize it, remember S3 is flat. You just put your stuff in the object storage. And the reality is there's a database pointer pointing to it. But that's going to be hard for the user to use. It's going to be tough. But we can use what's called the delimiter, which is a pointer to our data. And by doing something like that, it can feel logically organized like a folder. I'm going to put one right now, a basically fake one that I just made up in the chat box so you can see it. So here, if I use a delimiter, which I did in the chat box, Mike/2020/AWS video/storage/s3.mp4. But I popped in that chat box, you can see it looks and feels just like a Unix path. Well, it's not, but I can make my users feel like they're using traditional storage. And this is the same thing that happens if you use Dropbox or Google's cloud storage or anybody else's storage. It's all the same because it's all object storage. The Apple Cloud is all the same. iCloud, for example. Now, if you're going to have your data on S3, and somebody were to break into AWS and steal their hard drives, for example, your data would be there, and that would be bad, bad, bad. Now, of course, your data would be spread across RAID arrays, which make only partially the data active, but still, that's a problem. So you're going to protect your information with encryption. And encryption basically takes something and turns it into something that's not usable unless you've got the decryption key. Kind of like those old serials where you'd have a message and you need to buy the box of cereal to get the secret decoder ring to read it. It's the same. So we're going to protect our sensitive data with encryption. And encryption will make your data completely unusable without the decryption key or that secret decoder ring. Now, there's lots of forms of encryption throughout history. There's a martial art called capoeira in Brazil, and that was designed not to look like a martial art. There's languages like patois in the Caribbean, which were languages which were a form of encryption that certain people would understand how to speak and others wouldn't. Now we've got encryption via IPsec, SHA-256, and many other encryption algorithms. Realistically speaking, that's all we're talking about. Now we can encrypt that on the client side before we send it somewhere, or we can encrypt it on the storage server, and we're going to be talking about them. Now you'll definitely see this in the Certified Solution Architect Professional exam. You may actually see this in the Certified Solution Architect Associate exam as well. The first type of key encryption we're going to be talking about, and I didn't make up these terms up, is SSE-KMS. Again, I don't make up these names. And this is realistically a customer managed key within the AWS key management system. Now, this is a complete key management system, meaning the user manages the master key and the key management system controls the data key. And this provides a beautiful audit trail of how, who, and when the data was accessed. And it's going to look, realistically speaking, like this. Got the AWS key management key. There's a customer managed master key. And then data key is used to, basically speaking, encrypt your data. Simple and effective. Now let's talk about another version. And again, I didn't make up this term. SSE-S3, AWS Managed Keys. Now this is an incredible complete key management solution. Now, it's not going to be for ultra high security environments where you need control of your keys. But for most people, this is simple and elegant. Basically, the key management systems will manage all keys. It will automatically rotate your keys, and every object is going to be encrypted with a new encryption key. So wow, you implement this solution, the computer system automatically manages it for you, and you know your data is safe and secure. This is probably one of the best solutions for average organizations. Not good if you need military grade security or things like that, but under normal environments, this is simple, elegant, and really effective, and it reduces your overhead. Let's look at it this way. Basically, we've got the key management system. It literally manages the master key. It manages the data key, and everything is done for you automatically, as they like to say. And no, I never would use the term automagic, but lots and lots and lots of people like to use that term in tech, so I thought I'd give you something that would be a little fun. Now, the next option we have, and this is going to be what's going to be used in your critical environments, military grade security, is something that's going to be called SSE-C, and this is really customer provided keys. Now, this gives the customer complete autonomy over the encryption keys. The customer is going to manage all their keys. Now, here's the downside of that. Lots of actual key management going on here. Kind of keep that in the back of your mind. So how do we optimize and tune S3? Well, we're going to talk about pre-signed URLs, multi-part uploads, range gets, as well as cross-region replication. So what is a pre-signed URL? Let's say I want to send Superchild, the amazing cloud architect, some information. I've got two options. I could give her the keys to get into the system, or I could pre-sign the URL and send my pre-signed URL to Superchild, the amazing cloud architect. So how would I do this? I sign the object with my own encryption key, and I send that URL directly to Chell. The URL is a fully qualified domain name. She could click on this, and then she could download the photo of my cat, which is probably what I would send Superchild, a photo of my cat, because I love to send photos of my cats to everybody, especially the people on my team. Still love my cat. But by doing this, by pre-signing the URL, I'm giving Superchild secure and temporary access to my content. Now, how long is this content actually available? Well, it depends on the method that I actually sign it. So if I sign it with my IAM instance profile, again, identity and access management is, who are you? What are you allowed to do? And what did you do? And we'll talk much more about that when we get into identity and access management. But if I sign it straight with my profile, it's good for up to 6 hours. Now, if I use the security token service, and I promise you we're going to get into a lot of detail of the security token service when we get involved with security and identity and access management, then it's going to be good for up to 36 hours. Now, what if I sign it with an IAM user? Name and shall is an IAM user of our systems. Well, you can have access to that link for up to 7 days. Or I could issue a temporary token, and I love temporary tokens, and here's why. I give something, it's available for a short period of time, then it's not available, and poof, it is done. And that's why we really love these things, the AWS temporary tokens, because somebody steals your token, they can only access it for a short period of time, and then we're back to normal. Now let's talk next about multi-part uploads and what they are. Well, with S3, we can deal with a file size that's up to 5 terabytes, but we can upload a file up to 5 gigabytes. Now imagine this. You send 4.75 gigabytes over the wire, and the network connection goes. Do you know what's lost? All 4.75 gigabytes. And that's not an efficient system. It would be much more efficient if we could send little bits and parts of the file and then reconstitute it in the end. See, there's so many things that can go wrong with large file transfers. And that's why AWS recommends you use a multi-part upload for all files over 100 megabytes. And let's look at what that actually is. Again, it's a very, very simple concept. We've got our file over here. Our file gets split into multiple parts, and it gets put back into the big, beautiful file, the same file it was in the beginning, and then sent to object storage. Why do I love this so much? Why is this so great? Because let's say from the top to the bottom, you've got 4 file parts. Let's say file part 3, which is the second one from the bottom, gets lost in transmission. By doing so, we don't have to retransmit the entire file. We only transmit file part 3, which is the file part that was lost, making our transfers more reliable and more efficient. And that's why we use multi-part uploads for all files that are greater, or uploads that are greater than that are greater than 100 megabytes, making sure we don't have network transfer problems. So let's talk about the last one, which is cross-region replication. When we're dealing with cross-region replication, what we're doing is we're taking our data stored in one region, which again is just a large geography, and replicating it to another one. Why would we want to do this? Well, if I'm in the US East region and I replicate to US West, well, guess what? Guess what? Then if US East dies, I still have US West. But what else are we talking about? When we're dealing with cross-regional charges inside of the cloud provider, they charge you to send your data across regions. And let's say you had some object storage. It might be cheaper to keep your object storage replicated in 2 different environments than it would be to pay all those inter-region charges. Again, this is 100% based upon the use of your data, the specific use case, and where your users are accessing things. But cross-region replication gives us good disaster recovery abilities, but it might be cheaper if we're dealing with a lot of interdepartmental transfers, and if we're dealing with users in Japan and then users in New York City. By replicating the region, the information from region 1 to region 2, the users in Japan are going to get fast, low latency access because they're not going to be traversing the entire AWS global network to get it. They're going to go to something in Japan. Likewise, the people in New York or New Jersey could go to the bucket in the region that's closest to them. So that's why we're dealing with this. So we talked a little bit about storage area networks. We're going to talk more about storage area networks today, get into instance storage and block storage and all kinds of cool, exciting stuff. So now we're going to talk about instance storage. So what is instance storage? Well, if you've got a virtual machine or a server, it's the storage that's sitting inside your server. Now, here's the thing. It's fast, real fast, real fast, real fast. fast, 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 fast. How fast is instant storage? Well, let's put it into context. We're going to be dealing with EBS block storage. The fastest storage volume you can get is 250,000 IOPS. Now, you can go to Best Buy for about $100 and buy a Samsung 980 Pro, which gives you about 1 million IOPS, which is 4 times the fastest block storage. Now, when you're dealing with instant storage, what you're dealing with is a RAID array. It's typically 8 of these drives in a RAID environment. So you might have 6, 7, 8 million IOPS just sitting inside the server. So instant storage is fast, 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 where block storage is slow, 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 slow. So why don't we use instant storage? Instant storage. And here's the thing. The thing is as follows. Whatever you store in instant storage is deleted upon instance termination. So unlike your data center where you store your stuff in the NVMe RAID arrays that are sitting inside of your servers, in the cloud, every time you delete your system, it's all gone and you lose everything. So this makes it not feasible. So that's why we need to get really, really, really through what we're talking about here. So let's talk about elastic block storage. What is block storage? Block storage. It's the same block storage that's been around for 20 years in every data center in the world. It's nothing new. Why do we use block storage? As we talked about before, it decouples your servers and your storage environments. And by doing so, it means that the data centers can scale easy. Now we're going to mount block storage in our devices. And remember, block storage is slow regardless of what's taught in your certification course. It's going to act like a virtual hard drive. So what are we going to use it? We're going to be sticking it on our virtual machines, which are otherwise called on AWS EC2 instances. Azure calls them virtual machines. Google calls them compute engine instances. It's identical technology as all clouds for the most part are the same thing. Network in a data center has been virtualized, where they have new names for the same technologies. So block storage is scalable, real scalable, and it's not deleted upon instance termination. And this is high availability storage, And what we're talking about this is, it's 99.999% available, which means it's there when you need it, except for about 5 minutes and 15 seconds per year. That's relatively good high availability storage. Having said that, no cloud provider has been 99.999% available for the last couple of years. So it's really not going to be anything that's that high availability in practical purposes. But according to the exam, it's 99.999% available. And let's teach that. Now, on your exam, you can think of block storage, which AWS likes to stick the term elastic before, and they call it elastic block storage. They'll sell it for high throughput and high transaction workloads. It's the best you can do on the cloud. And we're going to teach you how to work around the weaknesses of block storage too, because it's so critical. With block storage, you're going to get multiple performance options, all slow, but compared to data center technology, but some are slower than others, and some are cheaper than others, and some are more expensive than others. So basically, block storage is going to be associated with a single availability zone or data center. And basically, realistically speaking, it's going to be backed up to another availability zone or data center. So that's good news. What's in one data center will be copied automatically to another data center. Now, what's also very, very, very cool is the way your block storage is automatically going to be backed up in terms of snapshot. Why is this so cool? It will be transferred to object storage. Whoa. So your block storage automatically gets sent into S3 or S3 Glacier, wherever you want to pop it. And now, wow, if something happens to your systems, you've got another one. Now, these EBS volume snapshots are truly, truly amazing, because it's not like you ran backup software and you backed up, and backed up stuff, okay? That's not what we're actually talking about. It's a full system image, like a ghost image or a system image that can literally be rebooted, which can be just relaunched, and then poof, a virtual machine will come up with the identical hard drive and everything else you need. So AWS gives you some of the most brilliant and beautiful backups. All the other cloud providers do too, but this is simple and elegant, and typically speaking, about 1,000 times better than most organizations and enterprises' backup strategy. I love this. So how do you choose your EDBS volume types? Well, it's going to be your performance requirements, and your performance can be trained as both latency and throughput. And they're not the same. So latency is going to be measured in input operation and output operations per second. What does that mean? How many times can you read write to the disk? Read write, read write, read write. The higher the number of read write activities you can do per second, the lower the latency. By comparison is throughput, which is how much stuff can you move per second. I like to use vehicles to explain the difference between latency and throughput. So let's say I'm here and I want to take a car full of cat toys from Palm Beach, Florida to New York City. So I get in my car, I shove my car full of cat toys. And my car is, let's call it a sports car. It's not, it's an SUV, but it's a high performance SUV. So let's say I shove my SUV full of cat toys and I get to New York City. Now the reality is, to New York City, I can drive my car probably at 100 miles an hour before the police stop me between Palm Beach and New York City. And I'm going to get there relatively fast. My car is designed to be driven on the left lane of the Autobahn where there's no speed limit. But let's say I wanted to drive between Palm Beach and New York and I could average 100 miles an hour. The latency to get to New York is going to be lower. Now, by comparison, let's say that my buddy owns a tractor trailer and he shoves this tractor trailer full of cat toys. Now, he drives that tractor trailer at 70 miles an hour between Palm Beach and New York City. When that trailer gets to New York City, look at the stuff that it carried. Every cat in New York and New Jersey is going to be having a party time with their cat toys versus my SUV that may take care of, a couple of cats in Brooklyn or Manhattan. The throughput is greater in the tractor trailer. The latency of the car is faster. So now you know what latency is, the speed that you can do something in terms of input output per second. How fast can you get somewhere versus throughput is how much stuff. So input and output operations per second, which is inversely correlated with latency, is going to be measured in IOPS. And throughput is going to be measured in the amount of stuff you can move. And that's going to be in gigabits per second or terabits per second or megabits per second. So when we go through these things, we're going to talk about latency and throughput. Now, the fastest block storage you can get in AWS is EBS provision IOPS. It's called IO2. This is their highest performance SSD storage. They consider it the lowest latency, and it's designed for workloads that require high input and output operations. They'll tell you it's good for large databases. They'll tell you it's good for applications requiring low latency. And they'll tell you it's good for 4,000 megabit per second, which is decent throughput, actually. And a 250,000 IOPS, this is acceptable. Now, this is nothing like you can get in your own private cloud, like with Nutanix Cloud, for example, where you're running all of this stuff. All of this stuff. And in these particular environments, that's what we're talking about. So, 250,000 IOPS, not very fast, but relatively quickly. It's going to be a problem in many business applications because it's still too slow. And that's why we're going to talk about RAID. RAID is not covered in the Certified Solution Architect Associate, but you need to know it for real life. It is also covered in the Certified Solution Architect Professional. So we're going to be explaining that to you when the time comes. So this is the fastest. It might be a few $1,000s per month to get this. And mind you, it's going to be slower. That $150 drive you could buy at Best Buy, like a Samsung 980 Pro. Now, by comparison, the old fastest drives that we can use EBS volumes, it's about 2 years old, were the EBS Provision IO1 devices. And that's going to be, relatively high performance. And I say that, with cringing. SSD storage is designed for low latency. It's designed for workloads requiring high input and output operations per second, like databases and applications that require low latency. Look, the max you can get here is 16,000 IOPS, which is nothing. But it's the second fastest block storage you can get on the cloud. The throughput on this thing is acceptable at 1,000 megabits per second. Look, that's not going to be problematic for most applications, but you're going to have massive problems when you're dealing with, low latency in these environments. Now let's talk about general purpose SSD. Instead of these other drives, which are based upon non-volatile NVMe drives, this is going to be based on traditional SSD storage. Now, when you're dealing with SSD storage, you get decent throughput. You get much lower latency, which means higher IOPS than magnetic storage, but much lower than you're going to get from NVMe. Moderate throughput, like 250 megabits per second, which is what you get a little better than a standard magnetic hard drive. This is fine for a transactional workload. It's good for a development and a test environment because it's cheap and it's relatively low latency, we can call it that. And now we can get into our magnetic storage options. Now, this is an interesting one. We've got EBS throughput optimized hard drive. Relatively low cost magnetic storage. Because it's magnetic, it's going to be high latency, which means low IOPS. Now, the throughput on these things isn't bad, 500 megabits per second, which is right up there with the standard SSD drive, because these are obviously sitting in RAID arrays. So this is really good for a frequently accessed workload or a throughput-intensive application like video, for example. It's great, great, great when it comes to throughput-intensive workloads like a video editor would use, transferring large video files. Great for large log storage, great for sequential reads and writes. So kind of keep that in the back of your mind. And then the next option is EBS cold storage, which is going to be your lowest option, low IOPS, low throughput, 250 megabit per second, and it's going to be used for workloads that are not accessed frequently. Now, because I told you right now, look, what are you going to do when you have a business application that requires 2 million IOPS on the cloud? Well, you don't get high disk performance on the cloud. So the only way you can work around it is either use a private cloud like OpenStack or Nutanix in your data center for your high performance latency sensitive applications and use the public cloud for non-latency applications. Or if you're going to be on the public cloud, no big deal, use RAID. So we're going to do a brief introduction of RAID. And then from there, you know, where are we going to go? We're going to go into things. So what is RAID? RAID, or redundant array of inexpensive disks, is really a means to combine multiple hard drives into a single hard drive for multiple performance. And they're still going to be separate drives, but we're going to take separate physical devices and logically associate them as a single device. On the cloud, everything's virtual. We're going to have virtual block storages, and we're going to combine them in the same manner. So there's going to be multiple performance options for redundancy. And there's going to be 4 main RAID types that the entire world uses. Now, we're going to be dealing with 0, 1, and 10 on the cloud, not RAID 5. But if you're a cloud architect or a cloud engineer and you're going to be moving stuff from the data center to the cloud, you better know what RAID 5 is because it's used everywhere. The only reason we can't use RAID 5 on the cloud is because the cloud storage is so bad in terms of performance with regards to latency. We can't deal with the additional latency overhead of RAID 5, but widely used in the enterprise. So let's talk about RAID 0. RAID 0 is called striping. And I'm going to show you what that looks like. But basically, you're going to be taking your data to multiple hard drives. Right to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And by doing it, you're load balancing the load across multiple drives. When you load balance, you get lots and lots and lots of speed. Lots and lots and lots of speed. Because of that, you're there. So when you do this, you get no fault tolerance either, because if one of the drives in your RAID array fails, you lose everything. So no fault tolerance. But it's good when ultra-fast speed is needed. But if you're going to use RAID 0, back up, and back up some more. So what's it going to look like? It's going to look like as follows. Store your data from block 1 on drive 1, block 2 on the next drive, block 3 on one drive, block 4. By doing this, you're going to get twice the throughput and lower latency. So great way to accomplish around this. You've got 250,000 IOPS drives in the cloud. Now that will equal to what you can get from that $150 drive at Best Buy. Now, of course, it might cost you $30,000 on the cloud to equal the performance of a $150 drive from Best Buy, but you can still do it. Like I said, it's all about knowing as an architect, where do you put your stuff? How do you architect it for maximum performance at the lowest cost? And what drives that? The business requirements, nothing else. That's why business acumen is so critical for the cloud architect. So let's talk about RAID 0 in the cloud computing environment. It's a little less bad than the normal environment, and here's why. In the normal environment, if one drive fails, you're done. But you got to remember, these aren't actually physical drives. They're virtual drives that are high availability, so they could be a little better. RAID 0 is generally too risky for the enterprise, unless we're going to get into RAID 10. Exception is temporary storage. Video editors use RAID 0 all the time. When I used to edit my own videos, I had my own RAID array that was RAID 0, and I backed up to a RAID 5 RAID array. The good news is that we can back up our RAID 0 into a single availability zone. And because they're logical rhymes, it's less risky, but still it's too risky for use for production environments. Now this gets us into RAID 1, which is going to get us into some really cool availability, and it's the secret to RAID 10, which is coming up. Now RAID 1 is disk mirroring. What's mirroring? 2 hard drives in the system. Whatever gets written to hard drive 1 gets immediately copied to hard drive 2, and that way if hard drive 1 fails, you just break the mirror and use the other hard drive. It's brilliant in terms of redundancy, but it's slow, it's expensive, and it has low capacity. And here's what I mean by this. Normally in RAID 0, you've got 4 2-terabyte hard drives. Guess what do you have capacity? 8. Here you've got 2 4-terabyte hard drives. What do you get? Capacity-wise, 4. Because you're getting one and it's backing up to the other, and that's it. So what's this look like visually and architecturally? You've got 2 drives, hard drive 1 and hard drive 2 here. All the data from hard drive 1 is exactly mirrored and copied to hard drive 2. I've got no throughput benefits, no latency benefits, and no storage increases, but I've got brilliant high levels of availability. Now let's talk about RAID 5. RAID 5 is really the best of both worlds. You can't do it on AWS because the storage is so slow, they won't let you. RAID 5 gives you speed and redundancy. RAID 5 is considered striping with parity. And it's high speed and it's highly redundant. It's used by 99% of all enterprises, some form of RAID 50, RAID 60, or even RAID 5. What does this look like? Here you go. We've got our block, let's say we split it amongst 4 drives. If we've got 4 4-terabyte drives, we get 12 terabytes of total capacity, because what's going on is as follows. We lose 1 drive to redundancy data. So here we go. In this environment, we basically copy block 1 to drive 1, block 2 to drive 2, block 3 to drive 3, and we put backup or parity data on drive 4. The next time we write our data to block 1 on hard drive 1, block 2 on hard drive 2. Now we put our backup data on hard drive 3 here, and then we store data on hard drive 4. Now the next time, for example, we put our data on drive 1, backup data in drive 2, data on drive 3, data on drive 4, and so much and so forth. So, kind of keep that in the back of your mind. RAID 5, speed and redundancy, but here's the problem with RAID 5. The act of writing this backup data, it can increase latency. And because we're dealing with block storage, which is so slow, guess what? Here's what we're dealing with. It's not even allowed on the AWS cloud. So block RAID 0 is fast and gives us everything we need, but redundancy. RAID 1 gives us all the redundancy in the world, but no speed. What if we blended them together? And that's RAID 10. So really, RAID 10 is a combination between RAID 0 and RAID 1, in which case we'll create a RAID array that's RAID 0 for speed, a backup RAID array for speed, and copy RAID array 1 to RAID array 2. Let's be fair. We lose RAID array 1. Guess what? We're good on RAID arrays 2, 3, 4, 5, 6, and everything else. So we're good on the other drives. So let's make sure we get this clearly. So I'll show you what it looks like. Here we've got 2 RAID arrays. The first case, we're combining RAID 0, 2 drives, back and forth, fast. RAID 0 on the other ones, that copies from RAID 0 array 1 to RAID 0 array 2. Anything happens with our first RAID array, don't worry about it, no big deal, we're good to go. Why are we good to go? We're going to be on the second RAID array. And that's why we're using RAID. I'm going to talk about a couple more file systems real quickly, and then I'm going to get involved in answering some questions. So let's talk about the next thing. We'll talk about the elastic file system. What are we talking about with regards to the elastic file system? Nothing special other than NFS file system, meaning if any of you have been using Linux or Unix storage environments for years, file storage, and you set up a network file system share, which was invented by Sun Microsystems 30 years ago, that's what we're talking about. That's the same thing that AWS Elastic File System is. It's the AWS branded, fully managed version of Linux Unix storage. That's it. And of course, with this, we have the same kind of versions like we do with any other kind of storage, where we've got the standard, which is the highest performance option, and frequent access, which is stuff where you're not going to access it frequently, but you have to pay for it when you retrieve it. We'll have our two options, which is burstable. Here's what burstable means. You've got access to this, but you can temporarily increase your speed, or guess what? You know, provision throughput, which is you say, I need this, and you pay for it ahead of time, and it's guaranteed to you. Again, no different than frame relay with a committed information rate and a burst rate from 25 years ago. Same kind of thing when we're talking about bursting. Now, what's good about is the elastic file system is it's like NFS, right? So it's POSIX compatible, and it will work with your legacy systems. It's considered high throughput, high IOPS, low latency. One thing that I really love about the elastic file system versus building your own file server, is it expands if needed. So normally, from an architecture perspective, you're planning how much storage you think you need 10 years from now, or 5 years from now, or 3 years from now, how long you're going to keep your systems. Then you usually double it, and you figure you got a good dose. I'm exaggerating the concept, but it's something like that. It's what's called the SWAG, a scientific wild something guess. Now here's where the cloud shines. The elastic file system will grow on demand. So we'll automatically adjust size and capacity. I got to tell you, for the people that do capacity planning and systems administration, this is a huge, huge, huge thing. They'll be incredibly helpful. Here's what it looks like. We use the elastic file system, so you can take your EC2 instances that are running Linux, for example, and mount them to an NFS SharePoint in a fully managed environment by AWS. Just like you would do in the data center, but here you don't have to manage it. Now, we talked about file services for Linux, right? So what do you think the next is? File services for Windows. Now, if you wanted to deal with file services for Windows, you could deal with a Samba share on a Linux system, or you could use Windows servers. Windows servers. So let's talk about Windows servers. When you're dealing with Windows servers, you're dealing with a fully managed, high availability Windows file system. Okay. Why is it? Because they're Windows servers that AWS manages for you. And because they're Windows servers, they use the server message block protocol, which means they're hosted on Windows servers. So because they're Windows servers offering Windows shares, you can get all those Windows system features like quotas and Active Directory. File system for Windows also provides encryption in transit and in rest. You know, what does this really look like? It looks like this. Basically speaking, you've got your server. You create your file system. You configure your file shares. You connect to your file shares, and that's it. You run your application. Simple, simple, and effective. While we're at it, let's get to the point where we talk about Amazon FSx for Lustre. So now let's say you needed a higher performance file system because block storage isn't good enough for you for some high performance computing. This is where we get into the Amazon FSx for Lustre, where you can get millions of IOPS and 100 gigs per second of throughput, bi-directional synchronization. We can synchronize our data with multiple S3 buckets, for example, and this enables some truly high performance transfers via multiple threads. Now we're going to get back to the training. So you'll recall yesterday we talked about the cloud and how it was organized and the type of connectivity you would use to connect to the cloud. And we talked about storage on the cloud. Now today we're going to begin by telling you how do you get your stuff, your data, to AWS. So realistically speaking, how are you going to get your data to AWS depends on your options. If you've got a high-speed link to you in AWS, like a 100 gig link, and you don't have that much data, or a 10 gig link, pretty easy. You just send your data over the wire. No big deal. But, you know, in some cases, that's not practical. There's ways where we can send it over the network, which I talked about, which is a manual transfer. There's ways where we can send the data over the network to the cloud over a more automated transfer. And of course, there's transfer appliances we can talk about to get our data there if we lack network bandwidth or we lack time. So we're going to tell you how to do all three starting now. Now, when it comes to sending data to AWS, the first, AWS officially supported method is to use something called the storage gateway. Love the storage gateway concept because here's what it is. Effectively, you've got AWS, which sits over here. You've got a specific virtual machine that you put in your data center. That data center becomes a server. You connect all your devices to this server, and I'll show you graphically what this is going to look like. And then your data is just asynchronously copied in the cloud. Put a file server in your data center, it magically gets copied to the cloud. Now, what is this storage gateway that AWS provides? It's just a simple virtual machine. You pop it in one of your VMware servers or your Microsoft Hyper-V servers, and it's an AWS managed virtual server. And basically what you do is you mount the server, and I'll tell you how you do it, and it just moves your stuff to the cloud, asynchronously, dynamically, and beautifully. It's very, very simple. Now, if an organization has a hybrid cloud, which is a data center connected to the cloud, the storage gateway will keep the data synchronized. It's magic. But if an organization wants to migrate their stuff to the cloud, they can also use a storage gateway, copy all their stuff over, and then launch their virtual machines in the cloud. On day 3, they're up and running like nothing. So we're going to talk about storage gateways. We're going to talk about the types of storage gateways. We're going to talk about how they work, and why organizations would use them. So the first kind of gateway, we'll be talking about file gateways, volume gateways in stored mode, volume gateways in cached mode. And realistically speaking, there's also something called a tape gateway. I don't know if most of you, hopefully not as old as me, who's been working in tech for as many decades as I have, where we started out by basically putting these tapes and we'd back up to a tape. And then the tapes got bigger and bigger and bigger. And many organizations still have a tape gateway, which basically speaking, we can get rid of that. We can create a virtual tape gateway, and we can back up and archive like we used to using virtual tapes as tape backup machines, which we'll talk about. So we'll talk about file gateways, volume gateways in stored mode, cache mode, as well as the tape gateway. So let's begin with the storage gateway, specifically the file gateway. It's a very, very simple, elegant solution. Let me show you what's really going on here. In this particular environment, what you have is you got your servers. So we have them on the left side of the screen represented as application servers. Now we stick this AWS virtual machine in either a Windows server using Hyper-V or a VMware ESXi server. And we basically use a server message block or an NFS share to the storage gateway, which is represented by red. And then that storage gateway is going to use your direct connection or your VPN connection, whatever WAN bandwidth you have. And it's going to directly send your data to S3. And from there, you could have a lifecycle policy with your data like we did, where it stays on S3, then it moves to infrequent access, and then it goes to Glacier. Or we could keep it on S3. So very simple. Takes your stuff in your data center. You mount a virtual machine just like it's any other file server in the world. And asynchronously, your data gets copied back to AWS. Simple, effective, elegant, very, very basic, very, very simple. Now, there are ways to truly optimize this. What if an organization really has a hybrid cloud and they want to use their data center for the majority of their computing because it's cheaper to operate the computers you own than it is to operate stuff on the cloud, where the cloud gives you more agility and it enables you to design potentially cheaper, and we'll talk about that when we talk about auto scaling. But best performance you're ever going to have is in your data center because there's no latency, and the cheapest cost is going to be for the hardware that you typically have. So for organizations that have that want a real high availability cloud, that have a network they have their own cloud and they connect to one or two public clouds. Now you're talking about volume gateways and store bed. Why? Because the organization keeps most of their data in the data center, and they're using the cloud either for bursting, which means added additional capacity. They're using the cloud for what it's really good for, which is hosting, say, web applications that dynamically scale on demand. Or they're using the cloud for backup purposes, like disaster recovery purpose. And this is where the volume gateway stored mode comes in. Put this machine in our data center. Everything gets backed up onto S3. And it's a beautiful, beautiful, simple way to do it. Now the servers will connect via the iSCSI protocol. Basically an internet-based SCSI, SCSI type attachment to the drives, and it'll operate like any other type of storage area network. So visually, what is this going to look like? Now in this particular case, you're going to have your users. They're going to be connecting to their stuff in your data center. And they'll be connecting to your application servers or whatever servers you have. Your servers will have an iSCSI connection, as you can see, between our application servers in orange and this gateway virtual machine, which is operating in store mode. And then as data changes in our data center, you're going to see it's going to be pushed to Amazon S3 or snapshots. Simple, elegant way. And your data is primarily in your data center, and you want to shift it and send it to the cloud. Beautiful, elegant in every way. Now, what if you really had most of your stuff going on in the data center, meaning the cloud, like the AWS cloud, but you still had some stuff in your data center, but most of your data was stored in the cloud? Well, there's a way to make this work too. Basically, you can keep your data center and your cloud synchronized while maintaining most of your data in the cloud and bringing it back. Now, here's the first thing to remember. Computers cannot mount object storage. Doesn't work. We talked about all those reasons why yesterday, of swap files and versioning and lots of challenges. So because of this, it's not like we can take our data center servers and mount them to object storage or AWS S3 or Microsoft Blob, Google's cloud storage, because the technology is not designed for that. But what we can do is we can store our data into object storage in the cloud, which is nice and cheap, and create some little virtual environment called the gateway that can then share it back to the systems in our data center and make it feel like it's real storage, not object storage. And that's where this beautiful volume gateway cache mode comes in. And the volume gateway cache mode is designed for organizations who predominantly keep their data in Amazon's object storage, otherwise known as S3. And it's going to make the data stored on S3 feel like local storage in the data center. The way this is going to work is a storage gateway virtual machine is going to be installed. And I'll show you what a picture for this in a minute. And the data basically is going to be received and cached from S3. And by doing this, what are we really, really talking about? It's going to be pulled from S3, placed on the server that all your devices mount to, and then you can pull information from the cloud and synchronize it. So let's look at what this is going to look like architecturally. So imagine most of your data is on the right side of this where it says Amazon S3. You can see the red data over here. And here in our data center, we've got users that want to access the data. So basically, we put this volume gateway in here, and the volume gateway connects us to the AWS cloud for storage. Now, when we pull data from the AWS cloud out of S3 and it sits on our gateway virtual machine, it's going to cache that data. And what do I mean by cache that data? So let's say I was drawing a picture of my beautiful cat, Cindy. I love my cat, Cindy. I adopted her theoretically. So I was supposed to rescue her, but I think she rescued me by making me happier after I adopted her. So anyway, so I picked up, so there's that. So kind of the way you like to look at it is if I wanted to pull my data from the cloud and I wanted to view a document of my cat, Cindy, it would be on the AWS cloud, sent to the gateway virtual machine. I would do my thing and it would be cached on the gateway virtual machine. Now my wife, who really loves cats, decides she wants to look at the photo of Cindy. She's going to go straight to that gateway virtual machine to access it, and it's going to be there for me. So the data is not going to go back to the cloud. Now then my brother comes to my house and he wants to look at photos of my beautiful cat, Cindy. And again, he connects to that gateway virtual machine, and the gateway virtual machine says, I have it here. and sends it back. Now later that day, I want to look at a photo of Chris's beautiful orange cat, the Maine Coon Sunny. And I go to the gateway virtual machine and it's not there. It pulls it from AWS S3, stores it on that gateway virtual machine, and sends it to me. Now, Chris from my team wants to look at his beautiful orange cat, Sunny. He goes to the gateway virtual machine and it's there. So it's a lot like a content delivery network concept, but for your data, your private data across your intranet versus the internet versus web pages, but similar in content with regards to caching. I'm aware that my pointer doesn't show on screen. I wish it really does. As I try to move my mouse, it just does not show up with our broadcasting stuff. So. Now, the last thing I want to draw is really a tape gateway. While we're at it, let's add a slide. We'll do it together. So what is really going on here with the tape gateway? Well, it's pretty simple. What we have over here is we've got AWS Object Storage. And what we then have is we've got our data center, and a lot of data centers have this virtual tape machine, where it's basically it's a tape backup drive. And usually the way this works, BAC backup. Typically what happens is we've got some user admin when they're doing the backup. They're popping in these backup tapes, and they're shipping them off-site. Now what happened is AWS came up with a virtual tape. And basically instead of being a physical tape that gets changed, it's this virtual tape. Terrible something. So they put in this virtual tape, and what happens, the tape backup drive thinks it's connecting to a tape, but it's literally a virtual tape. And then the virtual tape will send it over your network directly to AWS, your direct connection to AWS Object Storage. And there you go. That's your virtual tape gateway. So those are the ways that we can send our data over the network to AWS. Of course, we could put an FTP server or a secure FTP server in the cloud and just push it there like we would in any other data center. But these are the AWS, managed, simple, elegant ways to do it. But what if you don't have enough time? What if you don't have enough bandwidth and you need to get your stuff to the cloud faster? Now we're getting into other options. The first option we're going to deal with is something called the snowball. I love the snowball idea, I really do. What is the snowball? It's this ruggedized computer. And in the ruggedized computer, and you can see pictures of it in our book, they basically ship you a computer with a bunch of hard drives and a RAID array. You plug this computer into your network over the 10 gig network connections. You copy your data to the snowball. Copy, copy, copy. And then you ship the snowball back to AWS, and they pop it on your object storage. Now, when you copy it there, it's encrypted, and it's very simple. You request a snowball from AWS. They deliver you the snowball. You load data on the snowball, call them and pick it up and ship it back to them. And then AWS takes the data off of the device, puts it on your object storage platform, and then securely erases that device for the next customer. And yes, they know how to securely erase a device for the next customer. That's how the snowball works. And it's a nice, simple, elegant solution. Now, what if you needed to move a lot more? So instead of shipping this ruggedized computer, what if you needed a whole shipping container? So now we're dealing with the snowmobile. Really, really cool concept. The snowmobile is basically a data center and wheels. It is this 45-foot shipping container filled with storage, and more storage. And what happens is this data center gets driven to you, a tractor trailer. Get connected snowmobile to your network, copy all your data on, and then the snowmobile is driven back to AWS. They copy it onto your object storage, otherwise known as your S3. And guess what? It's done. Now let's talk about something that's a little more realistic for the average user. Let's say you've got a small amount of data, like 15 terabytes. In this particular environment, you could use just the very simple AWS import-export service. What is that? It's a rental hard drive from AWS. Copy your data to the rental hard drive, ship the hard drive, and then they take it off. So again, this is where we're getting the nice and simple and elegant. Put your data on a hard drive, ship it to AWS, they load it for you, and poof, you are good to go. Very simple. So before we get into computing, which we're going to have a lot of fun with, and we're going to even show you under the hood what's going on, because I want you guys to truly experience it as opposed to just seeing a lecture. We're going to talk about Amazon Workdocs, which is the last key component of storage on AWS. So if any of you have ever used something like Dropbox before, or Google Drive before, a consumer-oriented collaboration tool set, well, that's what Amazon Workdocs is. It's a fully managed, secure content creation, storage, and collaboration service. Just like Google Drive or Dropbox, it enables collaboration on creative projects, shared document editing. It's simple and affordable, and you can access it via web client or specific client software for Windows and Mac operating systems. And of course, it meets traditional security standards like HIPAA, PCI DSS, and ISO requirements. So far, we've covered storage. And in this boot camp, we've covered block storage, object storage, file storage. We covered the AWS branded S3 EBS. We talked about RAID, the Elastic File System /NFS, file system for Windows. We talked about storage gateways, the Snowball, the Snowmobile, and the import-export service on Workdocs. Now, we're going to get into compute next, which is one of my favorite parts. So now let's start talking about computing upon the AWS cloud. And before we do this, I want to explain exactly what's going on. I want to make sure you all truly understand what are virtual machines. Because if you don't understand virtual machines, all this stuff is basically going to all be for naught. So I'm going to give you a visual description of a virtual machine using one of my favorite things in the world, my cat Cindy. And then after we deal with this visual description I'm going to give you, I'm going to bring you to one of our data center servers. We're going to teach you how to create one in real life the hard way so you get to see it in the data center. And then when we talk about this elastic compute cloud, you'll be able to define it in one sentence. It's a couple words long, and you're going to all know what it is. So in 1999, VMware came up with the first x86 hypervisor. And it created the first virtual machine. It was the coolest thing in the world at the time. And what a virtual machine really was, is we would take a server, chop that physical server up into mini servers, and then be able to create multiple servers all on that single server. Now, when I started in tech 25 years ago, this was not possible, and here's the reason. The servers were slow. They had a couple megs of RAM. Maybe, and that was a $20,000 device, one core or two one-core CPUs, a couple megs RAM, and that's 10 grand. Now on that, here's what happened. We could only run one stuff on a server, and every 2 years, when computing power would double or so, we'd be buying a new server because we were constantly outgrowing our technology. Fast forward, 25 years. Now we've got the servers made by AMD, which can have a good 3 64-core CPUs in them, which gives us 192 cores. We can pack these things with 10 terabytes of DRAM. Now that one server can power many servers. So what happens is we're dealing with all clouds. And when we're dealing with AWS EC2, Azure Virtual Machines, Google Compute Engine instances, Oracle Virtual Machines, it's all the same technology. And basically what makes this possible is as follows. We're going to take a server, and I'm using my favorite technology demonstrators over here. And the server is going to be represented by the physical hardware. And we're going to install this very thin layer of software on the server called the hypervisor. Now, the hypervisor will let us take that server and create a bunch of mini servers all sitting inside this server. Now, each mini server will have its own operating system and its own applications and their dependencies. So in this particular case, we've got 3 servers. Server 1 is on the extreme left, and it's my beautiful, sweet, adorable cat, Cindy. She's running her own application. She is in one of the virtual machines. Now, on the same server, the same physical device, guess what we have? We have Chris, my chief operating officer's fantastic cat named Sunny, who's a beautiful orange Maine Coon. And you can see she's in her own virtual machine with her own operating system because she's the application. Now, on the right, we have this cat, which I named Catty. It's a Maine Coon. It's black with green eyes. It's a beautiful, beautiful cat. Now, this cat comes to my house every single day to go play with Cindy, my cat. My cat, Cindy, is terrified of this beautiful Maine Coon. I don't know why. I even put out food for the Maine Coon because it's hungry a lot of the times, and it's sad. But my cat and her don't like each other. I don't know why. But you can see this cat, who I call Catty, is on her own virtual machine. Being on her own virtual machine, guess what? She is completely separated from Sunny the cat and Cindy the cat, all on the same servers. And that makes my cat Cindy happy, because I don't know why Cindy doesn't like Catty. I think she's a beautiful Maine Coon. So that's what we're really talking about. But let's take this conceptual drawing and let's build a real virtual machine, the hard way, the data center way. And by doing it this way, now when you deal with any cloud provider, you're going to understand what is a virtual machine. So Chris, can you share my my web browser? You put the web browser on the screen. Okay, here we go, everyone. Here you can see my desktop. And right now I'm remoted into the web browser, one of my many VMware servers that the students in the Cloud Architecture Development Program use to really get hands-on experience, real hardcore hands-on experience. They build clouds on these things. And the basis of all virtual machines is the following. In this particular case, we've got a physical server. But tell me about the server. The Dell is a precision workstation, which is basically a server. It's Dell 7810. You can see it's got 24 CPU cores. You can see that it's got 2 of these Xeon E5 2670 V3s. You can see that the system has got a total of 128 gigabits of RAM on the right-hand side of this. You can see that the total number of gigahertz in the system is 55 gigahertz. And you can see that we've got this 1 terabyte of NVMe storage in here. Now, when we're dealing with virtual machines, all what we're really dealing with is as follows. We're really dealing with taking the server, the hypervisor on the server is that VMware ESXi, and we create a virtual machine. And we'll name the virtual machine, so let's call it Cindy's virtual machine. My cat's really cute, and she likes to get her hands involved in technology every day of the week. Unplug servers with her paws. Great troubleshooting coach, by the way. Then we pick the operating system we want. And then we give it some information about the operating system. In this case, we use Windows 10 64-bit. In case many of you haven't deployed service in your life, I'm just going to show you something real simple. And then the next thing we would do is, in the traditional data center environment, we're going to determine, what we need. Okay, how many CPU cores are we going to use? How much memory does the virtual machine need? How big is the hard drive we want to use? And then from there, we'll determine where it's going to boot. We're going to boot it directly off of this ISO file. We're not going to build the whole virtual machine. I just want you to get the conceptual knowledge over here. We're going to make sure that we expose the operating system, the hardware, etc. And this is basically the basis of all EC2 instances, Azure virtual machines. Now you can see we just created this new computer. And if I click on this computer, wow, it's going to boot up just like any other computer. Wait, just like any other Windows computer, it's going to press any key to continue, and it'll enable us to install it, just like it's any other physical computer. The only difference is I can have 20 of these things sitting in my server, optimizing using space, power, efficiency. And by doing it, guess what? We're basically in a position where we can maximize our data centers. So this is what we've been using for the last couple of decades. Chris, we can go back to me. We don't need to be sharing any more of the screen. But I wanted everybody to understand under the hood, what is an EC2 instance? So now let's go into the AWS related content. I want it to be meaningful to you. So AWS likes to call their virtual machines Elastic Compute Cloud. I don't know why they paid somebody in marketing so many millions of dollars to come up with that name, but that's what they call it. So now you know that Elastic Compute Cloud is nothing more than a virtual machine. If you're interviewed by a CEO, a CTO, a CIO, or any of these people, and they say, what's EC2? You tell them it's a virtual machine. Don't get rid of any of the sales or marketing things, and they'll trust you. So when you're dealing with virtual machines on the cloud, how do you size them? And the same way you do any other virtual machine. So if you know that a virtual machine takes 24 cores, you size your virtual machine with 24 cores. If you know your virtual machine needs 256 gigs of DRAM, guess what? You size your virtual machine with 256 gigs of DRAM. Now, when it comes to your storage, in terms of hard drives, in your data center, you know what you get. But on the cloud, you're dealing with slow block storage. So again, do you need RAID? What kind of storage environments? What kind of block storage environment do you go? There you go. And again, you're there. What kind of network performance do you need? You need gigabit Ethernet, 10 gigabit Ethernet, 40, 100 gig Ethernet, exactly what you need. So again, the same way you would make any virtual machine in any data center, it's the same thing you would do in the cloud. That's why I say learn the cloud, not any vendor's platforms, and then you're going to know all the cloud. So let's talk a little bit more about them. Now, I showed you the hard way. In the data center, you'll have to tell your servers exactly what you want. You can tell your server, this one has 4 cores and 4 gigs of RAM, or 2 cores and 4 gigs of RAM. This next server has 64 gigs and a terabyte of RAM. You can do that in your virtual machine, but not on AWS. On AWS, these virtual machines are pre-built for you. They took all the thinking of it out of you. And all you need to know is which family of virtual machines to use. And then you go to the chart and you determine which virtual machines equal your CPU DRAM performance. Now, they made families like A1, which is used for ARM-based workloads, and C5, which is used for compute optimization, for batch processing, media transcoding, and G3s are GPU-based machines, which you would use for, say, machine learning. And then they've got the i3, which is for high-speed storage, for like data warehousing and high-speed, high-performance databases. They've got an M5, which is general purpose, ideally for databases, and M6, which is more general purpose stuff for caches and databases. They've got a T3, which is the basic burstable computing platform, which is perfect for web apps and test environments. And then when you need a lot of memory for like big data sets and data science and data engineering things, so you're going to have large data sets in memory, then in memory databases, you've got the X1 family because it's got the lowest cost per gigabyte of DRAM, because they're focused on giving you a maximum DRAM. But, you know, kind of keep that in the back of your mind. You should be good to go. So realistically speaking, when you're dealing with a virtual machine, what are your operating system options? Well, EC2 really supports Linux and Windows. Basically, almost all your servers are going to be Linux. You'll have Microsoft Exchange servers, Active Directory servers. Some organizations have Windows servers, but for the most part, most servers are going to be Linux. Now, AWS also offers virtual machines that run on Mac Minis for the Mac operating system. Look, you're not going to host a mission-critical application on a Mac Mini. It doesn't have error-correcting RAM. It's not a mission-critical system. But if you're a developer and you need to compile code for applications running on a Mac, you need a Mac to do that. So instead of your developers having to buy Macs, they can get a 24-hour AWS EC2 instance that runs the Mac operating system. That's what that's for. Now, you can create your own machines. You can take your virtual machines from the data center and use a conversion tool and take those same VMware virtual machines or KVM or QEMU virtual machines or Hyper-V virtual machines, migrate them to the cloud provider of your choice. Or you can use a pre-built virtual machine. There's pre-built virtual machines from AWS, but also, let's say you want real security in your environment. You're not going to be using AWS WAF or any cloud provider's native things. You're going to be going to your extreme security vendors, Cisco, Palo Alto, Fortinet, Checkpoint. And then you're going to be running their stuff on a virtual machine. And you'll be getting those virtual machines from the AWS Marketplace. which is where you're going to be getting these things. So kind of keep that in the back of your mind. But whenever you build the machine image, what's it going to need? A storage volume. Where are you going to store your stuff, as my mother-in-law would like to call it? And it's basically going to be your system and your EBS one. So we can get, normally every virtualization device has its own name and its virtual machines. AWS calls their virtual machine images an Amazon machine image. Everybody else has their own names. And basically, in what I showed you, I created a virtual machine, and I'll have to install my own operating system. Windows, Linux, what have you, Red Hat, Ubuntu, Oracle Linux, Amazon Linux, CentOS, Linux flavor of your choice. So you see, now with AWS, they're pre-made for you. All you have to do is click 3 buttons, and it comes up. That's why the cloud is easier, because it's so agile. You just click 3 buttons and it's done in seconds. And launching one of these virtual machines is easy. I showed an 8-year-old how to do it in less than 5 minutes. She was real cute with it. A couple buttons. So much easier than the hardware I showed you, which is the data center. And we can get these machine images from the marketplace if they're a firewall. We can generate them from our own machines. And we can upload our own machines and use a conversion tool. So when we make a virtual machine image, it's basically a system image of your server. What are the components to this? Well, it's going to be your operating system, your launch permissions, and a block device mapping that maps the block storage to your virtual machine. That's really it. I can make an AMI, a machine image of my servers. I can copy it to different regions in case of a disaster recovery. I could take my image, modify that image, and ship it to other clouds for disaster recovery purpose. So it's great for new migrations, great for multi-cloud environments. Amazon Linux 2 and Amazon AMI are pre-built Linux images supported by AWS, and they're all based off of the Red Hat Linux operating system. But Red Hat, you have to pay for their support, and AWS it kind of comes with. So now let's say you launch a virtual machine. So let's say I launch a virtual machine, and I want this virtual machine to update its operating system upon a reboot. Maybe I want to install certain things like an Apache web server. So I can set up what's called the bootstrap script. And there's a little box where you put commands. So let's say I've got a Linux machine. I could have the first command be a sudo apt-get update, which will update the packages. Then I can do sudo apt-get upgrade, which will upgrade the packages. Then I could have it say like sudo apt install, I think it's Apache or HTTPD for the web server, and poof, it'll install all that as soon as the server comes up. So I could use a script to basically launch these AWS machines, install applications, patch the software. With the Linux things, it's a simple bash shell script. With the Windows system, it's a basic PowerShell script. Simple, 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 easy stuff. Now, when we're getting our virtual machines from the cloud provider, there's multiple ways we can get them. And the way that we purchase these things can affect our cost dramatically. This is called tenancy options. So let's talk about the first one. On demand. And what is on-demand instances? And by the way, this is realistically speaking, in many cases, why organizations love to use the cloud. So with an on-demand instance, you pay by the second. And what's your compute capacity? Your compute capacity is as follows. Whatever you need it to be. Meaning, I don't know my demands. So basically speaking, I think I need a 16-core server with 64 gigs of RAM. I buy that on demand. If I need capacity, I use auto-scaling. I add 10 more of those servers. And when I don't need them, the servers miraculously reduce their load, and I'm back to one server. Now, by doing this on demand, I don't need to know my exact capacity. And because I don't need to know my exact capacity, here's what I have to deal with. I have to pay more for it, for the agility to scale up or scale down. And it's actually technically scale out and scale in. Scaling up means using a bigger server, where scaling out means adding additional servers. So really what we're talking about is this. On-demand enables us to add what we need when we need it. Now, when we deal with on-demand, we're paying the most. Now, why are we paying the most with regards to on-demand? We're paying the most for the following reasons. We can't guarantee Amazon what our customer costs are going to be, so they have more business risk. Now, by comparison, if I told AWS, I'm going to buy this server of this capacity for the next 3 years, that's called a reserved instance. And in this reserved instance, here's what we're dealing with. We're dealing with, I tell them that I'm going to buy this capacity. Now, if I tell AWS how much stuff I'm going to buy, they're in a better prediction into how many servers they need to buy to support my business needs. And they're going to give me a nice discount for this. So that's what I reserved instance. So on demand is, you're going to pay the most because there's business risk involved for AWS. You're going to have to keep extra capacity around just in case you need it. With the standard reserved instance, you're basically telling them ahead of time, I'm going to buy this for the next 1 to 3 years, and they're going to give you a nice discount. Now, what if you've got a very, very, very strange environment? And in your strange environment, you know that every Friday, Saturday, and Sunday, your system's going to run a batch job. It's going to run 24 hours each day. And you only need it from Friday, Saturday, or Sunday. Well, that's where we deal with something called the scheduled reserved instance. And what that is really is you buy or a set of compute time every week on those days. And because you're committing to it ahead of time, you're going to get a discount. Now, that discount won't be as great as if you reserve it 24 hours a day, 7 days a week, but it will still be there. Now, the last option we're going to talk to is something called the spot instance. A spot instance is basically an auction of where you're buying or renting extra AWS capacity. So here's the thing. Here's the way a spot instance works. You know, you need extra compute capacity to do something. You bid in an auction-like manner at a certain price. Now, if the price raises while you're using the systems, guess what? Your systems get shut down. Kind of scary. Google calls this a preemptible instance. Basically, you're purchasing unused services at the lowest cost AWS is willing to sell it to you. But if somebody else wants your compute capacity and they're willing to pay more than you, you are shut off. So kind of keep that in the back of your mind. This is a little on the scary side. A little on the scary side. So kind of keep that in the back of your mind. So reserved instances, guaranteed to know what they are. Cheapest. Schedule reserve, you know you need them on a couple days a week. You reserve the capacity ahead of time, you get a discount, but not as big as if you buy it all the time. On demand, get what you need when you need it. Scale out, scale in, good to go. And spot instances bidding on extra capacity. Now, what other options we actually have was regarding tenancy, and that's more how you buy them. The next is really what they would call tenancy is, do you want a shared tenancy instance? And what is that? A shared tenancy is when you launch your virtual machine on a server that has a whole bunch of other people's virtual machines. Kind of like that system I showed you where I had 3 cats on the same virtual machine. Now that is standard. You get a standard virtual machine in any cloud provider. It's called shared tenancy. And your virtual machines and somebody else's virtual machines are on the same server. Who cares? It doesn't matter. They're logically isolated and they're secure. Now, what if you wanted to have the whole server for you and make sure the entire server for you, exclusive of the entire server, is guess what? All your virtual machines and nobody else's. That's where you get something called the dedicated instance. So shared tenancy, where multiple people share the same server. Dedicated instances are basically when you have on the same system multiple customers. Dedicated instances, you buy this instance, you only stick your virtual machines on there. Now, what if you need real performance? High performance, access to the high performance disks in your server, you've got an application that needs the serial number of your processor or a serial number on your motherboard. You have to put a key in there for the USB key in the server for a license. Now, when you're dealing with this kind of stuff, what you really need is what's called the dedicated host. What's a dedicated host? It's a bare metal server, just like the one that I showed you, for which case you put your own hypervisor, or you use their hypervisor, their Nitro hypervisor, and you manage it yourself. So realistically speaking, that's exactly what we're talking about. Bear with me, I may sneeze. My cat's kind of giving me allergies. Sorry about this. I adopted a cat. She's the sweetest thing in the world, but she makes me sneeze from time to time. So when you're dealing with a virtual machine, how are we going to deal with keeping it secure? Well, all virtual machines in AWS have the ability to use something like a host-based firewall called the security group. The security group will allow you to keep stuff, unwanted stuff, outside of your server. And the good news is that security groups are stateful, which means they track the connections going in. And basically, you can set up a firewall-based policy on the server. So for example, if it's a web server, allow port 80 and port 83 in to the server. Don't allow anything else in. Because why would you? Or if it's a high secure server, you could basically create a firewall rule that would say, allow any connection from the IP address 192.168.1.21/32, an exact match for something like that. So let's look about what we're really talking about over here. We're basically talking in an environment where we've got our virtual machines. We put a firewall rule called the security group right outside of them. And that's it. That's all we need to talk about. And everything is up and operational. Now, when it comes to getting an IP address on an EC2 instance, how do you think that happens? How's it happen in the data center? Well, in the data center, you can manually assign them, or you can use DHCP. Now, in this case, in here, all EC2 instances are going to be given a name from the DHCP server. So they're going to automatically be assigned. You're going to have to tell it your site or range, and you'll create the subnets, and an IP address is going to be assigned naturally for you. Now, when an IP address is given to your EC2 instances, you're also going to get the DNS service that's associated to it and a fully qualified DNS name. And that way you can attach to it Mike's ec2.this.this.com, and that way you can connect to it via the DNS name as opposed to remembering 1.2.3.4, which is his IP address. Now, when we've got a virtual machine, just like in our data center, we can have multiple network interfaces. We can have multiple subnets on multiple network cards on different subnets, public ones, private ones, anything we need to do, just like we would do it in a data center environment. So that would be created by multiple network interfaces, which we'll talk more about later, especially in the networking session. Now, typically speaking, anything that you don't want reachable from the internet should have a private IP address on it. It'd be behind your firewall, your IDS, IPS systems, your access control lists, etc. We'll talk more about that later. Kind of keep that in the back of your mind. Now, instances are also going to be assigned at launch a public IPv6 address. If you don't want to be reachable via public, don't take a public address. So remove that address and make sure you don't have a route to an internet gateway of some kind, which gives you IPv6 routing. And you see, manually disable anything you don't need. When it comes to security, you've got a server and it's got 1,000 services, and you only need one. Disable all 909 services and keep the one. Same thing. Now, the only thing to remember is when you've got multiple network cards on a server, generally speaking, each network card needs to be on a different subnet. And you can't use the same IP address in two places. So each interface is going to require a unique address space and a unique subnet that's not going to be used in subnets that are going to be overlapping somewhere else. Bear with me 1 second. Sorry, the cat really gets my allergies, even though I love her to death. Now, how are you going to manage your virtual machines? Well, lots of ways. You can use the management console where you click a few buttons, just like I showed you with my VMware environment, other than the AWS one. If it's a Linux machine, you can SSH or secure shell into it. And if it's a Windows machine, you're using that RDP, Remote Desktop Protocol. And of course, you can do lots of management on these systems as well via, what do you call it, the software development kit, or by pushing and pulling APIs. So those are your options. While we're at it, let's talk about another compute platform called AWS Outpost, which is realistically speaking a fully managed virtual machine service. Now, it's a little different. So here's what the AWS Outpost is. If you'll recall yesterday, I told you that the highest performance is in your data center because there's no latency there. The cloud is going to be your highest latency. And then we talked about these concept of local zones, which were intermediaries between your data center and the ultimate cloud, the local zone for lower latency. I also told you that by far the lowest latency solution is this. Keep your stuff in your data center that you need low latency. Well, customers are demanding low latency, so AWS decided to sell you servers that you can stick back in your data center. Now, they fully manage these servers, which makes it simply easy for you. But you got to remember, it's going to cost you more to buy somebody else's fully managed server to run in your data center than it would be if you just get your standard server. You use like Microsoft's Hyper-V or KVM or QEMU as a hypervisor, but it's your option. And by doing this AWS Outpost, it basically is giving you that simplicity and elegance of the AWS cloud and sticking it in your local data center, and giving you the performance as if it's in your data center, but AWS is going to manage it for you. But if they're going to manage it for you, they're going to charge you to manage it, so keep that in the back of your mind. Might be a great thing, may not be. So the AWS Outpost is really just a server that acts like an extension of your virtual private cloud, place where your own equipment is in your own data center. We're going to get to databases next. Hashtag AWS Certified Solutions Architect 2022. I know it's a long one, but we want a lot of people to see this free training. And putting that kind of content there will help as many people as possible see the free training. Ideally, spell it out, no abbreviations. Hit that like button and comment and subscribe. Tell friends, join us, so we can help as many people as possible with our free training. We are dedicated to making sure anyone that wants education can get some. So know that you're awake, which makes me happy. I'm going to start talking about databases. So what is a database? Well, a database is a place where you can store large amounts of information. A database facilitates the sorting, calculating, reporting, and information sharing. And databases are an absolute critical component to modern applications. Mission critical environment in today's world. AWS basically has three forms of databases. They have relational databases, and we'll talk about them. They have NoSQL databases. They have data warehousing databases. And while it's not a database, we'll to some degree talk about a data lake, in case they pop that into your exam. Now, when we deal with databases, we're going to start out with relational databases. And relational databases are the most common form of databases. And they give a business some really valuable insight. Data that's related to each other. Now, why would a business want to know data that's related to each other? Well, if I know that every time I use the coupon code Panda Bear with a 20% off discount, and I'm the CEO of a business, and Panda Bear can enable an organization to sell 30 times their normal sales, then it's pretty important to know that the coupon code Panda Bear drives sales. We can also find that maybe with a relational database, users' geography. The more users in Florida buy this, if so, the company can target their advertising money in Florida based upon a sale. So organizations thrive on data, and we can determine the relationship with data, pricing and purchasing, all kinds of exciting stuff. So that's why we need relational databases. because relational databases provide information that's related to each other. Good business insights here. And the way this works is the data is going to be stored similarly to the way it's stored in a spreadsheet, with rows and columns. Each row is going to have a unique ID, and the columns are basically going to hold certain values. And that's going to be the basis of how these things work. Just like a spreadsheet, but instead of being a spreadsheet, database. Now, when we're dealing with databases, we're going to talk about something called atomic. They adhere to the ACID model. And what does this mean? It means the transactions are all or nothing. It's either on the database or it's not. Now, the next part of this ACID compliance refers to the consistency of data. If I write something to the database in a relational database, everybody else who accesses that database a millisecond later gets access to the same information. It's something called isolated as well, which means transaction 1 doesn't affect transaction 2. And it's also called durable, which means your data in the database isn't going to miraculously just disappear. Kind of like your email where you can't find something because you got 10,000 emails that day. Well, maybe if you're not a CEO, you don't get 10,000 emails each day, but if you are, you know exactly what I'm talking about. So when we talk about relational databases, we talk about that ACID model, atomic, all or nothing transactions, consistent, immediately readable after a write. Isolated, transaction 1 doesn't affect transaction 2. And durable, data in the database will not be lost. So let's look a little bit at relational databases. You know, how are these things kind of structured? They're kind of structured as follows. You know, what do we have over here? We've got data that's related to each other, a customer order ID, a customer ID, information related to the name, their email address, etc. That's what we're dealing with a relational database. Getting data that's related to each other. Now, when we deal with relational databases, there's plenty of kinds that we can use. We're going to discuss Amazon Aurora, MariaDB, Microsoft SQL Server, MySQL, Postgres, and Oracle DB. And of course, you can create any database you want by launching a virtual machine and installing your own database software. I'm going to talk about the Aurora database, which is a wonderful database that you probably should never use in your career. And here's the reason you probably should never use it. No matter how good it is, it's AWS proprietary. So when you're using a hybrid cloud, and you want to have your database in your private data center and the AWS cloud, you can't. When you're going to be using the Azure cloud and the AWS cloud and the Google cloud, you can't use this because your information won't be there. So this puts you into one of those AWS proprietary positions, which we tech architects like to call vendor handcuffing. You're stuck. You can't get out of there. So generally speaking, if you're an architect and you want your customers to have some business flexibility and agility, stay away from Amazon Aurora. I would tell you to do the same thing for the Microsoft database, the same thing for the Google database, because it's proprietary. But for the purposes of your exam, it's the coolest thing in the world. It's a fully managed database, which is MySQL and Postgres compatible. It's high performance and high scalability. And the reality is it's a very good performing database. It can be up to 5 times faster than standard MySQL or 3 times faster than Postgres. And what it really does is Amazon kind of took, you know, some of the benefits of a commercial database, such as what you get from Oracle, for example, and combined it with what you get out of a freeware database, and they sell it to you as kind of a software as a service. And by doing this, it's serverless, which means you don't have to manage at all anything that's going on. It's done for you. You're not thinking of your storage, etc. So when you use Aurora Serverless, it's much easier for you to do it. Here's the problem with serverless. You lose all control. You lose your performance because you can tune your own systems to high performance as you want. But once you get serverless, you're at the mercy of somebody else. Mercy of somebody else. So for any of you that are into performance cars, and you've seen somebody take a Honda Civic and spend 50 grand to that Honda Civic, and they turn it into a race car that can outperform a $200,000 car, it's because they customized it. When you're going with serverless, you're getting whatever the average performance is. It's kind of like going to McDonald's or Burger King when they say, would you like fries with that? Serverless is standard. You've got much less opportunities. In this case, it's simpler. It's much easier to go to McDonald's and buy a hamburger than it is to cook it yourself. But the one you cook yourself may or may not be better based upon your taste. So kind of keep that in the back of your mind. It's a great database, but it's proprietary. Now, of course, you can use the MySQL database. Now, MySQL database is an extremely old, highly popular database used in a tremendous number of wide variety of applications. Now, AWS also supports Postgres. Postgres is an open source relational database. It's very scalable. In many cases, people actually use this as a data warehouse. Very advanced feature set over MySQL. Great database. Now, while we're at it, another great database is MariaDB. And this is an open source relational database, which means you can pop this in AWS, Azure, Google, your data center, which is why we love it so much. It's created actually by the developers of MySQL, but they added additional features and functionality for the enterprise. Beautiful, beautiful stuff here. Now, many organizations use the Microsoft SQL database specifically for Microsoft-related workloads. And of course, AWS RDS supports Microsoft SQL Server version 2008, 2012, 2014. Of course, you can create your own virtual machines, install any database you want. AWS, by having Microsoft SQL Server, lets their users really access Windows workloads brought to the cloud in a very seamless environment, allows for a very simple migration. Microsoft SQL has different clustering options and failover options than most databases that you would use, and you have to be familiar with those when you're using them. And the 4 versions that are naturally supported are Express, Web, Standard, and Enterprise of the Microsoft SQL Server. But you got to remember, you could easily launch a virtual machine, install any database you want, and not use anybody's database management system. Now let's talk about when it really matters. When it really matters. When businesses really need a scalable relational database, for the most part, they go to Oracle. Oracle is the 600-pound gorilla when it comes to databases and relational databases. It's one of the most popular relational databases in the world. It's got a massively functional feature set and functionality. It's developed, licensed, and managed by Oracle. And AWS Database Management Service offers, standard one, standard and enterprise licenses. And each of the versions of the Oracle database will have different performance, flexibility, and scalability options. And you can pick these. And these are great because they are standard databases. So use them across your clouds. Now, when you're dealing with the Oracle database with AWS, there's 2 versions. There's license included and bring your own license. So let's talk about what they are. License included is basically you're using the AWS license to the Oracle database. And you're only going to get 2 options, basic options, Standard Edition 1 and Standard Edition 2. But if you've already got a paid license to Oracle, you can bring that license directly with you to cloud and host your database on AWS. And then you get a lot more flexibility. You can use the standard license, the enterprise license, the Standard Edition 1, and the Standard Edition 2 data license. So that's really where you're going to get there. Now, we talked about relational databases, which show the relationship between variables. Relational databases are great. But there are other kinds of databases to sort different purposes. The next kind of database we're going to talk about is a NoSQL database. And a NoSQL database, which is an old school database developed by IBM, if I remember correctly, around the 70s, came up with not only SQL. That's where they got the NoSQL. Not only SQL. And the key with NoSQL databases, they provide a lot of flexibility and schema. So in addition to being like that regulated, columns and rows like a spreadsheet, you get a little more flexible here. We can deal with structured data, semi-structured data. Because the structure on these NoSQL databases is very loose, and NoSQL database can scale beyond things that you can possibly imagine, much, much larger than a relational database. And the data is stored in a key value kind of pair environment. And what are we talking about here? We've got our keys and we've got our values. And of course, anything that we're going to give you is going to have a cat, dog, or a bird in it because we love things with fur or feathers, as an example. Now, we're really talking about a lot of flexibility in a schema, which enables you to do things that you could never do in a traditional environment. So let's say you wanted to store video game state while a player is in a video game. That's a NoSQL database. Let's say you need near unlimited scalability. That's a NoSQL database. Let's say you want to store, you're a content provider and people are watching movies, and you want to store the place where they stopped in a movie. That's a NoSQL database. When we cover NoSQL databases, I'm going to talk about the three options that you have for the most part. I'm going to tell you about the one that's going to be in your exam, DynamoDB. I'm going to also tell you probably should never architect DynamoDB into anything. And here's the reason why. It's AWS proprietary. Just like Google's Cloud Big Table, just like Microsoft's Cosmos DB. And being proprietary keeps you from building your high availability, high performance clouds like you would do in a multi-cloud environment. So if you're an architect, try to stay away from these things. Try to use an open standard, such as MongoDB or Apache Cassandra. But this is up to you. You can always architect any way you want. But it's on the exam, so we're going to talk a lot about DynamoDB. Amazon DynamoDB is the AWS branded NoSQL database. And truthfully, it's an excellent, excellent, excellent database. It's a great database. But it's proprietary, which means you can't use it on multi-clouds, which for we architects that are concerned about high availability means it's not usable. But it's on your exam, and if you're only going to deal with one customer, one client, and they don't care about system availability, they don't care what happens if a single cloud goes down, then you can use it. Now, in this case, DynamoDB is another serverless, fully managed by AWS environment. It's highly available as long as the AWS cloud is up, and your systems are placed naturally in multiple availability zones no matter what. It's serverless, so that means you don't have to manage the servers or the security. And it stores information on high-performance SSD storage, but again, it's block storage, so it's not the fastest thing. Now, DynamoDB is a good performing database. It's got low millisecond latency. And what we could use is we could use the DynamoDB accelerator, which is basically an in-memory cache that can lower latency just sub milliseconds. When we send our data to DynamoDB, it encrypts all data by default. And one good thing that's pretty amazing about DynamoDB is you can back it up. It has almost no impact on performance. And we can set up our DynamoDB to replicate across regions, which is quite nice. But again, it's proprietary. Now, the way DynamoDB tends to work with, it tends to work with primary indices, but it can also work with secondary indices, in which allows applications to use different query patterns. Now, when you're dealing with a secondary index, it's basically like you partition the database, and you can have a local or global secondary index. Local secondary indexes have the same partition key as the base table. Global indexes can span across multiple database partitions. Now, relatively speaking, there's going to be some limitations on sizing. A single key can't exceed 10 gigabytes, but that's still pretty big. And to increase scalability, then DynamoDB doesn't adhere to the massive model at all, which means I might write to the database, and 3 seconds later, it might be available every place else. By slowing that down just a little bit, it can promote some extreme scalability. So it's going to be there. It's just not immediately available. Now, if you truly needed to, and you needed to make DynamoDB immediately consistent, where the second I write it, everybody else can read it, you can configure that if needed. But remember, it's designed this way for a reason, for scalability. Now, when you're dealing with DynamoDB, you really want to provision the capacity of it ahead of time. In terms of what capacity, what are we talking about? Read-write access to the drive where it's stored. So you're going to have to provision your read and write capacity. And if you don't, it won't be there when you need it. Now, you could potentially actually use something called auto-scaling as it pertains to your database. What do I mean by that? Auto-scaling, if you need more input-output operations per second, will scale up your storage to give you better performance. Problem is, it doesn't scale down when you're done. So if you needed it for a very short period of time, poof, it'll scale up, give you the capacity that you need. but then it won't scale back down, so you might be paying too much for long periods of time. So you need to know your workload and optimize your throughput based upon your needs as a business. Now there's the ability to create infrequent access tables, which lowers the cost for usage. But then again, there's a 25% fee to save data and retrieve data, so not going to be useful here if you use it a lot. Now with DynamoDB, we're dealing with pricing based on throughput, and on-demand capacity is there with higher cost than if you pre-provision ahead of time, just like anything else. So where would you use DynamoDB? When you need near unlimited scalability, when low latency is required, when you're storing data from a large number of IoT devices, storing a game state, a player data store, a leaderboard, those kind of things. But remember, so DynamoDB, if you would run a single cloud, you could be used for large-scale financial applications, shopping carts, inventory tracking, customer profiles. Now remember, that's your AWS proprietary database, which means you can't use it in multiple clouds. Can't use it with your private cloud, hybrid clouds. So keep that in the back of your mind. Now, if you needed a really good NoSQL database in a critical high availability environment, you can't use this because it's single cloud. You could use MongoDB or Apache Cassandra, and you'll select those based upon your read-write information, because Apache Cassandra is better for certain things, and as well as MongoDB is better for others. And that's why we architects, when we architect something, we always go to the database people and we ask them to help recommend something. And if you're a database person, you're going to automatically know. And if you're a cloud engineering you need, go ask a database person. They specialize these things. They'll be able to tell you when to use Apache Cassandra versus MongoDB. Generally speaking, you use Apache Cassandra when you have more write activity, and MongoDB when you have more read activity. But when it comes to architecture, it's never done by a single person. Leverage your team and make sure your team knows different skills, and that way you get the best overall skills and designs. Now, if relational databases show us the relationships between variables, and NoSQL databases give us a ton of flexibility and scalability, what about a data warehouse? Now, data warehouse is getting kind of cool to me. A data warehouse is where you store a tremendous amount of information. Why are we storing all this information? Quite frankly, so we can make better business decisions in the future. So a data warehouse, which is typically Postgres, is something that could be used to store large amounts of business data that you can then process later, run a database visualization tool, run a business intelligence tool like Power BI, and get information from the data so you can make better business decisions. Now, there's obviously there's several types of databases. Amazon, of course, has their own proprietary data warehouse called Redshift, which again, I don't recommend you use because you can't use it in a multi-cloud environment. I recommend you look towards things like Postgres. But you do need to know the AWS available proprietary service. This is definitely on your exam. And if you were going to only be working with AWS, these services are truly great. They're very good. It's just that most customers want to be on multiple clouds, and most innovation and high availability systems require multiple clouds. So we don't recommend you use anything proprietary that locks you into a single cloud. But the way you would set up a data warehousing database would be, you would take your object storage, you take your information and map it and reduce it with like a Python Spark script or with AWS's EMR, whatever. We'll talk about that system later. And then you'll push your data into your data warehouse. And then you can pull your data out of your data warehouse and use a tool like Power BI or AWS QuickSight and be able to analyze your data and make better business decisions based upon your data. So all this point while we're collecting data is to make better business decisions. Let's talk a little bit more. What is Redshift? It's the AWS managed, AWS proprietary database data warehouse. Get actionable insights from your data, use it for business analytics, et cetera, and these kind of things. And realistically, Redshift Spectrum can provide real insights into your data when combined with other services such as S3. AWS will tell you to use Redshift because it's fast, powerful, and fully managed. Fully managed does offer you the advantage that you don't have to think about it. Fully managed also means you take away your control. Which hamburger is better? The one at McDonald's or Burger King? Or the one your grandmother cooked you? Or your friend who's a chef cooked you? One you've got control, and is cookie cutter. Both are fine. It's up to you in determining what your needs are. But if you're using Redshift, they can scale to petabytes of full data warehousing ability. And because it's Postgres, you can run SQL queries on your data. Your applications can perform SQL queries on your data. Now, when we're dealing with Redshift, we're dealing with a primary architecture based around clusters and nodes. Basically speaking, you've got a primary node, which is called a leader node. You've got a bunch of compute nodes support the leader nodes, and queries are directed towards the leader node. Very, very, very similar to what you're actually dealing with in a traditional environment. I'm going to discuss data lake, Chris, and then I think we'll take a break, and then we'll go back into more database stuff. So what is a data lake? I love data lakes. So a data lake is a repository that allows you to take structured data, unstructured data, and store it in the same place at any scale. If you're interested in data lakes, I interviewed a really great database architect. His name was Praveen, and my team can put a link to that video in the chat box so you can go back and learn all about data lakes. But a data lake is a repository that enables you to store your data. And it's typically based in object storage. You put large amounts of data. Now, because you're creating a data lake is going to be created by taking the information out of your data warehouses, out of your NoSQL databases, out of your relational databases, and out of your object storage. Now, this data is going to be smoothed out. It's going to be normalized, and you can keep it in that format. Now, in the data lake, we can query for certain data. We can run business intelligence tools on these data. We can run machine learning on the data. And the whole point of creating data is so we can make better business decisions. So typically speaking, what would it look like? We would typically take 3 databases. We used proprietary ones just to make this graphic a little simpler. We'd have data sources coming from lots of places. And then what we would do is we would normalize the data. Now, AWS has a proprietary service to normalize that data called Elastic MapReduce. Although what most people actually do is they write a Python Spark script from their database team, and that's used to normalize all of your data. Store it in the data lake, and once it's there, you can make much better business decisions, inferences, and better predictions. So I know next thing we're gonna get into is storage options. Actually, let me go for 2 minutes longer before I go to the next question. Let's talk about database storage options. If you're dealing with a database, where are you going to store your stuff? Well, I want you to think about this. Databases are sitting on servers. What kind of storage can we mount on a server? In the cloud, block storage. So we're going to be storing our data on EBS volumes. What kind of EBS volumes? Well, provision IOP, the provision IOPS volumes, meaning the highest performance ones, if we need them, potentially a RAID array of provision IOPS volumes. We could use general purpose SSD and magnetic storage. If we use magnetic storage for a database, the latency is going to be sky high, so for the most part, we're not going to be using that. So if it really matters, we're going to be using provisioned IOPS. If it's less important, we can use general purpose SSD, but we're going to be running into some latency issues for the most part with the database stuff. Lastly, let's talk about quantum ledger databases. The Amazon Quantum Ledger Database is a fully managed and serverless central ledger database which automatically scales for applications. Because it's serverless, you don't have to manage or worry about provisioning things, which is good. But because you don't have to worry about provisioning things, you lose control over performance, which is not good. So it's architecture. It's always going to be a trade-off. You get this, but what does it cost me? All architectural decisions are this way. And unlike a traditional database, when we're dealing with quantum ledger databases, it creates what's called an immutable volume. So what does that mean? Immutable means it can't be changed. So by using a ledger database, like this quantum ledger database, we can take our stuff store it to the database, and leave it there, and nobody can touch it. So we can't add a record, update a record, or delete a record. And that way it's there for auditing purposes. So it's really nice. So now let's look at a little more quantum database. The quantum ledger database tracks data changes by storing small amount of changes inside of a transaction, known as a journal, like your checkbook. The data stored in the quantum ledger database journal is immutable and cryptographically verifiable, meaning the data has not been altered, modified, or tampered with. Perfect for legal tracking. The quantum ledger database can track all changes made to any application while simultaneously providing verifiable change history. The Amazon Quantum Ledger database can track all changes made by an application to any application while simultaneously providing a verifiable change history. It's also ACID compliant, meaning atomic, consistent, the transactions are independent, the transactions are durable, like we talked about before, completely before. And that means that information that's there is going to stay no matter whether you had a network failure or not. The quantum ledger database is ideal when you need a repository of secured, accurate, and verifiable immutable business history. So preserving the authentic legal documentation of, say, vehicle ownership, vehicle title, vehicle registration, recording financial transactions for auditing purposes, fraud detections, forensic analysis, and employee history. So let's take it from there. I covered a lot of stuff. We'll stop. So let's talk about some database optimizations. Actually, before we do that, if you give me a hashtag, AWS Certified Solution Architect Associate in the chat box, hashtag AWS Certified Solution Architect Associate, I'll know you're awake, alert, and oriented, paying attention, because I want to know that everybody's paying attention. That way I know everybody's going to get a great learning experience. And if you've not subscribed or hit the bell or liked the video, please do so now, so we can distribute our free content to as many people as possible to truly help all those in need get some skills so they can build the careers of their dream. Eric and Mila Economy, I'm so happy to see you. Namaskar, namaste. It's good to see you, Eric. Alexander, so wonderful to see you. Super happy to see you all. Okay, I'm loving this. You guys are paying attention. You're awake, alert, and oriented. I know now that you're there, and I'm going to keep going. So now let's talk about some database optimizations. We're going to talk about some Amazon database optimizations. We're going to be talking about backups, automated backups, database snapshots, which I love, by the way, and encryption. So let's talk about how do you scale a relation. We're also going to be talking about scaling relational databases, which means we'll be talking about read replicas, caching, queuing, high availability databases, multi-availability databases, and of course, multi-cloud databases is really what you want to do. Now let's talk about backing up your database. Let's say you put all your data in a database, right? And the database started to crash. That'd be a problem, right? If all the business's data was lost. So we're going to have to back up our databases. Databases are mission critical applications. And here's the really cool thing. If you're using any of the AWS databases, the backups are automatically done. It doesn't just back up the entire database. It backs up the entire virtual machine. So you got a server, which basically is your Smith system, your applications like your database and all your data. And it backs up the entire server into a single image file. I love this. Why do I love this? Because now you've got a full system backup. Now you can move that backup to another cloud. You can move that backup to another availability zone, another region, and poof, you can instantly launch this database with 2 or 3 clicks, and it's brand new, and it's got all your databases, and it's perfect. So that's why we love the way AWS does its database backups. It is truly, truly amazing. Now what will happen is your databases will be backed up automatically, and you can retain their backups from 1 to 35 days, or you can move it into your own object storage bucket and keep it there forever. And the backup is going to happen during a defined window each day. And during the backup process, the performance of your database is going to be severely degraded, or potentially even unavailable for a second or two, but that's okay, because you're going to have a full copy of your database. And the way this works is it's going to be creating a snapshot. And a snapshot is really just a point-in-time copy, an exact block-by-block copy of the hard drive, the block storage that you're going to use, which could be turned into another virtual machine. Now we can maintain these database snapshots until we delete them, and that way we can bring a database back anytime we want. Now, what's it really look like? It's very simple. We've got our database, and poof, it just automatically makes these snapshot images. And it's these images that we can then use to launch a new database, and poof, we're up, we're running, and we're all kinds of happy. Now, since we've got a database snapshot, what happens if we ever want to restore it? This is where the beauty comes in. You restore it by basically launching the instance, the machine image you just made, and magically your system comes up, applications installed, database installed, and guess what? It's up and running. Now, the only difference is it's going to have a new IP address. And because it's going to have a new IP address, it'll have a new DNS address. So if you have a catastrophic backup, you come back to one of your EBS snapshots, your database snapshot, it's going to come up, but you're going to have a new IP address and a DNS address. So whoever's doing your applications will need to update the application to point to the new address. And it's up and running, and you're back, and your business is fully operational. So it's just going to look like this. We take our snapshot, and automatically we've got a new virtual machine, also called the new RDS instance, and everything is running beautifully. Now, if we're going to store our data on the database, what happens if somebody breaks into the data center and steals Amazon's hard drives? Or, for example, or gets information from your account? We don't want that, right? So we want to encrypt the data. By encrypting the data, it's meaningless to anybody that doesn't have the decryption key. So we're adding security. So let's talk about the encryption types supported by the AWS databases. We can encrypt the data at rest. What does that mean? When the data is stored on the server, it's encrypted. Basically what happens is encrypting the EBS volume, the block storage volume, which houses the database. This is very simple. We turn it on by enabling the AWS Key Management System. That's it. Key Management Service. And the Key Management Service makes it really easy to create and control your encryption keys. AWS also supports transparent data encryption. And if you're going to be using an industrial database like by Oracle or Microsoft SQL, it's going to be transparent. Transparent data encryption is also supported with Cloud HSM. I love transparent data encryption because it's a form of encryption that encrypts and decrypts your data on demand. So when you write the data to storage, it's encrypted. When you pull it from storage, it's decrypted automatically for you. And of course, we can use the Cloud HSM, which is a hardware security device, to manage your encryption keys, etc. Of course, we can also use encryption in transit. Kind of like when you use IPsec over the internet for a VPN, or IPsec over a direct connection for encryption over your private line. It's encryption in transit. Now, in most cases, when you're going to do encryption in transit to a database, you're going to be using the TLS Transparent Layer Security Protocol, which is going to use as an SSL-based certificate. So there's a certificate created that's going to authenticate your endpoints, just like with an HTTPS website. Now let's talk about scaling your databases. Since databases have become mission-critical applications, it's a platform that's going to need to grow dynamically to meet the demands of the application. Now, there's two ways we can scale databases. Or any device, we can scale up, and we can scale out. Now, what does scaling up mean? We've had our database on a server that's got 16 cores and 256 gigs of RAM. It's not enough. We now put it on a beautiful AMD server powered by EPYC CPUs. We've got 192 cores and 6 terabytes of RAM. That's physical cores, which gives us, over 300 virtual, close to 400 virtual cores. It's a beautiful system. But what's going to happen? At some point, that's not going to be enough capacity either. So we're going to have to add systems. Now, when we're dealing with databases, it's not like a web server we can basically use where we can use a load balancer to load share across servers. We're going to have to do something else. So there's different ways that we're going to scale out relational databases and NoSQL databases. If we're dealing with NoSQL databases, it depends upon the kind of database. If we're going to be dealing with something like DynamoDB, we might just partition it, which chops the database into partitions, and it's great. If it's Apache Cassandra, we just add more nodes, and we can write to all nodes. And Apache Cassandra is designed to run on commodity hardware. And if it's MongoDB, we could do kind of a combination of those things. We've got options that we can use based upon the databases. Now, that's for NoSQL databases. Now, what about relational databases? They're a little different. With relational databases, for the most part, except for one or two, we can only write to the master database, but we can read from different databases. So how do we do this? We add read replicas. So right now, there's a bunch of truly amazing cloud architects that have blue wrenches that are sitting here in the chat box. I see Eva Doike there. She's fantastic, an exceptional cloud architect that's there. I see Abigail Marks, a wonderful Army veteran and a terrific cloud architect. I see Alonzo Coleman from my team. I see Chris Johnson from my team. I see Chow M. Pham. She's the cloud architect extraordinaire. She's an incredible architect in every single way of the week. And, there's many other people that are there. And they're answering your questions while I'm presenting, because I can't look at a chat box, talk, and type back at the same time. It's not feasible. So they're kind of like read replicas. What do I mean by read replicas? They're answering questions while I'm writing or presenting. And I'm grateful to have these wonderful, wonderful, amazing people helping me today, as also being part of my community. So when you think about what's going on, the way you scale a relational database is as follows. You add additional people. So Chow's out there helping people right now, and while Chow's answering people's questions, I don't have to think about it. She's offloaded the read work for me, making life simple and elegant for me. And because now I only have to focus on presenting, not all that work. So read replicas are ways where you add additional compute to help with scaling. So when we scale out a relational database, it's by adding read replicas. So what is a read replica? It is a read-only copy, except in MariaDB, of your database instance. Now it's synchronized in real time, meaning real time, which means something gets written to me, the master database, and Chow, and Eva Doikia, and Chris, and Alonzo, and Abigail. They can answer you immediately because they can see it. So now we've got 5 people answering your questions. I'm not thinking about the questions, and what does that give me more focus on? Presenting. Now, if I'm a relational database and I've got read replicas, I focus on writing, and they answer the questions, again, taking load off. So read replicas are just additional servers to take the read load off of the database. So let's look at a little picture that I had drawn a while back. Here we've got traditional 3-tier environment. We've got our web servers, we've got our app servers, and we've got a database. And to make the database scale, they added 2 read replicas. So the queries or the information requests from the database can go to the read replicas, while the main database can focus on writing. It adds scalability. So when do you add read replicas? Well, you got a lot of read activity. If all my activity is right, or if nobody was asking questions in the chat box, would those read replicas be helping a lot? No. But if there's people answering in the chat box, I can't do it without those wonderful, amazing blue wrenches, so thank you so much. They're functioning as read replicas. So when there's lots of read activity, you need read replicas. If I told you the read load is 4 times greater than the write load, I would use 4 read replicas. So when the query or read traffic, when the database is slowing things down, add a read replica. If your database gets 2 requests a month, chances are you don't need a read replica. Now, read replicas boost performance. They don't provide disaster recovery. And I'm going to put this together for you. Now, let's talk about caching. What's caching? Now, let's say we've got Chow and Eva Doika over there, and Chris, and Eddie Patrick, and Alonzo, all kinds of great people all over the world. And let's say that Alonzo got asked the same question 60 times per day. The question you got asked is, do I need to code as an architect? And he says, no. And they got asked 3 minutes later, do I need to code as an architect? And he says, no. And they got asked the same question 30 seconds later, do I need to code as an architect? And he says, no. At some point, it wouldn't make sense for Alonzo to basically ask that question all the time. And he'd record, if that's the only question he got, he'd record it on his iPhone, do I need to code as an architect? And he'd say no. And as soon as somebody would ask the question, he would just play it and play it and play it. And he would save his voice so he doesn't get laryngitis like me. Now, that's what caching does. Caching offloads frequent requests from your read replicas. Now, let's say now that Alonzo got asked 20 questions. Question 1 is, do I need to code? Question 2 is, should I get a cat? Question 3 is, should I get a dog? Question 4 is, do I need to know the network? Question 5 is, do I need to know Linux? Question 6 is, how important is business acumen? Question 7 is, how important is leadership? Now, obviously, he couldn't answer the same question and push a button every time to answer the same question. So caching only works when your information requested is the same. The same. In fact, if you add caching and the questions are all different, it actually introduces latency and it reduces the functionality of your system. Reduces it. So caching is good, going back to the situation for a line that's asked 1,000 times a day. Do I need to code as an architect? No, 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 no. So there's that. That's why we use it. And what is caching really? It's a service where we take access of frequently accessed information and we store it in DRAM or memory so we can just serve it to people as needed without affecting our compute capacity. And that's what we use. So caching, or any kind of caching, whether it's content delivery networks, whether it's volume gateways in cache mode or database caching, is really sending requests for the same information to an intermediary stop before they get to the ultimate people that are going to answer it. Now, just like a content delivery network, to protect against stale data, the cache won't keep your information in there forever. But remember, caching will not help if each request is unique. So you need to know your data patterns before you recommend the caching in your architecture. You always need to know your business requirements, otherwise you never know what to do. Now, when it comes to caching, there's 3 ways to do this. You can build your own cache. Get your own virtual machine, install a Redis cache on it like you would do in the data center. You can do this nice and simply and elegant and deploy the same cache across your 3 different clouds, all in the same virtual machine. Or you could take the AWS fully managed cache, and they've got one called Redis and Elasticache and Memcached. They make the proprietary term Elasticache as the name of their service, but it's just a cache. You can create your own cache. Now, Redis is basically speaking the most feature-rich of all caches, and that's typically what enterprises use in today's world. Now, the AWS Elasticache for Redis is compatible with Redis, so you can migrate your Redis workloads to Elasticache, or you can make your own Elasticache. Now, Memcached is another type of cache, but when you're dealing with Memcached, it's got a much reduced feature set. It's really designed to be simplicity. So tools that are designed to be working with Memcached can be used, but most organizations are going to use Redis. And many of them will just set up their own cache. So how does caching help? One more time. It offloads frequent requests to the database server or read replicas. It lowers CPU and memory requirements. When to use caches to improve performance and reduce latency. to improve scalability when there's a lot of requests for the same information. What's it going to look like? It's going to look like this. You've got your web servers, basically using 2 availability zones, posting to your app servers that are then posting your information to the database. Read information instead of hitting the database if it's frequently accessed to the same. It's going to come straight from the database, be stored in the cache, and you'll be good to go. Now let's talk about queuing. And we're going to talk about queuing in the capacity of databases, and it's really great. We're going to talk about the AWS proprietary queue, which if you're going to be in a multi-cloud environment, you can't use. And I'll tell you what you could use instead. But we have to discuss the AWS proprietary technology because this is an AWS exam. So what is queuing? Queuing is just a means to schedule your delivery. Where have we all formed queuing? For the Americans, I'll give the example that's used in England because a queue is just a line. So if you go to England and you want to get on the plane, they say, please form a queue, which is a line. And then they say anybody with health issues gets on first. Anybody that's got a first-class ticket gets on second. Anybody in the rear of the plane then gets on third. And they migrate it on. It's queuing or scheduling. Now, why do they do it? Well, when I was a kid and I went to my home airport in Greece, and they said, everybody get on the plane. It was like we were all rushing to get on the airplane. It was kind of scary. Everybody's trying to get in the same door to the same place that's going at the same time. So to manage and schedule the delivery of who gets in the seats, the airplanes basically say first, second, third. Now imagine we've got a really critical, mission-critical business thing. Got our web server, and we've got, let's say, Abigail's here. I saw Abigail had a blue wrench. Abigail is probably the most beautiful cat in the world, Noni, even though Cindy might be jealous if I said that. But it's one of the prettiest cats I've ever seen. And let's say, Abigail, I'm running a business, and she wants to buy cat toys for her beautiful cat, Noni. And she hits the website, which is opening, and then she hits my application server and logs in, and then she buys 10 fuzzy cat balls, 3 fuzzy cat mice, and that message has to be sent to the database. Now, if the database is busy when Abigail's trying to buy cat toys for Noni, the beautiful cat, I don't get the order. Which means as a business, I lose money, and Abigail's cat Noni is sad because she didn't get her fluffy cat toys. So we can't have that. So what the queue is an intermediary stop. So first, Abigail hits the website, Mike's beautifulcattoys.com. And then that goes to the application server where she logs in. Then she orders the beautiful cat toys. The message stops in a queue. And as soon as the database has capacity, it gets taken out of the queue, placed into the database. And that way, the business doesn't lose any orders. So that's why organizations use queuing. So queuing is just a means to schedule your data delivery. Queuing is used in lots of applications as well. And we do it to decouple the traffic environment from our systems. So here's a picture that we drew of a cache. Sender sending message into the queue. I've been talking about a queue. The message deposits in the queue. When the receiver is ready, they pull it from the queue. And then the data, the message is removed from the queue. So simple, elegant environment. Queuing is used in everything from networking to applications to databases to jumping on an airplane. Now, when you use Amazon, you've got 2 queues. They've got the Amazon Simple Queuing System, which is their proprietary queue. It's a pre-built queue, which means you shouldn't be using it if you're dealing with multi-cloud. If you're dealing with multi-cloud, you've got Apache Kafka, and you can set up the same queues across all your clouds, but this is the AWS proprietary one, which is going to be what's on your AWS exam. Now, with the standard queue, they use what's called FIFO. As soon as the messages come into the queue and they can be drained, they're drained out of the queue. Fastest in, first out. I'm sorry, so first kind of queue is a simple queue. Fastest in, fastest out. Fastest in, first is out. And why do we use a standard queue? It's the most scalable and it's the fastest. That's the problem. There's no guarantee of message delivery. Now, does it really matter if I'm getting 100,000 orders for cat toys. If Abigail's cat comes in before Chris's cat, who comes in before Michelle's cat, who comes in before Mike's cat, as long as all the cats get their cat toys, no, it doesn't matter. But if I had an application that was dependent upon the messages being correct, we could, with SQS, we could create what's called the FIFO queue, or first in or first out. A queue where message 1 comes in, then message and goes out. Then message 2 comes in and goes out. But when we do that, we're losing the cost of performance. Because what if message 2 is 10 times greater than the size of message 3, 4, and 5? Then it slows everything down. Now, how does this queuing help? Well, let's walk through an example. Let's go look at the CPU performance of systems. So let's go back to our 3-tier architecture here. We've got our web servers, app servers, our queue going into a database. And here we go. We're going to be coming into the database to buy nothing other than cat toys. So if we don't have a queuing system, our traffic orders aren't going to be normal. Maybe we get more orders at breakfast, during lunch, and those kinds of things. So what have we chosen to do? You'll see your CPUs are going to spike up and down and up and down and up and down. And we're going to be reaching times where our CPU performance is 100%, and our disk performance will be 100%, and we'll lose messages. And we're going to have other times where our systems are going to be sitting idle and everything's good. That's not a good situation. By adding the queue, what you can see is we can smooth out the CPU and disk performance at maybe 40%, as opposed to going from basically 20% to 100% and then down. And as you can see, messages come in from the web server to the app server. They get dropped in this queue, and they get placed in the database when needed. So when do we use it? To increase scalability, and there's lots of write requests. To decouple our application architectures so that if one thing goes wrong, we don't lose messages. Extra assurance that you don't lose messages. Now we're going to talk about a couple of AWS tools. Now somebody asked me about, hey, how do you take your information from one database? Could you back it up to another database? And I said, you wouldn't want to. But what if you are migrating your data out of one database to put it into another database? Or you're pulling out data out of your database to do something else? Typically, you need some form of tool that's designed to do it. You can extract your data, meaning it pulling it out, transform your data to be in whatever format it needs to be another database, and then load it into another database. Now, every database has their strengths and weaknesses. One database might be able to be more scalable. One gives you better information between variables to make a different kind of business decision. And we're going to need to be pulling information from databases to another. Now, the less of this we do, the better. Because anytime we translate something to something else, so we lose something. Now, in Greece, if someone says, I'm going to change your life, I mean, they're going to beat the living daylights out of you, and it's not a good thing. But if I told Chris, I'm going to change your lights, he'd say, oh, you're going to come to my house and choose light bulbs. And I'd say, yeah, I'm going to come bring you fancy LED light bulbs. Never have anything negative to say about Chris, my chief operating officer. He's amazing. But what we're talking about is, that's the problem with these ETL tools. When we pull something and go somewhere else, things don't always translate. Now, Amazon has their own fully branded ETL tool. Of course, there's other very good commercial tools in the industry that are designed by database companies and special ETL companies. What to use, that's up to you. But Amazon has an ETL tool called Glue, and it is their branded ETL tool. And it's used to pull information from one database and put into another one. Amazon is a fully managed serverless ETL tool. They call it Glue. And basically speaking, you point Glue to where your data is stored. It discovers your data, creates a metadata catalog. And after the data is cataloged, it's query and searchable. And from there, whether you want to copy your data, load it into a database, data warehouse, that's kind of your thing. Pretty simple here. You can see we're using 3 databases, and we're trying to use something to take the information from one source of information and put it into another source of information. That's what we're dealing with. Now let's next talk about the schema conversion tool. The schema conversion tool. The schema conversion tool is something that will help you migrate databases. So the AWS schema conversion tool, SCT, is an AWS managed service that simply simplifies the moving of one database engine to another. So if you were going to your Oracle database in your data center and you wanted to move it to Amazon Aurora, you're going to need to get your data out of Oracle and into Aurora. And that's what the schema conversion tool is designed to do. When you migrate a database to AWS, the schema of your source database is going to be analyzed. Typically, they're OLTP/OLAP, and they need to get converted into a format that's used by the target database. And the schema conversion tool gives you a graphical interface to do these automatic schema conversions. Trust me, these schema conversions are never going to be perfect. And you're going to do the conversion, and then you're going to have to fine-tune your data before you stick it into the next database. We can use the schema conversion tool for migrating data between different databases and convert them. It's a helpful way to migrate your data from one database to another. And because it's an ETL tool, it extracts, transforms, and loads existing data. Let's talk a little bit about high availability network design. Database design. Now, how do you design a database for high availability? Well, truthfully, you put it in 3 clouds. But at minimum, you put your database in multiple data centers, otherwise known as multiple availability zones. Remember, AWS divides their network and their systems into regions and availability zones. Regions are a large geographic area like a continent or part of a continent, and availability zones are data centers inside of those continents. And a high availability database design at minimum uses multiple availability zones, so copies from database 1 to database 2. Now, by doing this, you're not increasing your performance. You're creating an active database in one place and a failover database someplace else. So if data center 1 goes down, data center 2 comes back up. If the primary database fails, or the primary server fails, the backup comes up. It's pretty cool. You write to the main database and it synchronously copies it to the backup database. So what's it look like? It looks like this. We've got our web servers, our app servers, and our databases. And you can see we've got our main database in availability zone 1, which is data center 1. We've got our backup database in availability zone 2. So what will cause your multi-availability zone database to fail over? Well, your database dies or fails, switches over. It's kind of beautiful. One of the data centers has a power outage or a network outage or any kind of outage, you switch over to the next data center. You change your database instance type, poof, it's going to swip you over to the backup, which is beautiful. You put the database under maintenance, like upgrading the operating system or patching. It's going to send you to the backup. Or if you manually reboot the system, like with a reboot with failover, then poof, you're going to go to the backup system. Now, the next topic that we're going to cover is networking. I'm going to basically talk a little bit about IP addressing, a little bit about the OSI or Open Systems Interconnect modeling. I'm going to touch on subnets without getting deep into them, briefly talk about route summarization, and then we're going to stop there. I'm going to tell you right now that we know that this is going to be, we're glancing over these things. I'm also going to tell you that the AWS Advanced Networking is too junior for what you guys need to know. So next month, we're going to do an AWS Advanced Networking course plus the stuff you need to know. We're also going to have a lot of subnetting and supernetting and BGP and routing things. So let's briefly talk about the OSI model. So what is the OSI model? Well, for network architects like me, network engineers like I used to be, and anybody that's designing systems, we need to have a common language or lexicon. You want to get kicked out of a chief information officer's office and fired in about 3 minutes? Tell him about your EC2 instances and S3 buckets. He's going to laugh at you, or she's going to laugh at you, because they're going to say, I don't know what that marketing babble is. Now, by comparison, if you walk in that chief information's office and you talk to them about their 10,000 virtual machines and their 6 petabytes of object storage, now you're speaking the same language. When we speak different languages, we have errors. So when it comes to system design or system troubleshooting, we must speak the same language. While we're at it, since we're going long, everybody please give me a hashtag, AWS Certified Solution Architect. So now we must speak the same language, a common lexicon. So Alex is here, Alex is Greek. If I say Alex posisa simura, he's going to say imadaxi posisa maikis, because we're speaking the same language. But if we had to translate that into another language, things got lost in translation. So when we communicate the network, we have to communicate it in terms. So we've come up with a 7-layer model that describes networking. Now I'm going to tell you right now, networking professionals like me work at layers 1 through 4. We don't go above that at all. But we also have to know about all of it. So let's talk about the 7 layers. At layer 1, that's the physical layer. Now, what are we talking about? If the physical layer is a wire, what are we transmitting over this physical layer? Electrons, right? Now, if we're going to be dealing with a fiber optic cable, what are we going to be transmitting? Laser light, which is what? Photons, okay? So the physical layer is the physical connection between our devices. Now, this physical connection could be a wireless thing too, but now we're getting into some weird stuff. So let's just talk about wire. Physical layer is wire. You're transmitting photons or electrons to send bits and pieces of data. Now, if you've ever had a computer, you notice that you plug it into the Ethernet card, right? And the Ethernet card is layer 2 of this. That's the actual physical device you're plugged into. Layer 1 wire, called the physical layer. Layer 2, where you've got a MAC address in your Ethernet card, it's called the data link layer. What do you send at the data link layer? Frames. That's why the first cloud that I worked on in 1996 was called Frame Relay, because we sent frames. So, layer 1 wire, layer 2 Ethernet card, MAC address. Now, layer 3 is where the fun begins for network engineers and architects like me. This is where we put a logical address, the IP address. It manually gets assigned to your system. It's not hard-coded into it like the MAC address, which is your Ethernet card, that's your data link. So layer 1 wire, layer 2 card, layer 3 IP address. Now, when we send our data, we have to determine the optimal way to send it. If we need reliability, we use TCP or Transmission Control Protocol. And we'll cover this much more in depth in the AWS Advanced Networking Plus What You Need to Know course. Now, what if we wanted to send real-time data? We would use the Uniform Datagram Protocol, or UDP traffic. So that's how we send the data called transport. So layer 1 wire, layer 2 card, layer 3 IP address, layer 4 the method that we send it. So layer 1 bits, layer 2 packets, layer 1 bits, layer 2 packets, layer 3 frames, layer 4 we're sending segments. Now there's this weird layer 5 session protocol. Basically, this controls the connection on both sides. What's being sent here is data. Think of an example as a socket. Then we're going to get to layer 6, which is presenting our data. That's the presentation layer, which presents all this lower layer stuff to the application. Layer 6, or the presentation layer, also does encryption. And layer 7, what we're talking about is the application layer, which is the application. So you go to a web browser, that's a layer 7 application. Layer 1 wire, layer 2 card, layer 3 IP address, layer 4 transport protocol, TCP, UDP, ICMP. Layer 5 session controls the connection. Layer 6 presentation deals with encryption. And layer 7 is application. Now, when we're dealing with the system, we need to address the system. So if I wanted to send mail to Super Chow over here, I need to know Chow's IP address. a child's mailing address. Because if I didn't, if I took a letter and I wrote Child T. Pham, Cloud Architect Extraordinaire, and I didn't have her city, state, street address, you know, the mailman or mailwoman might not know how to get to Child Cloud Architect Extraordinaire's house. She probably wouldn't. So because of that, we need an address. Well, if I want to send data to Eva Deutke's computer, another fantastically technical professional over there in Europe, I need to know her mailing address or her IP address. So when we're dealing with data on a network, we must know the destination address we're sending it to. And that's why many of us, for example, can do the following. They can do one of these three things. For example, they have the ability, you can have an address 123 Main Street, right? But somebody else has a different zip code or postal code for those of you that are not in the US. So every device needs to have an IP address and it needs to be unique. Now there's going to be two versions of IP addressing. 99% of what we're dealing with is IPv4. IPv4 has been around forever. It's still 90% of what we're dealing with. But there's also IPv6, which we're gradually, slowly adopting. When you're dealing with IPv4, we have public addresses and private addresses. So here's the problem. When IPv4 was invented many, many years ago, nobody knew what the internet was going to look like. Nobody thought of Internet of Things, whether just other sensors, IP-enabled refrigerators, IP-enabled smartphones, 6 houses having IP TVs in their house, printers. So the problem is, if we do 2 to the 32nd power, there's not that many IP addresses. There's a couple billion. But now we're dealing with an environment where many people have 5 to 10 different IP addresses per person, let alone businesses. So we ran out of IP addresses a long time ago. So the Internet Engineering Task Force, and if you want to learn networking stuff, you got to go to the Internet Engineering Task Force, IETF.org, created a specification, otherwise known as a request for comments, called the RFC 1918. And they established 3 places that all organizations internally use their IP addresses from. They're called private addresses, RFC 1918 addresses. Those addresses are as follows: the 10.0.0.0/8, the 172.16.0.0, all the way to the 172.31.0.0/16. So what that really comes down to is 172.16.0.0/12 and the 192.168.0.0 SuperNet. And those are private addresses. They're only allowed on internal systems. Now, you're going to hear the term site or range. Now, a long time ago, back when the dinosaurs roamed the earth, and, you know, I first started working in networking, which was lots of fun. You know, we had this thing called classful IP addresses. We don't have them anymore. And that basically meant there were things that would apply to classful boundaries. I'll show you what these boundaries are. They don't exist anymore. And what they used to be is, you know, Class A addresses all had a /8. Class B addresses all had a /16. Class C addresses all fit in this space and were /24. Class Ds were used for multicast. We still do use the multicast addresses. But here's the point. Any Class A address would actually burn 16 million IP addresses, almost 17 million. And now remember this, every device on your server, if you've got 3 network cards, needs to be on a different subnet. So if you use 3 Class A addresses inside of your server, you would ultimately burn over 49 million addresses on a single server, which is obviously a problem. So what happened was IP classes all went away. About 20 years ago, you used to have to put on a Cisco router IP classless until it became the default. And classless meant we no longer adhere by standard subnet boundaries, and we can subnet or supernet as needed. I'm going to cover that extensively in the AWS Advanced Networking Plus what you need to know. So what happens is modern routers enable us to subnet or supernet or change the classful masks on our network boundaries and it's called classless interdomain routing. All that means is we're not bogged down from the class A, class B, class C type things that you actually need. So consider AWS lets you use classless interdomain routing like everything else. Now, normally speaking, you're going to be given a CIDR block that you use for your IP address space, and you're going to have to subnet that down. So I can't in this discussion go over subnetting, but I can actually give you some examples of it. In order to use our address space, we've got to chop it down. So what does this really mean? Subnetting. Well, let's say right now, let's say you had a whole pizza, right? And you were just one person. Well, chances are you're not going to eat this extra large 18-inch pizza by yourself. If you do, you probably have some health issues long-term from eating that way. You might divide that pizza into 3 pizzas with your buddies or 4 pizzas with your buddies. The subnetting is basically taking a large IP block and chopping it down to the smallest thing. Maybe you've got some skinny friends that eat a quarter of a piece of pizza, and you could chop it into 16 pieces, and each one of your skinny friends eats 1/16 of the pizza. Maybe you got a couple of big friends, and you need to split it into 2 halves of the pizza. Maybe you got some hungry friends, and you need 3 pizzas for 2 people. I don't care. Subnetting is really about taking your IP address blocks, chopping them down, and making them exactly what you need. So for example, this was a Class C network, 192.168.1.0/24. It's a Class C. That means 254 addresses all on this single subnet. But it might make sense if we don't need all of those to chop it down into small subnets. So for example, I created one subnet, 192.168.1.0. I created another subnet, 192.168.1.16. I created a third subnet, 192.168.1.32. I can create another subnet, 192.168.1.48. And what you're seeing is I'm taking this one classful address, chopping it down to multiple ones, and getting there. Now that's called subnetting. Here's another example. I can show you those exact subnets that I just did. I can take this one subnet and chop it into multiple little things. Now, when you subnet an address, you always have to remember that you normally lose 2 addresses. So normally you use the first address and the last address. So let's take this first subnet. The 192.168.1.0 is actually used by the router as the network. That's what's going to be in the routing table. The end of that subnet is what's called a subnet-directed broadcast or an IP-directed broadcast, in which case I would send it to 192.168.1.15, which is all hosted see it because I couldn't use those 2. And then we'd have 14 usable addresses. Now, when you're on the AWS cloud, basically they reserve 5 of the addresses out of them automatically. The network one and the broadcast one plus 3 others. So they always lose 5 IP addresses per subnet with AWS. I'm just going to end on this route summarization concept. So if you're connecting to AWS, you've got to give them routing information connecting back to you. If AWS doesn't know how to reach your data center, and you don't know how to reach your subnets in AWS, nobody's talking to anybody. It means no matter how much stuff you have in the cloud, you got nothing. Something my grandmother would call bupkis. Nothing, 0. No matter all the beautiful cloud, no network, you got nothing. So supernetting is basically how you take the routes in your routing table and you aggregate those routes. And therefore you can send a little bit of information to the cloud provider versus all of your cloud provider. And what does that really look like? Well, look at it this way. If you've got 4 subnets, these are 4 Class C subnets that you have, and you want to only send one route to AWS, you can route summarize or aggregate these routes, pop it into BGP, and tell AWS, hey, to reach my data center, all you need to reach is 192.168.0.0/22. That gets you to the data center. What is that really like? Well, have any of you flown overseas, flown to a new city, and you don't know where you're going in the new city. So let's say I want to go to Denmark. I think Eva Doike is in Denmark, and I want to go visit her. I get to the Denmark airport, and then I got to get into a taxi. And I give the taxi Eva Doike's not IP address or street address. And the taxi knows how to get there. I don't know how to get there. I just need to know how to get to the airport. From the airport, I need to get to a taxi, and the taxi driver needs the intelligence. Why is this so critical? Well, too many routes in the routing table, you have routing problems. But also, AWS only takes 100 routes from you. Normal enterprise might have 30 or 40,000 routes in the routing table. So if we don't summarize, we can't really deal with AWS because they have very limited networking. Not because they're bad at all, but because when I connect to the internet on a normal router and run BGP, I'm taking in 800,000 routes. But when I connect to the cloud provider, imagine them taking in 3,000 routes, 10,000 routes from 500,000 different companies. The routers wouldn't handle it, so they make you route summarize and only send 100 routes. So for an architect, subnetting route aggregation is a really critical skill. Last thing I will end with today is just IPv6 addresses. IPv6 addresses are just a newer form of IP addressing. Normally speaking, with IP addresses, we have 2 to the 32nd power of addresses. But when we're dealing with IPv6, we've got a 120-bit hexadecimal address. So normally binary is 0 and 1. Hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. So that's how we get to 16. So it's 16 to the 120th power. Infinitely more address spaces, much more scalable, typically used by mobile phones. Every interface in AWS is automatically assigned an IPv6 global address. Most people will remove this global address because you don't want addresses that you're not using and just use the IPv4. We're going to talk about my absolute favorite part of the cloud. You know what it is? It's the VPC, or the virtual private cloud. Why? Because it's where we get to do as much networking as possible. And you guys know me, I'm a network person. Back when the CCIE was a complicated exam and it was challenging when it used to be 2 days, I remember taking mine. My CCIE number is 7417, and I love networking. So today we're going to talk about the VPC. Now, under the VPC, we're going to talk about a lot of things, but we're going to talk a little bit about routing. And we're going to talk about much more about routing when we actually go through the AWS Advanced Networking Plus, what you need to know. So we'll talk about that. Then, and it's a little now, but a lot when we do that. We'll discuss internet gateways today. We'll discuss egress-only internet gateways. We'll discuss NAT instances, but also NAT gateways. We'll discuss elastic IP addresses, VPC endpoints, VPC peering, access control list, security groups, and we'll have some more fun as well. But I want to begin with, let's begin with the routing tables. What is a routing table? Well, it's really a map of how your traffic gets to its destination. And routers build maps. The way routers typically build maps is they run a routing protocol. Inside the network, it's called an interior gateway protocol. Typically speaking, in today's world, it's using something called OSPF, or intermediate systems to intermediate systems. Routers identify with each other and they tell each other the state of their routes. When we connect to external entities, we use BGP, and I'm going to show you graphically what that looks like. And it builds a table that says, how do we get from point A to point B? What's this table look like? It looks like this. To reach Joey, go out my right arm. To reach Nick, go out my left arm. To reach Sally, go north. To reach Blake, go out my leg. So it's basically building a table. Now, I built a routing table for you in Excel just so you can get a feel for it. And it's going to look like this. The routing table is going to tell you the destination subnet and where to send it. Now, when it comes to routing, we're talking about the most specific route. And if you notice, I have two routes, which are very similar. I've got the 192.168.0.0/16. And I also have the 192.168.1.0/24. For those of you that know subnetting and supernetting and route summarization, you're aware that 192.168.1.0/24 falls within the 192.168.0.0/16. But which one's more specific? The one with the longer subnet mask, the 192.168.1.0. So if we want to reach the 192.168.1.0, we're going to end up using the interface PCX-654321. But if we want to reach any other subnet inside of that range, we're going to use the interface PCX-123456. And of course, we have a default route. What does a default route mean? If you don't know where to go, take the default route. And here you can see we've got a default route pointing to an internet gateway. And there you go. So that's realistically what we're talking about. Now, the VPC has a routing table. But let's talk about what they really look like in real life. Let's assume on the left side of this is 64513. This is your entity, your data center. And let's assume for right now, on the right side of this, we've got the AWS cloud. The Azure cloud, the Google cloud, your other data center, another company, it doesn't matter. It's all the same way. Now, inside of your data center or the AWS cloud, they're going to have to calculate the routes in between their stuff. And that's used with an IGP or an interior gateway protocol. We'll discuss them much more when we cover the AWS Advanced Networking. But for right now, understand, inside of an organization, routers have routing protocols that determine the best path for the traffic. Kind of like your GPS does. When you go to somebody's house, make a left, go 2 miles, make a left, go 3 kilometers, make a right. Kind of keep that in the back of your mind. Now you'll note that we have where it says eBGP peering between the two organizations. Now, BGP is a path vector routing protocol that's used to connect to external entities. So when you connect to your cloud providers, they are not your organization, they are an external company, and you're going to use BGP. Now, we're going to be using BGP to exchange certain information. I'll talk about what that is, but understand internally, all organizations have an interior gateway protocol, and in between them, they use an exterior gateway protocol, which is BGP. And when you connect to AWS, you are going to be using BGP to exchange routing information, especially if you're using a direct connection will be required. And if you're using a VPN, you could use BGP or create a static route, but you're going to want to use BGP because otherwise you're going to be manually updating routes, and that is a nightmare. I can't get into a full BGP discussion here, but I can tell you this right now. When we do the AWS Advanced Networking coming very soon, I will spend hours on BGP, hours on subnetting and supernetting. We'll spend time on interior gateway protocols. We'll spend substantial time on switching. And then we'll cover the silly, easy AWS Advanced Networking, which is honestly an intro to junior level networking. We're going to add that critical networking up front so you guys understand it because it's critical knowledge. So let's talk about a little bit about dynamic routing with BGP. BGP is the de facto standard exterior gateway protocol. And because AWS, Azure, Google, you connect to them externally, you'll be using BGP to connect to them. Now, the reason we use BGP as opposed to an interior gateway protocol is as follows. The tunability of it is incredible. The scalability of it is incredible. When I connect to 3 different internet service providers, with BGP, I'm taking in about 800,000 routes per internet service provider. I mean, it's incredibly there. So it's scalable. Whereas interior gateway protocols like OSPF kind of die once you hit 30,000 subnets or so. And there's lots of tuning and manipulation. Plus, we can't filter routes between us. And BGP gives us the ability to filter routes. And why does this matter? If you don't have a path to it, you can't reach it. So let's say I've got a buddy over there in England. I got lots of friends in England. And here I am in South Florida. Now, if there's no airplane and there's no bridge, I couldn't visit my friend. There's no route. So with BGP, you can provide the path that you want people to access, And you can provide no route to the paths that you don't want to access. Now, how would I get from Florida to England? Well, I could try and swim, but that's not going to happen. I'm going to run out of fuel and be eaten by sharks. I need a path. I need a route. And BGP provides the path. It provides the routes, the knowledge intelligence on how to get your data from point A to point B. Now, when an organization wants more than one connection to the internet, like 2 of them, they can either have one default route and a backup default route, in which case they use one and the other one sits there sleeping, or they can use BGP and they can load share. So BGP enables you to load share, traffic engineer, and tune your data. It's magical, magical. I spent over 10,000 hours learning BGP and working on BGP, and trust me, people like me that are network architects can do really cool stuff with this. And if you want to be a great cloud architect, you must be able to understand BGP. Otherwise, your systems will fall apart. So we'll cover that in more depth with the AWS Advanced Networking. It's not covered in the AWS Advanced Networking, but we'll cover it anyway, and we do that completely free. Now, when you use BGP, you kind of have to identify yourself. So, basically saying, hey, yo, I'm Mikey. Yo, Joey, let's be friends. And that's really what has to happen. You actually have to connect to each other, identify yourselves, and set up your policy. So like I said, when you use a direct connection to AWS, you must use BGP. Now, BGP's got a lot of tuning things. When we cover the AWS Advanced Network, we're going to get deep. We'll prepend AISs and leak specific prefixes and change the weights, play with the local preference. It's going to be party time, party time, party time. That's about the only time when I talk about networking where I get to put my propeller hat on and get real geeky anymore, and I love it. Because I started out as a techie. It's just that I can't be a techie as an architect. I got to be a business executive. But when I talk about BGP, put my techie hat on, and it's fun, fun, fun. So, well, one thing we'll talk about is AWS supports the BGP community no export. I'll show you what that means in a second. The AWS BGP implementation supports the proprietary weight, which is great because lots of other routers do too. Local preference, AF path, specificity of routing information. So it's a pretty standard BGP implementation. But AWS only allows you to inject a very small number of routes, like 100, which is 0. It's basically nothing. So when you're going to be connecting to AWS, you better have somebody that understands IP addressing, subnetting, or supernetting. So you can use summarize and route aggregate. Now, let's briefly talk about what no export means. So normally speaking with BGP, let's say you've got 3 of us that want to talk to each other. We've got my data center, my superstar architect, cloud architect Chow, Alonzo, also from my team, my chief content officer on our team, and we want to exchange information between us. In a normal environment, if I connect to Chow, and now Chow collects to Alonzo, I know how to reach Alonzo through Chow. Alonzo knows how to reach me through Chow. So what happens is Alonzo's traffic wants to reach me, and here's what will happen. It'll go through Chow to me, and then I'll respond, and here's what ultimately is going to happen. I'm going to respond back. My traffic will traverse Chow and go through Alonzo. And we're all happy, right? Because we've got routing. But here's the problem. What if Chow doesn't want to be the entire destination for the entire internet to connect me through Alonzo? Well, what would happen, and to make this simple, is we tell Chow our routes, and Chow doesn't tell anybody else our routes. So if by comparison, I tell Chow my routes, and Alonzo tells Chow her routes, his routes, loop this around, and Chow tells me her routes, which are not putting the arrow, and I tell Chow my routes, I can reach Chow. Now, if Alonzo tells Chow her route, his routes, and then Chow tells Alonzo her routes, they can talk to each other. But if Chow doesn't send Alonzo's routes to me, I can't reach Alonzo. And that's typically done via a BGP community called no export. There's many other ways to do this, but AWS does support that no export community, to kind of keep that in the back of your mind. All right, so we had a little introductory to BGP. We're going to do it a lot better in a lot more depth when I actually have 4+ hours to do it when we do the AWS Advanced Networking. Like I said, it's not covered in AWS Advanced Networking, but we're going to cover it because you need to know it. So how do you get to the internet? Well, you need a router that connects to the internet. Now, what's the alternative name for a router? It's called the gateway. So this is one of the few places where AWS didn't have their marketing people spend millions of dollars to create a fancy name that doesn't mean anything to anybody. An internet gateway, what do you think it is? It's a router that takes you to the internet. I love this name because it's reality. And an internet gateway is going to be a virtual, because it's a cloud, it's all virtual, router. And because it's a virtual router, not a physical router, it can't go down. So this is going to be a highly available internet router. Now, AWS for certification points will tell you there's no bandwidth constraints or performance limitations. Look, there's always a bandwidth constraint or performance limitation, and you'll have to figure that out as it takes to testing your applications. But at the end of the day, the internet gateway is nothing more than a router that connects you to the internet. So the way you create an internet gateway, that's a very simple thing to do, is you attach an internet gateway to your VPC, you create a default route, which looks like 0.0.0.0/0, pointing to the internet gateway. You put a public IP address on the internet gateway. Why does it need a public address? It's going to reach stuff on the public internet, needs a public address. And there you go, you're good. Now, here's the thing to remember. You've used an internet gateway. Now your stuff will be accessible from the internet. Now, if your stuff is available from the internet, accessible from the internet, and you don't do something about it, you'll be hacked in about 15 minutes. So when you're connected to the internet, you're going to need to do some serious security things. Otherwise, you're going to get hacked. So let's look a little bit about what this looks like, at least in concept and principle. Here you can see we've got our stuff in our VPC, where we have the term instances. You can think about them as maybe a web server, an FTP server, whatever you want, reachable by the internet. The instances all need to have a public IP because they're not behind a load balancer here. And the internet gateway needs to have a public IP. And there you go. Our systems are going to be reachable through the internet, and people can attach to our web servers, FTP servers, or any other kind of server we want to put there. Everybody's happy. Let's say we've got a cat. My cat Cindy made a website, www.cindythecat.com. She puts it on some of these servers, and we got photos of my cat Cindy dancing, my cat Cindy sleeping, my cat Cindy climbing the walls, sitting on the roof, running away from her scary friend, the Maine Coon, which is a beautiful cat that she doesn't like, so she hides on roofs when the cat comes, and it's all on her website. So kind of keep that in the back of your mind. Now your systems are available from the internet. Now let's talk about something different, an egress-only internet gateway. So let's talk about this. Ingress is traffic coming in. Egress is traffic going out. When this was first explained to me, it never made sense. So I like to think of it as a parking lot. When you enter a parking lot to go to your favorite pizza place, that's ingress. And after you had your pizza and you're full, and you leave that parking lot, that's egress. So let's talk about egress-only internet gateways. They allow your IPv6 traffic, not IPv4, which is 99% of your traffic, to go out to the internet and have stuff come back to them, but not be reachable from the internet. So why on earth would you ever want egress-only internet traffic? Because it sounds crazy, right? Well, it's not. So let's say you want all your systems secure behind the firewall so nobody can come into them. But you want your systems that are behind the firewall and your users to be able to go out to the internet, to go buy training from www.gocloudcareers.com, and then you want them to go to www.cindythecat.com to look at some cat photos, and then you want your person to be able to Google something, and then you want your systems to be able to update their operating system from Red Hat, Ubuntu, Microsoft, or whatever. That's where you need egress-only internet access, where you want your systems to go out to the internet, be able to do something, allow the return traffic back in, but not allow other traffic to come in. So that's what we're talking about when we talk about an egress-only internet gateway. It's for IPv6. It enables the traffic to go out to the internet and come back, but your systems are not reachable. So how's it work? Well, it's stateful, just like a firewall. Traffic goes out, comes back. Other traffic externally tries to come in, block, block, block. But here I am, and I want to go look at my, I don't know, Facebook account where I've got cat Cindy photos. I don't have any cat photos on Facebook, but let's say I want to go to my Facebook account. I would go through the egress-only internet gateway, and when the traffic comes back from Facebook, it would hit that egress-only internet gateway, which acts like a firewall here, and says, yep, Mike requested it, send the traffic back to Mike. So no inbound activity, traffic out, traffic back. Used for IPv6 systems to go out to the internet and come back. Now, we're going to talk about a NAT instance, which was kind of an AWS managed service, which has been sort of, we don't recommend you do this anymore, but there's still times where you're going to need to create these on your own. So let's at least talk about what it is. A NAT instance is basically a system like a virtual machine that's got 2 Ethernet cards in there that translates a private address into a public address. Now, this was available from AWS as an AMI, so basically a systems image, and it runs on an EC2 instance. And in this particular case, NAT is only going to the internet. So you have to put part of it in a public subnet and part of it in a private subnet. And what happens is, and I'll show you later, NAT instance will then translate your private addresses to a public address so they could go out your internet gateway. So no inbound internet access. And the way this will work is as follows. Let me draw you a picture. You would keep your systems in a private subnet. You would create this NAT instance, which is just a virtual machine with 2 or 4 network cards. This NAT instance would do something called NAT overload, otherwise known as port address translation. And it would translate your private IP addresses into a public IP address. Your systems would have a default route to the NAT instance. The NAT instance would have a default route to the internet gateway. The NAT instance would have an external IP address. The internet gateway would have an external IP address. And all your systems would have access to the network, the internet. So that's a standard AWS NAT instance. Now, what if you wanted to translate between 2 IP addresses? Well, you could obviously create a Linux machine on your own, put 2 Ethernet cards in there, and translate between a private address and another private address. And why might you want to do this? Well, let's say I addressed my system 10.0.0.1, and I bought a company who addressed their system 10.0.0.1. Wait, they can't talk to each other, but if we NAT between them, then we can. So there's lots of use cases to use NAT. These are only the ones that we're mentioning. Now, if you notice that NAT instance required an internet gateway to work. So AWS likes to make people's lives simple. The whole point of the cloud is it's simple. We lose features, we lose functionality, we lose performance, but it's simple. We go to the cloud because it's agile, it's fast. We don't need as much sophistication because they manage 3/4 of the workload for us, which is kind of beautiful. That's why we all love it so much. So AWS came up with a simpler, more elegant solution for most people. And it's called the NAT gateway. And the NAT gateway kind of combines the NAT instance and an internet gateway in the same device. So a NAT gateway is a fully managed NAT service. And NAT gateway is redundant inside of an availability zone. Every availability zone will require its own NAT gateway. So what happens is you create the NAT gateway in a public subnet. It will have an, an external public IP address, which AWS likes to call an elastic IP for the life of the gateway. You'll put a default route on your systems to the NAT gateway. And then your systems can reach the internet and then your traffic come back, but they will not be reachable from the internet. Remember, this is egress only, just like the egress only internet gateway, except for the egress only internet gateways for IPv6. And this is for IP version 4. Simple stuff, simple stuff, simple stuff. So let's look at this under the concept of what we're doing here. You can see here we've got our systems in a private subnet. We've got our NAT gateway, and they can go to the internet. But remember, our systems will not be reachable from the internet. Our systems, our servers can go out there and update their operating system, collect new operating system patches, and all kinds of good stuff. Go through the firewall and get out to the internet. And our traffic can come back. Simple, elegant solution. So now let's talk about the Elastic Network Interface. This to me is the most ridiculous name in the world. When you have a server to connect it to the network, you plug it into its Ethernet card. When you have a virtual machine, guess what? It's got an Ethernet card, and a virtual one usually, although it could be a physical one if we talk about single root IO virtualization, which I'm sure we'll address soon. But what's going on is if you ever want to put your virtual machine connected to the network, you need an Ethernet card. So what does AWS call the Ethernet card in your virtual machines? They call it an Elastic Network Interface. So by default, your systems come up with a single Elastic Network Interface. But if you want two systems to be on two different subnets, well, then you could use two of them. Now, in many certifications, they teach you how to create something called the bastion host, which is about the fastest way to get hacked, fastest way to get fired. So I'm not going to teach you how to do that. There's a way to do it intelligently, but 99% of them that I've seen out there are hacking events. I've seen people get fired for putting these things up there, so I'm not going to teach you how to do that because I don't want you getting fired. I know they teach that in a lot of certification courses, but there's good reasons not to do it. We've got a video on why you should never create a bastion host, and my team can pop that in there. But if you had a server that you wanted to have on two different subnets, you could put two network interfaces in there, and that's what we always used to call a dual home server. Now, we can have a management subnet on one side versus another side, inside, outside of our network. So there's lots of reasons we might want to do these things. So let's talk a little bit about Elastic IP addresses. Okay. Now, AWS could just say public IP address, and I'd be happy, 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 right? But, you know, they don't. If you want a public IP address from AWS, they have to stick the word Elastic in everything. And because they have to stick the word Elastic into everything, they call it an Elastic IP address. It just means a public IP address. So here's how normal you would get a public IP address. You've got a network architect like me. I need a public IP address. I go to my ISP and I request one. And I own it until I'm done with them. Now, by comparison, with AWS, when you need a public IP address, you get one of their Elastic IP addresses. They own the address. They give it to you for as long as you need it. And when you shut your system down, it goes back into the pool, and they can go and resell that IP address to somebody else. An Elastic IP address can have a single public IP address mounted to it, like at the edge of a load balancer. Or it could be used in a NAT overload situation, like you would in a NAT gateway, which provides port address translation. A little bit of an appearance of what's an Elastic IP address look like. Very, very simple and elegant. Very simple and elegant. Here we go. We've got our private systems. We've got our instances, which are sitting behind the firewall, all using the public IP address, otherwise known as Elastic IP address, 3.3.3.3. Goes out to the internet, and we should be good to go. Pretty simple and elegant. So let's get into the next thing. So if you guys can give me all a hashtag that says AWS Certified Solution Architect Associate in the chat box, I know you're awake. I need to know you're awake. I'm teaching here with laryngitis to try and make sure you guys have a good learning experience, and I want to know you're awake. So now let's talk about VPC endpoints. VPC endpoints are essentially devices that are high availability and enable you to connect to things. There's two kinds of endpoints. There's gateway endpoints and there's interface endpoints. Let's first begin with gateway endpoints. Gateway endpoints are high-speed, high-security access to AWS services. And what happens is it places a route in your routing table. And gateway endpoints are typically to things such as Amazon S3. And what happens, it'll put a route in your routing table and it'll reach AWS S3. So you'll create an endpoint, it's going to create a prefix list, and it'll attach you to the endpoint. The reason we're using the endpoint is it's going to provide secure access. Let me show you what it would look like without the endpoint. So let's say we were inside of our VPC, our virtual private data center, and we wanted to connect to Amazon S3. There's really two ways that we could do it. Way one would be to go all the way out to the internet, cross the internet, and come back to AWS and reach our S3 bucket. Now let's talk about why that's ugly. Well, we have to go to the internet, and that's outbound traffic. And guess that one, we're going to pay for all that traffic to go to the internet. Now the internet is not secure, so we're going to have to encrypt that traffic. Then it's going to come back in. So cost is a reason we don't want to do this, but the internet is not guaranteed, has no guarantee, so the performance of the internet isn't good, and the internet's not secure. So now we have to encrypt it. So let's think about the alternative way. If we didn't want to go to the internet per se, and we just wanted to use the AWS private network, a network with guaranteed speed, guaranteed performance, and guaranteed capabilities, we could just send our traffic directly over the AWS private network, and that's what the endpoints are for. Endpoints provide secure, private, high-performance communication, and now gateway endpoints are to reach AWS services, like S3. So let's talk a little bit about gateway endpoint security. We can set up an endpoint policy that can be set up to limit resources, like to the S3 bucket. We can limit routing information so that not everybody knows about the endpoint. If you don't have a route, you can't reach it. It's some of the best security in the world. And we network architects and network engineers were providing security for decades. And here's what we're doing. It just didn't give somebody a route. If they didn't have a route, they couldn't reach it. And then we would use access lists, firewalls, and all these other cool things. But first part of security is don't give somebody a path to you. So if you wanted to build a really secure house, right, and you created an island in the ocean, and you needed a boat or a helicopter to get to you, it'd be more secure than if you built your house in Philadelphia, for example. I'm from Philadelphia, pretty high crime area, so I can tell you right now, if I had a house in the middle of the ocean, it'd be less likely to get hacked than if it was in Philadelphia. So keep that in the back of your mind. Now let's talk about the next kind of endpoint, the interface endpoint. Now, interface endpoints are a way to connect to several AWS services, like EC2 Systems Manager, Kinesis for streaming data, Elastic Load Balancer APIs, or external services hosted by AWS partners or other customers in their own VPCs. Now, an interface endpoint is going to work differently, and it's really kind of cool, actually. Basically, what's going to happen, now if we had a gateway interface, what happens to the previous kind, it puts a route in the routing table. Now here, when you create an interface endpoint, it effectively puts another network interface or an elastic interface on your VPC. And your interface is local to the VPC. And when you create this interface endpoint, AWS will create this network interface in your subnets that you want to have access to this, which is going to be pretty cool. And then when you create the endpoint, AWS will automatically generate a fully qualified domain name so people can connect to it via domain name. What's a domain name? mike.gocloudcareers.com. That's a fully qualified domain name. And it's going to give you something just like that. Another really cool point of interface endpoints is they use a service called AWS Private Link. Look, I love Private Link. I've been working with the equivalent of Private Link now for 30 years, well, 25 years. Feels like 30 and dog years, so to speak, because I've been doing it forever. And Private Link is basically what's called a virtual private line. And what is a virtual, and it's going to restrict all traffic between the virtual private line. So let me draw it out what a virtual private line looks like for you. Because, you know, if you're not used to private lines, then you're definitely not going to be used to virtual private lines. Let's go back to my fancy drawing board. So let's say you've got, we used to call it the frame relay cloud. It could be the internet cloud. It really doesn't matter. So we've got us over here, our VPC, and we want to connect to somebody else's VPC over Private Link. Now, realistically speaking, there's two ways we could do this. Option one, we could connect to the internet and back to the internet, and woohoo, everybody's talking to each other. Now, we have to understand that by doing this, we've got internet security issues, and the performance of the internet is not guaranteed. So we have no guarantees that the internet are there. But what we could do instead is, if this is the AWS private network and they control the private network, AWS, what they can do is they can create us a virtual private line directly across to it. And we'll call this Private Link. And it's basically a pseudo wire, a fake wire they're creating for you. It's no different than an MPLS-TE tunnel, a GRE tunnel across a private network. They're building you a private wire. So they're giving you much, much better access to their own network. The reason we can't control our traffic on the internet is our traffic goes through 10 or 12 different entities. But when it comes to Private Link, we're only using the AWS network. And you can guarantee performance across your network using signaling, things like resource reservation protocols, things which you don't need to know about for this. But we can't guarantee performance across the public internet. And this is when you're already on your systems. Not, for example, if this was a direct connection getting to AWS. So let's say we're doing this. Let's say we've got a VPC over here to the left side of the screen, another VPC. We can basically create a private link connection between us, and everything is done. This is done internally. This is the equivalent of a pseudo wire, and we're good to go. I didn't share, let me share this photo with you. So in this particular case, we've got a service customer, and we've got a VPC, and we're creating that pseudo wire in between them, and that's the way they can talk to each other. Very simple, very elegant solution. Very elegant solution. Now, there are other ways to get our systems to communicate to each other. And the other way is VPC peering. And I'm going to get into VPC peering in a minute. But before I do, I'm going to give you some backup information about the difference between Private Link and VPC peering. Private Link is only going to allow you access to a single service. So I can create a Private Link connection, and I can only give people access to the Cindy.com website and nothing else. My cat Cindy, she's pretty popular these days. She's like internet famous because she's always doing fun stuff. So access to just Cindy's beautiful photos of her doing silly cat things. By comparison, VPC peering is a little different. I have my VPC, I connect to Superchild, the amazing cloud architect VPC, and she and I can exchange everything between us. So Private Link, I give Chow access to just Cindy the cat photos, and she's happy looking at my silly cat Cindy. But now I want to connect to Chow, and I want to share information, I use VPC peering. We're going to get into VPC peering in a minute, but when you use VPC peering, every organization must have private addresses. I mean, must not have overlapping addresses. So if I'm using the 10.0.0/16 space, and Chow's using the 172.0.0.16.0/16, 172.16.0.0/16, yeah, and we have different addresses. Chow and I can use VPC peering, and we're all kinds of happy. Well, what if Chow, my super architect, and she's an amazing architect, read RFC 1918. And I read RFC 1918. And we decided to both use 10.0.0.0/16 on both of our systems. And now we've got overlapping IP addresses. Much more common than you think. Now my systems and Chow's systems are not eligible to use VPC peering because VPC peering does not work with overlapping IP addresses. Now, when we've got overlapping IP addresses, our systems can't talk to each other. No big deal for we network people. We just use NAT to translate between them. But VPC peering doesn't let you use NAT. So when you need to deal with overlapping IP addresses with organizations, which is extremely common, because all organizations use RFC 1918 private address space, Private Link automatically does NAT. So we'll keep that in the back of the mind. Now, VPC peering, which we're going to get to in a minute, enables you to connect to other virtual private clouds or virtual private data centers. But you can't get more than 125 connections. That's nothing. 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 It's like zero. Me then, deep with the butt piss, as my grandmother would say. Nada. Zilch. Nothing. Where Private Link gives you much more scalability. Private Link, they'll tell you the limits are based on the max throughput achieved by your load balancers and servers. There's some other stuff beyond that, but for your test, Private Link's limits are only based upon the limits of your load balancers and servers. One last thing, Chow and I have VPC peering between us. She can get access to all my information, and I get access to all her information, and it's unidirectional. I could set it up where Chow could only see photos of Cindy the cat, and I can't even reach her. Whereas with VPC peering, it's like opening a full conversation between two people. Both sides can get access to everything. So now let's talk about what is VPC peering. VPC peering is simply a means to connect two private virtual data centers to each other. Now, VPC peering provides a non-transitive connection, and we'll do some demos and explanations here. What is non-transitive? It means if I connect to Chow and Chow connects to Alonzo, I can't connect to Alonzo through Chow. I can just connect to Chow, and Chow can just connect to Alonzo. That's called non-transitive. VPC peering always uses private IP address space. And inter-region VPC peering, meaning going from like the US region to a UK region or an Asia region, is encrypted. Let's look at basic VPC peering, and then we'll talk about some challenges and workarounds. This is normal VPC peering. I've got one VPC, I've got another VPC, and we do VPC peering between us, and we can exchange organizations, information. Now, it's common to have a lot of VPCs. You might actually find 1,000 VPCs in your own organization, let alone external organizations. And here's the reason why. In my data center, I can do beautiful micro-segmentation. I can create different subnets for different systems, and I can route between those subnets and put ACLs between every subnet or access control lists. Very simple and elegant. In my VLAN, I can do rate limiting, admission control, and all kinds of cool stuff. Yes, I have greater security in my data center than the cloud if I design it right. I don't have access to any of those cool security features in the cloud. None. So sometimes the only thing that I can do in the cloud is to chop my company into multiple virtual VPCs, multiple mini organizations, and then use BGP and routing to connect between them. This is some of the complexity that we're trying to do in the cloud to try and equal the security we naturally had in our data center 10 and 15 years ago. So we're going to be dealing with a lot of VPC peering. Now, as I mentioned, VPC peering is not transitive. I'll explain what that means, which means you've got two options, hub and spoke and fully meshed. Now, if anybody wants a funny math challenge, I want you to understand why 125 VPC peering connections is deepata, nada, zilch, zero, even, zaba, bupkas, whatever you want to call it. The formula for determining how many VPC peering connections you're going to be is n times n minus 1 divided by 2. I hate math, so let me explain this to you. If we've got 3 VPCs that we're going to peer, and I'm going to show you this in a minute, It's simple. 3 times 3 minus 2, n times n minus 1, so 3 times 2 equals 6 divided by 2, and we've only got 3 peering sessions. Simple, 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 right? Now we've got 10 VPC peering sessions we need to do. So 10 times 9 is 90 divided by 2 is 45. Wait, only 10 VPCs? What about organizations that have 1,000 VPCs? So 25 VPCs. 25 times 24. Now you're getting there. Divide by 2. See, we've already exceeded the 125 peering sessions that we're allowed to do. So let's talk about hub and spoke, when you'd want to use it and when you wouldn't want to use it. So let's first talk about an environment where we want everybody to talk to everybody. Here we go. We've got 3 VPCs here, A, B, and C. A is on the bottom, B and C are up top. Because we have VPC B paired with VPC A and C, VPC B can talk to A and C. Because VPC C is paired with A and B, VPC C can talk to B and A. And because VPC A is paired with VPC B and C, VPC A can talk to B and C. So here we go, everybody. Now everybody's talking to everybody. Pretty simple, right? Simple, easy. But what if we didn't want everybody talking to everybody? Might that occur? So now let's pretend I'm a computer manufacturer. And I want to connect to other organizations. Perhaps I want to connect to a DRAM manufacturer. Let's call them VPCB. And an NVMe drive manufacturer, call them VPCC. And a CPU manufacturer called VPCD. And an SSD manufacturer called VPCE. And a GPU manufacturer called VPCF. And another GPU manufacturer called VPCG. Now, do I want my 2 GPU manufacturers, NVIDIA and AMD, talking to each other through me? Of course not. So here's a perfect place where I can do hub and spoke. By doing hub and spoke and having non-transitive routing, I can connect to everybody, but they can't connect to each other through me. So here's where security is good. But now, what if I want everybody to talk to each other? For example, what if I wanted B to be able to talk to C through A and D to connect to A through E and A to connect to C? Well, I've got 2 options. Option one is I fully mesh them, but as I told you very quickly, we're going to get through those 125 peering connections very quickly. Option 2, I break the rules. And there's 2 ways where we can break the rules over here. Our rule-breaking options are something called Transit Gateway and CloudHub. For the certification providers that are going to make it sound very different. For the people that build their clouds and know networking, they're pretty much the same thing, and I'm going to show you the subtle differences between them. So in iBGP, or an interior BGP, we have the same problem called non-transitive. We get into the same silly hub and spoke environment that I talked about before, where VPCB will tell A and A can't tell C, so they couldn't reach each other. So for those of you that are in networking and understand BGP, you may recall that there's this thing that you can use to break the rule, and it's called the route reflector. And all a route reflector tells BGP is, hey, be transitive, by the way. And it would tell VPCB when it tells VPCA's routes to tell it to C. So we need some form of route reflector kind of technology on the cloud in order to do this, in order to do so. So this is where CloudHub comes in, and Transit Gateway. When you need to break the rules of non-transitive routing, you need a route reflector. Same solution we've used externally forever. And what happens is you've got multiple VPCs. You want to create a hub and spoke network. Hub and spoke networks are used everywhere. They're used in airlines. For me, for example, if I want to fly to New York and I live in Palm Beach, I fly to Atlanta and I go from Atlanta to New York. Hub and spoke. I want to go to California. I fly to Dallas and then I get to San Jose, or Houston and I get to San Jose. Hub and spoke networks. In networking, they exist forever. Connect to the New York office, and that connects you to other places. Connect to the San Jose office, and that connects you to other places. So what we're dealing with in the cloud is they decided to rename the route reflector and call it CloudHub. And CloudHub enables your systems that are connected via VPNs to have transitive routing on the cloud. Each site will use eBGP to connect to this little device in the center, and then our routing will work. So what's it going to look like? Here we go. We've got our cloud. We've got a Boston office, a New York office, our Washington office, and a San Francisco office. We all connect into the cloud. We use CloudHub over here, which means it can only support a VPN connection. Transit Gateway supports obviously direct connections and some other things. And now we've enabled our cloud to allow transit networking. So now Boston can talk to San Francisco through the cloud. Washington and Boston can talk to each other through the cloud. We've effectively created a transport network with VPN CloudHub. Now, the only problem with just VPN CloudHub is it only works with VPNs. And what happens when you need high-performance networking, high-performance computing? You don't want to use VPNs. So that's where AWS came up with the concept of Transit Gateway, which realistically speaking is the same thing. But Transit Gateway is the following. Now we can use private lines, for example, and connect to these systems. Still using eBGP, which doesn't have the non-transitive routing properties of IBGP. It's not forcing people to become familiar with route reflector technology. It's simple and elegant technology, and we've created a transit environment. So unlike CloudHub, with Transit Gateway, we can still use VPNs, we can use private lines and other network forms of transport, and that's why Transit Gateway is pretty much the way to go. Now, Chris, I'm going to get into access control lists and security groups. Okay, so let's get into access control lists. So normally speaking, on a router, we'd create multiple subnets and we put an access control list between them. An access control list effectively says Cindy subnet is allowed to talk for Cindy's subnet is allowed to talk to Caddy's subnet. That's what we're talking about. Now, reality is, in here, we're going to do it via subnets. So network ACLs keep unwanted traffic out of a subnet. And network ACL allows or disallows traffic based upon a configured policy. The default policy by definition is to deny all traffic. So an access control list is going to have to specify the source and destination address, protocol, and port number. Access control lists are stateless, and because they're stateless and they don't have any knowledge of the state, they can be configured inbound and outbound. Inbound and outbound. So let's talk about how you put an access control list in order. You do the following. You create a rule. And I'm going to show you the why and reason the rules matter so much. Rule 100, deny all traffic. Rule 110, allow TCP port 80 traffic. What do you guys think is going to happen? Tell me in the chat box what's going to happen. Tell me right now what's going to happen. I can tell you right now. But tell me in the chat box what's going to happen. Rule 100, deny everything. Rule 110, allow TCP port 80. What's going to be denied, everybody? Tell me. It's going to deny everything. Why is it going to deny everything? It's going to deny everything because it already says deny. So it has to be done intelligently, correctly. We have to put it in sequence. So now let's change the sequence. First, we don't need to put any denies, and here's the reason to deny. It's implicit. The only time we do a deny, we would do a deny, and then a permit is maybe we have one bad host that we want to deny, and we want to permit the rest of the subnet. So yes, then we would do certain things, or we could just deny a single IP address. Now, what if I told you to just create a single rule? Rule 110, allow TCP port 80 from any source to any destination. What's going to be allowed in? Tell me what's going to be allowed in. Rule 110, allow TCP port 80. And while you type that, after the problem before was, the reason the order matters, if we have a deny before an allow, and the deny is everything, everything would have been denied. Okay, Alex, we're going to allow web traffic into the web servers. Yes, Jeannie, port 80 web traffic is going to be in. Jason, port 80 web traffic is going to be in. Billy Manning, allow web traffic, so good, good, good. Now, because what you're dealing with is the ACLs are not stateful, meaning they have no way to track that you went out and to allow your traffic back. That's why you need to apply them in both directions. That's why. So now let's say we're going to do it together. Everybody give me Rule 110, allow TCP port 443. What's going to be allowed in? Specifically, what kind of web traffic is going to be allowed in? Basic unencrypted web traffic or only encrypted web traffic? Tell me in the chat box, everybody. Alexandros, Polikala, HTTPS, good job. Jason, HTTPS. ABG, HTTPS. Okay, perfect. Secure, HTTPS, web traffic. Okay, you got it. This guy's got it. It's encrypted, it's encrypted. Now I'm feeling excited. I'm happy. So we have to put them in order. We have to apply them inbound and outbound because there's no state. Now let's see what it looks like, because this is going to be a test question, test question, and more test question. Here's what we're going to see. We're going to see our network access control lists are used to keep traffic, unwanted traffic, out of a subnet. And then we're going to talk about a security group, which is to keep unwanted traffic out of a host. Access control list, unwanted traffic out of a subnet, network access control list, they like to call it. Security group keeps traffic outside of a host. Now, a security group, so while an ACL protects your subnets, your security groups protect your host. So let's talk about what that means. A security group is a stateful ACL. What's the stateful ACL called? A firewall, everybody. So a security group is similar to a host-based firewall. Does this mean you shouldn't put a host-based firewall on your server as well? Of course not. You're going to use both. Because when it comes to security and availability, 1 is none, 2 is 1, and 3 is greater than 2. But a security group keeps unwanted traffic out of a subnet. Out of a host. And a network access control list keeps security groups out of a subnet. Which you're going to use? Both of them. You can't just use one. You're going to need both and then some more. So all good system designs are going to include both, and more both. So keep that in the back of your mind. A security group being your host-based firewall. Now, when you write a security group, you don't need any denies, you just do allows. Why? Because you're only allowing stuff into a server, the minimum amount of stuff that you need to. If I want to allow FTP, I'm going to allow FTP, not that we allow FTP anymore in today's world. If I wanted to allow TFTP, which we don't do anymore, we'd allow TFTP for the most part, which we don't do. If I wanted to allow secure FTP, I would just permit a rule to allow secure FTP, to allow HTTPS or HTTP. So we just create a security group, which tells. Now, when we create a security group, they're smarter than access control lists. All rules will be evaluated prior to denying traffic. So if we made the mistake of saying deny any, and then permit afterwards, well, at least all rules are going to be evaluated. So we're in a better shape. But only inbound rules are necessary. Why only inbound rules? Allow this stuff to come in. Because once it's come into us, we know where it's coming from. We're tracking the state of the connection. We allow the return traffic out. So let's going back to this diagram. What are we really talking about here? We're talking about the following. We've got our network access control list protecting the subnet and our security group protecting our hosts, our virtual machine, our instances, or any name that we choose to call it. Now, what if we wanted to create a network and use the cloud? So there's two ways you can create your own network. You can hire somebody like me and say, I need a network with 10,000 locations, and I'll design your beautiful wide area network. I'll determine the routers you need, the switches you need, your routing protocols, and I've been doing it for decades. And when I design a network, it's going to work, it's going to be high performance, but it's going to cost you money. Because if you've got 30,000 locations, realistically speaking, you need 60,000 routers. These routers could be $30,000, $40,000 each. Each router is then going to need its interfaces, might need a WAN connection. Each WAN connection, say it's $1,000 a month. Then I'm going to need 3 CCIEs at $300,000 a year to be able to maintain this thing, at least to design it, high-level stuff. I'm going to need a network operations center. I'm going to need some basic network engineers that can keep stuff and running and build the stuff that we architects do. And it's going to get real expensive real fast. Or if we're connected to the cloud, we could actually use the cloud to build our entire wide area network. What that's called is a transit VPC. It's another way to create a hub and spoke environment through the cloud. So a transit VPC, it pretty much is an intermediary that allows you to connect multiple VPCs, multiple customers, multiple organizations through something. What about a service provider? Let's not go that path for this class. It's essentially a way to use the cloud as a private network. Now remember, you could create multiple VPNs on the internet. You could do it. Each VPN is going to need a router and a connection to the internet. But here's the thing. Internet bandwidth is not guaranteed because it traverses multiple internet service providers to get to your destination. But you can guarantee the performance on your network. AWS can guarantee the performance on their systems. So we can create this transit VPC. We can basically connect to anybody who's connected to the cloud already, and we can use the cloud as a conduit, as if it's a router. So a transit VPC acts like a cloud router and directs all traffic, in much the similar way of VPC peering in CloudHub. When we use a transit VPC, it has hubs and spokes. And we use BGP as the routing protocol to exchange information. The data is never going to be routed through the public internet, but use the AWS private high-performance network. It's an elegant thing. The transit VPC has all spokes directly using it, and it's going to be using our exterior gateway routing protocol, otherwise known as BGP. Data keeps flowing, and it's privately and it's automatically encrypted across the private network. So private network with encryption, high performance, high security, elegant. Very elegant. Okay, let's talk about implementing network performance and placement groups and what they are. So let's say you had a low latency application. I'm going to tell you right now, most of your critically low latency applications, you probably shouldn't put them in the cloud. You should keep them in your data center. By putting them on the cloud, you've got the latency of your wide area network connection, multiple network hops, slower storage, and all the challenges that come from a virtualized environment. But if you wanted to, how do you achieve the best performance in the cloud? And this is where we get into placement groups. Now, placement groups are logical groupings of your servers inside of a single availability zone. Instances in the placement group are close to each other or proximate to each other. And by putting your stuff close to each other, what you really get is lower latency and high performance. Kind of keep that in the back of your mind. And so we're going to talk about the kinds of placement groups you can actually deal with. So the first kind is a clustered placement group. Clustered placement group is the way you get your best performance at your lowest latency. Now, in architecture, everything is a trade-off. Everything is a trade-off. So if we put our stuff close together, the latency to connect to our devices is nothing, right? Yes. But let's talk about what can go wrong. Generally, placement groups are where your servers are all in the same physical server. And you're not traversing the network at all, just the backplane of the server. So you've got very low latency and the incredible performance. But you've got very, very little redundancy. So let's talk about what we're dealing with. If you put all your servers in the same rack, and they're connected to the same network port, to the same power distribution unit, hopefully 2 power distribution units, and there's a power failure in the rack, your whole placement group is gone. Can't have that. The circuit breaker blows. Can't have that. Now, what if all your stuff is in the same server, and the server encounters a hardware failure? Whoa, okay, now you're still down. What if the switch that's connected to the server fails? You're still down. So cluster placement group, critical performance. Look, I've worked for banks when they needed critical low latency. And here's what we did. We had 2 racks side by side, each plugged into different outlets, two different power supplies, 2 different power distribution units, multiple switches plugged into the back of these things. And that way, if one died, we'd fail over to the other one kind of instantly. We couldn't even use regular routing to get through the routing. We had to come up with specialized routing to tune this to get maximum failover performance. So clustered placement group, lowest latency, highest performance, single point of failure, scary. If you're going to create one, create a second one. So let's talk about a way that's going to give us good performance, but not necessarily optimal performance. This is going to be a partition placement group. And in a partition placement group, our instances are grouped across racks. This protects against failure of a rack power, network switch. And because we're providing systems across racks, we've got a little more latency, not much, but excellent performance with much lower risks. So what are we really talking about with regards to latency? The speed of light, which is 186,000 miles per second. Now, when we go 1,000 kilometers or more to the cloud, that has latency. But if we go 20 feet in the data center, is that latency worth talking about? It's not. So a partition placement group is, inside of the same data center spread across racks. Excellent performance. Not quite as good as a cluster placement group, but, we're getting into some serious stuff here. Good performance, high quality networking. Rack 1, Rack 2, Rack 3, all in the same building, same data center. So good performance, we don't lose money. Now, let's say we want a little more availability. What if the data center fails? It could happen, right? Data centers fail. So now let's talk about a spread placement group, okay? So here's what a spread placement group is. AWS has these regions, these large geographic areas, and they've got a bunch of data centers in the same region. And a lot of their data centers could be across the street from each other or close to each other. So a spread placement group is when you put your stuff and spread it across availability zones in the same region. So by doing so, what could we do for you here? We can put 2 in building 1, 2 in building 2. We've got a fiber optic connection between them. So the latency is still relatively low latency. We've got a much higher availability system. Now, believe me, this is higher latency than a clustered group. but it's got much more availability. So when it comes to architecture, there's never, ever, ever, ever a single thing that we can do. The key is as follows. What do we need for this application? What's the need that we're going to do? I don't know if I shared my screen with the cluster spread placement group. It's going to look like this. Now I understand what we're actually dealing with the spread placement group. Now let's talk about some kind of network performance and training. I'm going to use some complicated terms that I hate it. I hate marketing fluff. So if you've ever worked in a virtual machine environment in a data center, and let's say you were dealing with a VMware server and you needed really good performance, like GPU performance. Well, a virtual GPU's performance is terrible, but a physical GPU performance is great. And if you've ever built a virtual machine that was designed for machine learning, you might take your virtual machine and you might push 4 Quadro 8000 cards into a single virtual machine. And that's called PCI pass-through. And what that does is enable you to put a physical card directly into your virtual server. And we've been using this for machine learning for a while. People that would create lots of devices that needed high performance. Now, the problem is when we deal with a network card in a virtual environment, it's not the physical Ethernet card that's in the system. It's a virtual card that's created in software. I want you to think about this. Hardware fast, software slow. So for people that were mining Bitcoin on their GPU, they might be able to do a few thousand hashes per second. But if they bought an ASICs or hardware, they could do trillions of calculations per second. Thousands versus trillions. Hardware is fast, fast, fast. Software is slow, slow, slow. So if we needed high-performance networking, the first thing we could do is push a physical network card directly into our server. So you'd think they'd call it physical network card. But no, marketing people get paid a lot of money to come up with crazy names to make it sound cool. So the first network performance option we have is something that's called Single Root I/O Virtualization, SR-IOV. Here's what it means. Pop a physical card and pop the physical card in and push the physical card in the virtual machine. And there's that. Now, the next thing that we're actually going to talk about is as follows: the virtual fabric adapter. For organizations that need real high performance, the other alternative with AWS is they've created a specialty software driver. And the software driver can offer some incredible performance. And the performance can go up to 400 gigabit per second. It's not there yet, but the driver is designed to support this. So what we're dealing with here is very, very cool stuff, network performance options, and there we're going to go. And I see there's something about a puppy in the chat box. I've always wanted a puppy in my entire life, but my wife would only support cats, and I'm allergic to everything, so I have a cat named Cindy. Now, we're going to get into DNS next, Chris, and DNS is going to be a topic that I'm going to need to spend 30 to 45 minutes on. Right, now, give me a hashtag AWS Certified Solution Architect Associate so I know you're awake, alert, and oriented. Remember, I'm a medical person. In medicine, somebody falls over, we say, hey, what's your name? Who's the president? What's going on today? Where are you? Because we want to know that you're oriented towards person, place, and time. So give me a hashtag AWS Certified Solution Architect Associate. And then we'll get back to the content as long as I know that you're there. It's hard to do this. I've had laryngitis now for 2 weeks, and I want to make sure that we're doing it and you guys are paying attention. So I want all of you to have the best possible careers. Fantastic, fantastic. I know you guys are here. Now let's talk about DNS and Route 53. What is DNS, everybody? DNS is simply a way to map a name to an IP address. So let's say you wanted to connect to an IP address. You could do it any day of the week. You can put the IP address in your browser and it's just going to work. No big deal. Now the question is, can you remember everybody's IP address? My wife, yeah, she can remember everybody's IP address. Here's a phone number. Lisa, the phone number is 256-345-78910. And I asked Lisa, what's the phone number? And she'll tell me a year later, 10 years later, 30 years later. Now me, I don't remember what time I'm supposed to be somewhere sometimes. I'm exaggerating the concept. But, you know, for me, it's very easy to remember Cindy the cat. That would be easier than to remember her DNA sequence. That would be harder to remember. So since every device needs to be reachable, that you want to be reachable needs an address, you could either be a genius like my wife with 170 IQ and remember everything, like an elephant, or you need some sort of mapping agent. And this is where DNS comes into play. It's very easy for me to remember Amazon.com. But out of curiosity, let me do an NS lookup and actually find the IP address of Amazon.com. The IP address of Amazon.com is 162.219.225.118. Now, which do you think is easier to remember? Amazon.com or 162.219.225.118? Well, I'm going to tell you right now, I can remember Amazon.com and I already forgot the 162 after the 219. Now remember it a week later, and now we got challenges. So DNS is really a means to map a name to an IP address. Here I go, I'm sitting on my browser, I type www.amazon.com. Now my computer goes to the DNS server, the DNS server returns the IP address, and my browser redirects me. Now here, I'm going to actually do an example with you. Every one of you, all of you, I want you to open up a window. On Windows, it's going to be your command prompt. If you're on a Mac or on a Linux system, open up a terminal and do the following with me. Let's go find the IP address for gocloudcareers.net. So every one of you type NSLOOKUP, November, Sierra, Lima, Oscar, Oscar, Kilo, Uniform, Papa. Leave a space. And then after you leave a space, type www.gocloudcareers.com, just like I did in this example that I'm sharing with you right now, or at least I meant to be sharing with you right now. And here you go. What IP address did you get on your computer? You did an NS lookup. Pop the address that you got in the chat box. Now that IP address may be different than it was when I ran this, but here's what you're going to do. You're going to do an NS lookup, and you're going to be able to find the IP address to any website. After we do mine, do an NS lookup to www.cisco.com. Big website. And that's what DNS is doing. It's mapping a name that we can remember, like gocloudcareers.com, and we're mapping it to the IP address of 192.0.78.217. There you go. Now I can remember gocloudcareers.com, but 192.0.78.217, that's a little harder for me to remember, even if it's my own IP address. So that's why we came up with these things. But DNS can also do some more. But let's go what talks about what goes into a DNS name or a domain name. A domain name is going to be broken down into three sections. Now, when we talk about a fully qualified domain name, we're talking about the following. The host name, which is the given name of the endpoint. The domain name, and the top level domain. So if we go to www.gocloudcareers.com, the host name is going to be www. The domain name is going to be gocloudcareers. And the top level domain is going to be .com. Could be .net, which are also on. But those are the kind of things that it could be. So fully qualified domain name. Host name, MikeEC2.GoCloudCareers.com is a fully qualified domain name. Now, we work with DNS. You got to be dealing with something called DNS records. DNS is kind of like a database that maps IP addresses to different addresses. So we need to have these things. So when we're dealing with DNS records, we're dealing with something called the zone file as well. Same thing, DNS record, zone file, I don't care what you want to call them. And what they are they're sets of particular instructions that are located in the DNS servers and provide information about the domain. The records are in a particular format known as DNS syntax, which is a type of text file. And the DNS syntax is instructions to tell the DNS server how to carry out its action. Now, when we're dealing with anything on the internet, we have something called the TTL, or a time to live. And the TTL with DNS is how many seconds it will take for the DNS servers to refresh its information. So why do we need a TTL? If I put an IP address and it was permitted in the DNS, and then we changed IP addresses, nobody would ever figure it out. So we can't leave records up there forever. Now, there's a tremendous number of DNS records that you're going to need to know, and we're going to talk about them. So kind of keep that in the back of your mind. Understand when we talk about DNS and AWS, we're going to be talking about Route 53, which is AWS's highly available, scalable DNS platform, which uses something called Anycast. It's low latency, high availability, supports health checks. But here's the thing to remember. If you want a high availability cloud architecture, a true high availability cloud architecture, you're not going to use AWS Route 53. And here's what. AWS Route 53 is the AWS proprietary DNS system. So now imagine you use Route 53, which is great DNS, by the way. And now you've got the Azure cloud, the Google cloud, and your Nutanix cloud, and the AWS cloud. And now you're using all your DNS from AWS. And AWS goes down. Guess what? None of your other clouds are going to work either. So when you're dealing with high performance, high availability systems, you can't afford to use your cloud provider's DNS. You're going to need to use a critical high availability system, the kind of thing that we've always used from F5 or any other way you want to do it. And we're going to put DNS servers in each cloud and data center. Now, you don't need to know every DNS record, but there are certain DNS records that you, for the most part, need to know. You need to know the A record, which will cover, the AAA record, which will cover, the C name record. You definitely need to know some of these start of authority records and MX records and the C name record. We'll probably I'll cover a few more of them, but kind of keep this in the back of your mind. They are critical knowledge. So let's start with the most fundamental record, the simplest thing. The A record, it maps a name to an IP address. 1.2.3.4 to prettycindythecat.com. One day I'm going to make a website, prettycindythecat.com, if I ever have more than 5 minutes to myself. And if I have 5 minutes, I usually spend it with my cat Cindy or my wife. And it just maps a name to an IP address. Now that's with IPv4. A record, one address maps to the IP address of the website. Simple and then. Now, what if I had an IPv6 address? Well, then it wouldn't be an A record anymore. It would be an AAA record. AAA record. So an A record and an AAA record are identical. The difference is an A record is used for IPv4, an AAA record is used for IPv6. Now, next on the list, we have a C name record. Oh, why do we use a C name record? Well, I'm going to show you why we use a C name record in a second. So, okay, so let me make this a little bigger. Chris, I'm going to need your help figuring out how to share a window on my screen. Let me go deal with this. Bear with me. Let me present a window. Share a screen. Window. Okay, can you guys, okay, good. You guys can see my screen. So I did an NS lookup about Amazon. And if you notice, what you're really going to see is, first, these are my Google DNS servers. Why does it have a hashtag 53? Well, 53 is the ports, the DNS, the TCP UDP ports that are used by DNS, and that's why it's relative. That's why it's 53. AWS calls it Route 53. And you're also going to see that Amazon.com, this is actually its DNS name. Now, this is what's pointing to it. Now, what is this ugly thing? This Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net. That's actually the address of the content delivery network that's used by Amazon.com. Now, if you think any of you are ever going to remember that, except for my wife or those of you with photographic memories, you're not. But you can remember Amazon.com. So a scene name record will map Amazon.com to this ugly, clunky name, which is the actual name. So it's effectively like it's mapping one IP address to another IP address. And that's why we're creating a scene name record, to map one IP address to another IP address. I'm going to stop sharing right now if I can figure out how to do that. Share screen. And Chris, you can stop sharing that. Okay, so there we go. So that's why we're creating a scene name record. It's not exactly an alias record, but it's kind of mapping a domain to another domain. Now let's talk about an NS record, or a name server record. Well, we've got DNS servers, but we need to know what are the real DNS servers. The most authoritative servers, the servers to trust. Servers that propagate our organization's DNS information to the rest of the internet. We need an NS record that identifies those servers. Now let's say you want to receive email. So my cat Cindy, she's cleaning her fur, doing cute little hand stuff, and she wants to send an email to her friend Sonny the cat. Well, if you or your organization wants to receive email, you need a mail record called an MX record. So an MX record, what we're dealing with, is really a record which tells you which mail servers can accept and receive mail from your domain. Last record we're going to talk about is something called the Start of Authority record, or SOA record. And that's the primary name server responsible for your domain. It tells you the responsible party for your name. And it'll have a timestamp that lists any changes that were made in a number of seconds before your information should be frozen. So now let's talk about Amazon Route 53. Route 53 is a highly scalable proprietary DNS service provided by AWS. If you use AWS and AWS alone, it gives you a very nice low-cost method for DNS. It supports IPv4, but IPv6, but remember, it's proprietary. And if you use multiple clouds and AWS goes down, you lose all your clouds. So you don't want to be using something like this in a high availability environment. You want a high availability DNS solution. But for your exams, here you go. Now, there's nothing wrong with the service. It's a great DNS service. The problem is when you put all your eggs in one basket and the basket gets dropped, all your eggs are lost. That's why people diversify their portfolios and don't have a portfolio of a single stock. That's why organizations never use the same service provider. When they have a WAN, they use two different service providers. That's why it's insanity to use a single cloud when you should be using multiple clouds. Same problem. Now with Route 53, you can route customers inside or outside of AWS resources because it's standard DNS. And you could use Route 53 to connect to AWS and Azure and Google. The problem is if Route 53 goes down, you lose your other clouds. You don't really want to do that. The way DNS servers always determine whether your endpoints are healthy with a health check. So they work via health checks. I'll be describing health checks in a minute. I may actually give you a health check right now. So Chris, are you on the other end of this phone right now? I'm going to do a health check. Here's what a health check is. Let's say, Chris, is there anybody else behind the scenes like you right now?
No.
Okay, so it's just Chris. Chris, are you there?
Yes.
Chris, are you there?
Yes.
Chris, are you there? Ooh, Chris just failed his first health check. Chris, are you there?
Yes.
Oh, good. Chris is here. Now, I can keep sending traffic to Chris. But let's pretend I had 2 people there. Now, there's going to be Chris 1, and there's going to be Chris 2. Chris 1, are you there?
Yes.
Chris 2, are you there? That's scary. Chris 1, are you there?
Oh, sorry. I was me. I'm over here coming up with accents and I'm muted. Yes. Chris 1 is here.
Chris 2, are you there?
Yeah, man. We jamming.
Okay, good. And Chris knows I love Bob Marley and anything Jamaican. Chris, are you there? 1, are you there?
Yes.
Chris 2, are you there?
Yeah, man.
Okay, see, I'm happily sending traffic. Now, Chris 1's going to get really tired and lazy and not be there. Chris 1, are you there? Uh-oh. Chris 2, are you there?
Yeah, I don't know what happened to the other man.
Okay, Chris 1, are you there? No, he's not here. Chris 2, are you there? Chris 2's there. Otherwise, we're in real trouble.
Yes.
Chris 1, are you there?
Yes.
Okay, now the Chris 1 just passed the health check. Okay, I was hoping Chris 1 was not going to be there so we could revert all traffic to health 2. What the health check is your system is asking somebody if they're there. If they don't respond, you send your traffic to the other device. But it doesn't always work, and it completely clumsy, uncoordinated, no matter where you try to do it live. So there you go. And that reminds me, I need more turmeric tea for my laryngitis. I did have some Bambi this morning with breakfast, but I need some turmeric tea. So now if we're going to use DNS to determine what's available and map a name to an IP address, can we use it for more? And the answer is, of course we can. We can use it for high availability. So let's deal with high availability. We're first going to begin with a simple routing policy. And a simple routing policy is the most basic form of routing. And what are we talking about here? You have one DNS record and it maps to a single IP address. So Cindy the cat maps to 1.2.3.4. Simple routing. Very, very simple. Now, that's great if you've only got one website. But what if you have something different? Let's say you want to send traffic to 2 places. Let's say you want to spend 50% or 75% to your data center, and you want to produce 25% to the cloud. Well, you could use a weighted routing policy. Weighted routing is really cool. You send 50% to Azure, 50% to AWS. AWS goes away, send 100% to Azure. That's weighted routing or weighted routing. Weighted routing is also good when you've got new applications. So let's say you want to test a new application or a new website in this particular environment. We could send 85% of the traffic to the website that's existed for a long time and 15% to the new website. And that way, we could test it with a subset of our customers before rolling out a brand new website to the entire world. What if the website crashes? So when you see blue-green deployments and things like this, they typically use, for new applications and new code, they typically use some form of a weighted routing policy. Latency-based routing. Latency-based routing enables you to direct your traffic to the site or the region with the least traffic. Now, how does this work? Well, it really works based upon your IP address. See, I go to the internet, and it determines via my IP address that I'm in South Florida. It will send me to the web server in South Florida. Now, what if I was in Tokyo instead of South Florida? Would I want to go to the Florida website? Probably not. I might want to go to the web server in Tokyo or Kyoto or someplace else that would be close. By comparison, that's what latency-based routing does. It determines where you're at and determines what's the lowest latency server next to you and sends you to that server. That's pretty cool. Latency-based routing. I'd like to look at it this way. You hit our site, which one's got the lowest latency, send it to the site with the lowest latency. We're not Go Cloud Architects anymore. We're Go Cloud Careers, but there you go. Maybe these slides a long time ago. Now let's talk about failover routing. I love failover routing. Failover routing is done by the following. It enables you to create your active and passive systems. So send all traffic to AWS. AWS has a cloud outage, send all traffic to Google. That's failover routing. And that works via the health checks that we didn't demonstrate as elegantly, but I'll be demonstrating a health check very soon. The point of failover, it's going to check the health. And if one goes away, there's good. So let's look at it in this environment. Here we go. We've got our main servers. Go Cloud Architects primarily goes to the primary one. But if it fails, it goes to the secondary one. That's called failover routing. I absolutely love it. Geolocation routing. Now, this is really, really cool. Geolocation routing policies looks at your user and puts them to the website that's closest to the user. But we can get pretty cool with this. Let's say you're in a country like Cameroon. I have so many wonderful people with us from Cameroon. Now there's an English side of Cameroon and there's a French side of Cameroon. And if you want something in English, it's pretty easy to do. So we could set up a routing policy that could say French side in Cameroon goes to the French web page. English side goes to the English side based upon your source IP address. So that's actually called geolocation router, and it sends you the source that's closest to you. But think about countries where you speak, there's 3 languages in these countries. Many countries, there's 2 different languages. Many regions, there's 2 different regions. You know, Greece, where I'm from, is pretty close to Egypt, which is pretty close to Israel, which is pretty close to Turkey. Well, in Turkey, they speak Turkish. In Egypt, they speak Arabic. In Israel, they speak, well, Arabic, as well as Hebrew, as well as English. And in Greece, they speak Greek. Figuring out my IP address and sending me to the right website is the determination whether I buy something off of that website or whether I read it and go, I don't know, it's not Greek. And I don't know how to read it. So, you know, I kind of love these kind of things, but we use it like this. I love geolocation routing. Where do you go? Go to the place that makes more sense to you. No, multi-answer routing policy to me is ridiculous. It's the biggest random thing in the world. I don't do random. I don't do random at all, but geo-proximity, I mean, multi-value answer is you've got multiple entries, and it's just going to randomly pick some to choose from. Kind of like rolling the dice, and I don't like rolling the dice with any architecture. Here, throw the dice in the air, and where are you going to go? Which one of these websites you're going to? But it still uses a health check. So we'll only send your traffic to a healthy system. Now let's talk about geo-proximity routing. This gets a little ridiculous here. This lets you divide your region into different parts of the world. And AWS then lets you kind of do the following. It enables you to create something called the bias, which is going to spread and shrink regions. And by changing your regions, you can shift where your traffic's going to focus. Keep that in the back of mind. I've never used it for anything. Then again, I'm always going to use my own DNS. In a tiny business, you can use the DNS from your provider. In a big business, you've got to manage your own DNS servers. And if they need a cloud architect, they're going to be managing their own servers. So let's get back into this concept of the health check, which I tried to demonstrate before. It didn't exactly work, but my team didn't coordinate it ahead of time.
I'm a quick learner.
That's okay. The health check's going to monitor the functionality of our stuff. Anything's have fun when you go live. If the system doesn't respond to the health check, it'll be marked as unhealthy. Now, I wasn't sure if this slide was here because we got our slides beautifully redone, and I was trying to create some availability, but it is, so let's do it. Here I've got 2 responses. Hey, server 1, are you there? Yeah, it responds, yeah. Server 2, are you there? No response. That's getting scary. Server 1, are you there? Sure am. Server 2, are you there? No response. Server 1, are you there? Woohoo! I'm here. Server 2, no response. Shift all traffic to server 1. So Chris, the next topic is load balancers, which is one of my coolest, favorite, most happy things to talk about in the entire world because I love them. They improve performance and availability. Okay, let's get back to the content, everyone. Now let's talk load balancers. I love load balancers. I think they're the coolest thing ever. We network architects don't work with them, but you know, they're cool. And why do I love load balancers so much? Well, load balancers are devices, and yes, I called it devices, that enables you to increase system performance and availability at the same time. Wait, better performance, making sure the systems are there when you need it? Well, how could you not want that in your system? Load balancers can reduce costs, and I'll explain to you how, but they can really help with scalability, and here's why. They can let you use multiple servers and makes them act like a single server. And in many cases, it may be cheaper to buy more small servers than one giant server. But also, let's say you, instead of using a 256 core server, you had decided to use 8 32 core servers. Now, here's the thing. Now, if you use 8 32 core servers and one of those servers fails, you still have 7 left. But if you use a 256 core server and that fails, you got nothing. Like my grandma would call it butkas, or dibata, depending upon which grandmother I have, the Jewish one or the Greek one. So when you're in this position, the load balancer removes that single point of failure. Now, the load balancer improves scalability as why? Because, you know, I might need 8 servers, but if I need 9 servers, 10 servers, 11 servers, 500 servers, by using load balancers, I can keep spreading the load, and no one's the wiser. So I can allow a lot of performance, and at the same time, I can produce availability by removing single points of failure. So I love single points of failure. Now, how do load balancers remove single points of failure? Through a health check. Server 1, are you there? Yeah, I'm here. Server 2, are you here? Yes, I'm here. Server 3, I'm here. I got it. I love it. To kind of keep that in the back of mind. That's why we're using load balancers, to improve performance and availability. Now, load balancers, don't think they're new devices. They're 20+ years old devices. And we love load balancers that typically fall into 2 categories. AWS has lots of names for them, but we either have network load balancers or we have application load balancers. I don't care what names you call them, gateway load balancers, are one of 2. A network load balancer operates at layer 4, which means it looks at the TCP, UDP information. And network load balancers are fast. Why? They're not too bright. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30. I mean, it's fast, right? Because they're not doing that much. An application load balancer is really smart. So instead of doing 2 + 2 = 4, now we're doing calculus in our head. Now, how fast can you do calculus in your head? My wife, pretty quickly. Me, I don't know how to do calculus. I'd have to learn. I could learn anything, but it wasn't something that I ever had to learn, so I didn't learn it. But the point is it would take longer to do calculus than it actually would to do simple addition. So when we deal with application load balancers, we're looking at deep stuff inside of an HTTP or HTTPS header. Now, when we're on AWS, they have network load balancers. They call them elastic load balancer because their marketing people have to stick the word elastic in front of everything. And they also have application load balancers, for example, but they call them elastic load balancers too. And of course, they call a classic load balancer, which of course could be a network or an application load balancer. They call it a classic one. They recommend you don't use them. The same concept. So an elastic load balancer is a virtual load balancer instead of a physical load balancer. And it distributes traffic. Now, what's it distribute traffic to? Whatever you want it to. Typically speaking, virtual machines like your web servers. Now, the load servers are kind of auto-scaling. They kind of do whatever they need. They give you enough capacity. load balancers can load across spread load across multiple availability zones. They support health checks, and they can terminate your SSL connection. So why is it cool to terminate your SSL connection? Well, SSL is a form of encryption. Encryption. And what do I mean by encryption? Encryption is running mathematical calculations. And let me tell you, mathematical calculations take CPU performance. And if you put these math calculations in the load balancer, where does this encryption not have to occur? On your web servers. So by offloading the encryption onto the load balancer instead of your web servers can be hanging out there like Cindy the cat, who's eating tuna fish, looking happy as a lark, relaxed, relaxed, relaxed. So that's why we love this. So AWS network load balancers route traffic based on network stuff. They can handle millions of requests per second. Excellent with rapidly changing conditions. And network load balancers, because they look at the TCP port, source and destination protocol and port number, and that's it. They're fast and they're stateful. Send this thing to server 1, goes to server 1. Next one goes to server 2, next to server 3. Third session's load balanced on server 3. And those connections stay until the connection is terminated between the users. They're stateful. What happens, they call it a sticky session that maps the source and destination of the connections. But it's by default on network load balancers. Now with AWS, you can put a static IP address on a load balancer. Well, we've been putting static IP addresses on load balancers for 20 plus years. And you can also route to containers. So the one you're going to be routing to containers, you're typically going to be using an application load balancer. Want to see what it looks like in action? Got a network load balancer, load balancing on high speed between 2 availability zones. Boom, boom, we're good to go. Now let's talk a little bit about application load balancers. Application load balancers work at layer 7 of the OSI model. And they look at the path provided in the URL, elements inside of an HTTP or HTTPS header, the HTTP routing method like push or get. They can route based upon source IP addresses. And these application load balancers are truly ideal for balancing HTTP and HTTPS traffic, ideal for balancing requests between microservices and container applications, optimal to load balance multiple requests on the same server by registering the same server on multiple ports. And they're pretty good for load balancing for those types of things. Now, how does this thing work? Well, in a similar manner, we've got our load balancer that's listening, and all load balancers route to something called the target group. But here we're dealing with much, much, much greater intelligence. Now, AWS is a classic load balancer. Guess what? It's the same thing. And it works on both EC2 instances, classics, and VPCs. Autoscales just like the rest of them. Provides the same cloud trail auditing. But they don't want you to use it. They want you to use the new one. It's called an elastic load balancer. Now let's talk about internal load balancers versus external load balancers. Internal load balancers are for your internal applications. Like, you're not going to put your HR database on the public internet. An organization may have its private website called www.in, which is pretty common for an organization, especially tech companies. They have an internal website called www.in, which is only accessible for people inside of the network. So that would be an internal load balancer. An external load balancer, also called an internet-facing load balancer, is one that covers your systems to the internet. And the way load balancers work is they typically have a listener. A listener is a process that's going to wait for connection requests. Application load balancers are going to look for HTTP, HTTPS requests. Network load balancers by nature are going to look at a TCP or UDP request or a TCP UDP request. So let's talk a little bit about load balancer concepts. We've got targets. Target is where the application distributes its traffic. Targets can be a single instance or an IP address. When the target's an IP address, it needs to be from the private address space, meaning RFC19 address space or the shared address space. So when we're using elastic load balancers, we can only put route to private addresses. So you're going to have private addresses in your web servers anyway, because the load balancer is going to be your public-facing address. So what does that mean, RFC 1918 addresses? Well, it includes the 10.0.0/8, the 172.16.0.0/12, the 192.168.0.0/16, and the 100.0.0/10 RFC 6598. That's what we're talking about. Now, I mentioned we can send to a target, but we could also create a target group. What's a target group? A group of systems. Now, as I previously mentioned, when we're dealing with load balancers, we can group our things to, we have the concept of sticky sessions. When we're dealing with sticky sessions, on the network load balancer, it's by default. But on the application load balancer, you might want to enable it. And if you want user one to say on the same web server, we can do that through a sticky session. The way that'll work on a network load balancer is as part of the flow. On an application load balancer, they don't really have these kind of flows. So what'll happen is the application load balancer will give a cookie, and it'll use a cookie to track the session. And that's the way these work. Now, all load balancers use a health check. Are you there? Are you there? Don't get a response. Remove from the absolute rotation. Now, we've reached an interesting break in the content. And this is where we're going to do some voting. The next section is security, and it's a pretty big session. So today we're going to talk about security on the AWS platform. Now, when we talk about security, realize this is just a subset of security. This is an AWS Certified Solution Architect Associate course. So we're going to cover the AWS Security Services and the Associate and Professional exams. Now, remember, in real life, security is much bigger than this. We're going to be using things from the marketplace, next generation firewalls, but they're not part of your AWS exam. And we need to focus on the exam. That's why this is a Solution Architect certification versus Cloud Architect training. But it's on your exam. Your exam is going to help you get the interview. And then it's your knowledge after the interview on cloud computing that gets you cloud hired. But we still want you to get that interview. So in this section, what are we going to talk about? We're going to talk about who's responsible for what parts of your VPC. We're going to talk about principle of least privilege, which I like to call need to know. We'll talk about industry compliance, identity and access management, multi-account strategies, network access lists, security groups, the AWS version of a firewall called WAF. We'll talk about the AWS's intrusion detection systems. We'll talk about DDoS mitigation. We'll talk about the service catalog, and we will talk about the systems manager parameter store. So we're going to begin by security. Who is responsible? And the reason we're going to deal with this is normally in your own data center, you're responsible, right? You're responsible for all your firewalls, your routers, your switches, your QoS policies, your identity and access management, everything. But that's because you own the data center. You manage the data center. And if you manage the data center and you want to hire Navy SEALs snipers to be on the roof, you can do that. And you can hire whatever level of security you want in your data center. Now on the cloud, you don't have access to that because the cloud provider manages their infrastructure and you manage your virtual infrastructure. So when we deal with this, we're dealing with this shared security model. And you can think of it this way. AWS maintains the security of their cloud, and the customer maintains the security of their virtual cloud or their virtual data center. So when we talk about security, we can only control our stuff. If the cloud gets hacked into, we have no control over that. So we have to trust that our cloud providers are doing a great job doing security of their own systems. And for the most part, they are. Now, they're not invariable to hacking. They get hacked too. We've seen it in the past few years. Azure was recently hacked. And we know that anybody can get hacked and everybody will get hacked. It's just a matter of when. But you manage the security of your virtual private cloud. AWS manages the security of the underlying hardcore tech infrastructure. So let's talk about what that means. It means the customer is responsible for the identity and access management, users and roles, and we'll talk a lot about that. Patching of the operating systems of our virtual machines, maintenance and security of our own applications, configurations of our security groups, physical security for the devices that we're dealing with, our own firewalls, for example, that we're going to use inside of our systems, pretty important to us, whatever intrusion detection prevention systems we use, and the gamut of our own security services. So that's kind of what we maintain. And of course, AWS manages the security of their infrastructure. So I drew it out for you to try to make it a little easier for you. You can see on the bottom, AWS manages the servers, the BIOSes and their servers, their hypervisors. They manage their storage area and networks, whether they be block storage, object storage, file storage. They secure their databases. They secure their networking. They secure their regions, their edge locations, their data centers, otherwise known as availability zone. Now, what do we secure? Let's make it a little simpler. Our data, our applications, the operating systems and our virtual servers, any kind of encryption of our data we're using, any kind of networking traffic that we're using. For example, you could run IPsec over our direct connections or over a VPN. So there's that. And that's kind of what we're talking about. Now, the first concept whenever you get into security is the principle of least privilege. I hate this term. I like to call it need to know. Military makes it simple, need to know. And here's what it means. If you don't need to know anything about that for your job, you're not told about it. If you need to know it, you're told. And here's why. The more information you have, the more you can harm the company, either maliciously by going to a competitor and selling your secrets, or by accidentally disclosing information you don't even know, or by using a system in the wrong way and damaging things. So the principle of least privilege is very critical. It basically says give your users the least amount of access necessary for them to perform their function, and no more, no mas. Only what's necessary to do their jobs and nothing else. And when somebody leaves your company, when they're walked out by security, lock their systems down so they can't damage you. So principle of least privilege means as follows. Provide only the necessary features, functionalities, and access that somebody needs to do their job, and nothing else. And when they leave that company, you revoke it immediately. And that's why organizations, just to let you know, actually have security walk people out. And sometimes it's the saddest thing in the world, and I've seen it over the past few decades happen a lot. Sometimes the only way somebody finds out they were laid off is their email doesn't work. They can't log into the systems. They call a help desk, and all of a sudden they find out they've been laid off. Now, this is a horrible, horrible situation, but that's why it's going on. And I've seen it happen so many times. Not good companies, well-run companies don't do this, but it happens, and it happens more than you would like to know. So let's look at this in another context. Here I am, and I'm an administrator. I need to access something, and I basically got authenticated by the system. The system says, yes, Mike, you're allowed to do this, and yes, you're authorized to do this, and I'm allowed. Now, by comparison, we've got another user that's not me. And this user is not allowed to do their thing. And because this user is not allowed to do their thing, they're denied, access denied. And this is really what we're talking about by using the principle of least privilege. So before we get into real security concepts, and we're going to get into a lot of them, let's talk about industry compliance. Many industries have all kinds of security regulations and requirements, data retention, etc. And AWS, like all cloud providers, supports the main industry compliance. And you can see a full list on the AWS website, but the main ones I'll cover PCI DSS for payment cards, sure. ISO 9001, 27001, 27017, 27018, pretty standard requirements. AWS supports them. FedRAMP if you're going to do anything with the US government, and HIPAA, which is basically, healthcare US privacy rules and regulations. Now let's get involved into identity access management. And this is a key part, last line of defense in your security architecture. Last line, not first line. Now, I hate the term identity access management because it sounds so fancy and complicated. I'm going to simplify it. Many years ago, before we used word inflation, we used to call a spade a spade. We called coffee coffee before it became a latte and all these other funny things. And we used to use the term AAA, authentication, authorization, and accounting. And I'm going to cover those concepts because I want you to truly understand this IAM or identity access management. Authentication, who are you? Who do you claim to be? I'm authenticating right now. I am Michael Gibbs, CEO of GoCloud Careers. Now, they could authenticate me via retina check. They could use my, my fingerprints. They could authenticate me via DNA. They could authenticate me via a password and a username. They can authenticate me via something you have and something you know, like your ATM card and your PIN number. So authentication is who are you? So the first component of identity and access management is who are you? Now the next component is authorization. So let's talk about what authorization is. Authorization is what are you allowed to do? So we can't have all users accessing all things. I'll give you an example. Chow Pham, she's an incredible cloud architect of mine. She works in our team. She's absolutely amazing. If Chow says to me, Mike, I'm going to come visit you in Florida, I'd say, thank you, Chow. Can't wait to see you. When she'd knock on the door, I'd look at her and I'd know she's Chow because I've seen her before. Then I would give her the keys to the house, give her the keys to the Mercedes, and tell her to go in the house, take the guest bedroom. My wife would prepare all the things for her, and Chow could have access to every room in my house. And that would be authorization. Now, by comparison, if it wasn't Super Chow, the amazing cloud architect that walked into my house, and it was a stranger, I might look through the peephole on the door and say, get out of here. Or I might question them, and they say, I need to use your phone. My car is broken down. Maybe I bring my phone outside to them and let them use the phone. Or maybe I'll allow them to come in, and I stand by and I stand guard. See, authorization. And the key is we're going to give different privilege levels to different people based upon their need to know and how trustworthy they are. So authentication, I identified it's Chow. Authorization, I told Chow she can do anything because I totally trust Chow. Now the next thing is accounting. That's the last part of this AAA concept. And I'll give you the example of accounting. Chow comes and visits. She stays with us. She plays with my cat Cindy. My wife gives her all the things that she needs. And then after Chow leaves, my wife checks and says, Chow used 3 shampoos, 4 bars of soap, ate 22 cans of tuna, which all really went to Cindy because she kept opening cans of tuna for Cindy. So I need to go to the store and I need to buy 22 cans of tuna, this many bottles of shampoo, and this much soap. So that's called accounting. Now, so identity and access management is really about who you are, what you're allowed to do, and then keeping track of it, or building an audit trail so you can find out after the fact. Now, when you're dealing with AWS, they're going to define the concept of users and roles, and we're going to get much, much, much more into that depth later. But here's the thing you need to remember. A user is a person, like Superchild, the amazing cloud architect. That's a user. A role, generally speaking, is a computer, meaning one system accessing another system. You may have been involved in Linux and you're familiar with the term service account, which is typically used like in your 3-tier web application. We've got your web servers, your app servers connecting to your database, and the service account connects your application servers to your database. So if you've got an EC2 instance accessing DynamoDB, that would be a role. But if we've got me accessing a system, I am a user. So while we're at it, let's look at this concept again. Authentication. User signs in and we know who they are. Maybe we use a username and password, a one-time password, something you have and something you know, but whatever the case, that's what we're using. Now next, after we've identified that user, we have to authorize that user for what they're allowed to do. And then after that, we have to track that user. So that's the basis of authentication, authorization, accounting, otherwise known as identity and access management. I don't make up those terms, somebody else does. Let's talk a little bit about IAM users. Users are identities, people that have the permission to access or interact with your resources on AWS. What are your resources? Your virtual machines, your containers, your storage, that kind of thing. Now it's created by a principal. We'll get into the term principal and what that means later. But in other words, a systems administrator needs to grant you access to things, otherwise you won't be able to reach it. And we can create our user accounts, with the management console, the command line interface, or the software development kit. That means pushing it over the API. And IAM users are permanent unless deleted by the administrator. So think about this. Somebody works for you, they get a job going somewhere else, and you have to remove their access, you must delete their account. So let's look a little more into this. We've got a user. You can see the user logs in, they identify themselves, and you can see they have access into their proprietary NoSQL database or the object storage or anything that's sitting on a virtual machine. So let's talk a little bit about authentication options. Let's talk about the simpler ones and get better. At the simplest name, username and password. Hi, my name's Mike, and my password's name is Cat. No, you'll never find me use a password named Cat, but you get the concept. Username and password. Log into the console, enter my username Mike, enter my password named Cat, and of course I'd be hacked in about 3 seconds with a password like that, so I would never use something like that, but that's your username and password. Now, what if we want something a little better? We can use something called an access key. And an access key is a combination of a 20-character key ID and a 40-character secret. That's some security there. And this access key you would use to connect to AWS via an API. One system connecting to another one, done over the software development kit, so to speak, and you're pushing some decent security between systems. Now, if we want to get even better, we can use an access key and a session token. And what we're dealing with here is when IAM authentication needs to occur under an assume role, our secure token, we're going to use the token alongside the access key. Now, that's going to maximize our security. Now, I know I briefly covered what is authorization, but I want to do it again. Authorization occurs by determining what specific things you're allowed access to. And these are going to be policies that are going to be written. You can give it to a user or a group or a role. So let's talk about it. Hi, I'm a user. You can add specific policies for me under authorization. Now, let's say you've got a company with 200,000 employees. Do you want to add policies per user, one-on-one, manually, 200,000 times? I don't think so. So what you could do, and we'll talk about more of this later, is you could create groups of users, network admins, sysadmins, cloud architects, finance people, HR people, and then you could apply a policy to the group. And then when you hire someone, you hire 5,000 new solution architects, put them all in the solution architect group, and they inherit the permissions of the group. Much, much more scalable. That's how everybody does things. Now, when we write policies with regards to AWS, they're written in JSON, which is otherwise known as JavaScript Object Notation. And the default policy for anything with IAM is deny access to everything until you configure it. Now, there's 2 ways that you can set up your systems. Allow everything until you lock it down, hacked in 3 seconds, or allow what you need. So that's why they start lockdown. Now, when it comes to a policy, there's a few things that we have to determine. The effect first. Do I allow Cindy access to the room? If the answer is yes, I allow. If the answer is no, because the room's full of birds and my cat Cindy likes to eat birds, the policy is denied. Now, we also, under the authorization policy, need to define the service. What is the cat allowed access to? Is the cat allowed access to S3? Is the cat not allowed access to the room? Is the cloud not allowed into a room because it's full of birds? So the effect, allow or deny. The service is what we're protecting or not protecting. And then we put the resource. Now with AWS, we have the opportunity to use a full Amazon resource name. And by doing this, we can point to the exact resource that we're allowing access or denying access. Now, the last things that we're going to talk about under this policy include the action. What is the permissions of the user? Read, write. And we can add some conditional elements which are optional but very granular. Maybe to allow access to a certain subnet at a different time during the day. So go through so now you get what they're actually dealing with. So let's go back to looking at authorization again from a graphical perspective. Here we see we've got a user. This user's allowed access to object storage, otherwise known as S3, and DynamoDB. But when they try to get to that management console, they're not an authorized user, so they are denied. Now, when they're dealing with AWS IAM concepts, I talk about some more critical things that'll be on your exam, and you need to know it to create a policy. We'll first talk about a principal. All that a principal is an IAM entity or something, meaning a user or a role, that has permissions to access something on the AWS cloud. Let's talk about the root user, the king, the queen, whatever you want to call it. When you first create the account, you're creating the root user, the person that's the owner of the account. And when you own the account and you're paying for the account, you have unrestricted access to anything. So of course you're going to be the root user. Now don't log in as root because you could accidentally delete your entire organization by mistake. And if any of you have ever been Unix users or Linux users, and you've been told don't log in root as work in root as root, it's the same thing. Because you can't restrict access to the root user. And one little silly thing, and it's gone. Now, when you have a root user, don't use the password cat. Because somebody could use the password cat, which they can crack with a GPU in less than 5 minutes. Poof, they've used the password cat, and now they're inside of your systems, right? And now they can spend $1 billion on systems if they want to, and it's going to be built to you. So use a strong password. Now, realistically speaking, you should also secure that strong password somewhere, maybe on a key in a safe that's locked down inside of a safe and another safe and another safe. Depends on your systems and how critical they are. And maybe enable multi-factor authentication on your root account, so it's not just a username and password. And don't use for programmatic access, meaning don't use this key on a computer that's connecting to another computer, because when that computer gets hacked, your whole account is hacked. You'd think these things sound very simple, but the reality is I've seen it all done before. So let's talk about this root user. You'll note that I had the graphics person put a crown on them, because if they're the crown queen or the crown king, root has unlimited privileges inside of your virtual private cloud, otherwise known as your virtual private data center. So let's talk a little bit more about identity and access management. Identity and access management is used to determine whom can access the system. It uses standard concepts like users and groups and access control policies. These are the same things that you'd be dealing with a Radius server, for example, or a Microsoft Active Directory server. And the plan is we create a group. Create a group for the security personnel. And they all get security personnel positions. The accounting team, the finance team, the system administrators. But remember, as I mentioned before, could you imagine writing 200,000 security policies? No. But what if you're AWS and you have 20,000 solution architects? I don't know how many they have. You put them all under a single policy. It's better than that than making 20,000 single policies. So here's how the groups work. I create a group, cats. I provide permissions to the group. The cats can open and close the back door, but they can't enter the bird room. And then I add all the cats' names to the room. Cindy, Sunny, Catty, Noni, any kind of cat I want as allowed to the group. Now that cat has the same permissions. They all have the same permissions. So if my cat Cindy and Sunny are under the same permissions, and Sunny can't enter a room, Cindy can't enter that room either. Which would make Sunny the cat probably not so happy, and Cindy the cat not so happy either. As I mentioned before, roles are generally systems. And we're going to talk about several kinds of roles. We're going to get a little bit in the weeds here. It gets a little complicated here, so please bear with me. There are a few kinds of roles. There's what's called a service role for EC2. Here we got choose service. A service role allows this system into this system. Simple, easy, elegant. There's a cross-account role, which is when you go from one AWS VPC to another AWS VPC as a role. And there's an identity federation. Let's be fair. No serious business is going to be using the AWS IAM system. They're going to be using Microsoft Active Directory. All their users are going to be in Active Directory, and they're going to connect to Active Directory and pull that Active Directory information into AWS. It's called federated identity, and we'll talk much more about that. But understand this, roles enhance security by making sure the credentials are never stored anywhere. You don't want to put a password in a computer to attach another computer, because if one computer gets compromised, guess what? Your entire systems are compromised. And the way roles enhance security is, what will happen is the AWS service, the API, will provide a temporary token for the system that has to access the other system. And here's what's so great about the token. They expire. I give you a token and it's only good for an hour. You can use it for an hour. Now, the token will change in an hour. Now, if a hacker got access to your token, the worst case scenario is they could use it for an hour. Now, 45 minutes of the hour pass, the hacker gets control of your token. They can only use the system for 15 minutes. And guess what? At the end of the 15 minutes, they can't access anything because the token's been expired. That's why we love them so much. So IAM roles are used for one system to access another system. IAM roles can be assumed by applications and services. IAM roles use short-term credentials, meaning periodically, which substantially enhances their security. IAM roles will basically leverage the security token service, which I'll talk more about. And tokens are temporary. The default expiration time is 16 minutes, but in a really high security environment, they can be reduced down to 15 minutes, or they can be extended to 36 hours to promote additional scalability. Now, talking a little bit more about IAM roles, they are typically used to grant permissions for applications running on EC2 instances. IAM roles are really used by people when connecting to external identity providers like Active Directory, or using your Amazon account or your LinkedIn account. IAM roles are used to grant permissions to IAM users in the same account to a different role, and grant permissions to different accounts. It's called a cross account. Logged into my VPC is peered with Chris's VPC. That's called a cross account role. What I'm going to do is briefly mention the security token service, and then we're going to take some questions, and then we're going to get deep into the roles. So most of these roles require something called the AWS Security Token Service. What that is something that's designed to provide trusted users access with a temporary token, but the tokens expire. Here, I request access, I get given my token, I'm allowed access to the system. When that token expires, guess what? It's no longer recognized by AWS, and we are done. And the hacker, if they got it, gets access to expired information. Let's go back to the content then. Now let's talk about a cross-account role. Actually, before we do, everybody give me a hashtag, AWS Certified Solution Architect Associate, so I know you are awake, alert, and oriented. Now, a cross-account role enables you to access another account, meaning you're in my account and I'm connected to somebody else's account. A cross-account role enabled me to do this. So Chris over there has his own AWS VPC. No, he doesn't, because we're running an OpenStack cloud. It was much cheaper for us based on our business, but for other things it wouldn't be. But if Chris has his VPC and I have my VPC and I want to access something on his VPC, I would get a cross-account role. Now, it's often set up to allow a user in one AWS account access to an account that they don't own. So when you're connecting or creating a cross-account, meaning you're allowing somebody else into your account and they're not part of your company, now you got to get scary, scary, scary good when it actually comes to the security. So, Super Chow or Chris, they're part of my company. They have pretty much full admin rights to anything they need to. But if it was somebody else that I was dealing with, perhaps I hired an adjunct instructor from some other company, and I only wanted them access to Tuesday's class material. With a cross-account role, I would only give them access to Tuesday's class material, not everything, because with a cross-account role, remember, you're bringing in other people that are not part of your company into your business. So that need to know, that principle of least privilege becomes critical, critical, critical. So give access to only what's needed and nothing, nothing, nothing else. So while it's always essential to use the principle of least privilege, with a cross-account role, it is critical, critical, critical. Now, cross-account roles, when we're dealing with cross-account roles, an external ID is needed. Now, this external ID is going to be uniquely associated with the role. The external ID can be a secret identifier that is only known by a third party, for example. But when you use this cross-account role, you must specify this ID when you define a trust policy. The third party obviously will provide this ID when somebody assumes the role. Permissions needed by the third party are obviously necessary to work with your AWS account. So let's graphically look at a cross-account role real quick. Here you can see company A, company B, and company C. They're all allowed into my virtual private cloud, which I like to call my virtual private data center. And by using this, each one gets access to privilege. So I kind of like to view it that way. How cross-account roles will work. A role is going to be created for your external user. The external user is going to connect to the AWS Secure Token service and get a temporary token. And when the external user wants to access it, they'll provide that temporary token. Well, that's one of the more complicated roles we'll get into. Well, let's get into a much simpler role, a service role, which everybody else calls a service account, but AWS calls a service role. And this is a role taken by a virtual machine called an EC2 instance that can access with another service. Effectively, it's enabling your applications to make secure API calls. So think of it this way. You've got an EC2 instance that wants to post messages into an SQS. You've got a system that wants to access something in an S3 bucket. You've got your EC2 instance that wants to access one of your relational databases. Now we're dealing with this service role. So let's graphically look at this real quick. Here we go. EC2 instance wants to access the proprietary Amazon NoSQL database, DynamoDB. And we create an EC2 service roles. Pretty simple. Now let's talk about how you create a policy, an IAM policy. The IAM policy is going to determine who and what can access what systems or resources. In this policy, you can assign permissions to specific resources or all resources. And when you provide access to specific resources, you're using the Amazon resource name. Now we get real granular and specific access this, but not access that, which is fantastic. Now, many of you guys are fully familiar with regular expressions or Boolean things. And if we want access to everything, we can just use that asterisk, that wildcard. Just like you would in a regular expression with BGP or many other things, with Linux. Now, there's going to be two kinds of policies, two main types of policies, an AWS managed policy and a customer managed policy. Let's talk about the two of them. A customer managed policy means you make it yourself, and an AWS managed policy means you take it from them. So let's talk about how we're going to create a policy under either case. We're going to sign into the AWS IAM console. In the navigation pane, we're going to choose policies, and we can create our own, or we can use one that's made by AWS. And let's think about why. Most of us are not JSON programmers. And if we're not JSON programmers, AWS has a million kind of policies, I'm exaggerating the number, but a lot. And they work for 90% of use cases. So we can basically create our own policies, or we can use the ones from AWS. Now, our policies are not visible outside of our organization. Keep that in the back of your mind. Now, if we create a customer managed policy, let's talk about how we do it. One is we could take one of the AWS managed policies, for example, and tune it. That works. Two is we can use something called the policy generator, which I'll show you what that looks like in a minute. And that basically is going to ask you some questions. And in the questions, you'll fill it in like an interview. And it's going to generate a policy for you, which we kind of like. Or you can create one from scratch. But don't create a JSON policy from scratch unless you understand JSON grammar and syntax. So this is perfect for someone with some JSON programming experience. So let's look at, what is this policy generator? You go to the AWS web page, and you put in your information for a policy. It's going to ask you some questions, and you'll fill in the questions, and you're going to get something that's going to help you. Now, what do these policies actually look like? Well, here's an example. Remember, I talked about the action, effect, or allow. So here, in case we're going to allow an EC2 instance to attach a volume and detach a volume. And we specified a resource by the Amazon resource locator name. You can see that that's over there. We've highlighted this, and we specified some optional conditions over here. So now that we've created a policy, we have to apply them somehow. Now, we could have created a policy for the user, like I talked about. Mike's allowed to do this. Chris is allowed to do this. Tal's allowed to do this. Alonzo's allowed to do this. Cindy's allowed to do this. Leo's allowed to do this. Manuel is allowed to do this. Eddie can do this. Anselm can do this. We could do that, or we could create a group and put those users in similar jobs into the same group. So let's talk about how we apply them. In most cases, here we go. We create an account, right? That's us. And then we communicate by, we block our group people into groups. Our network admins or our cloud admins are put in one group. They have a certain set of privileges. Our software developers are put into another group. Our test engineers are put into another group. And each one gets access to different policies. Now, how else do we further secure identity and access management? Well, we use multi-factor authentication, which can greatly increase your IAM effectiveness. And this way, if you use the username Mike and the password cat, which would be insanity, and at least it reaches out to you and asks for a one-time password, you're better off because the password cat will be instantly copied by anybody in a second and a half. But what won't be compromised is that one-time password. So the key is to use a good, really strong password and then use a multi-factor authentication. And multi-factor authentication is not new. They've been using it forever. We used to have this thing called the MAC card, money access card. It got renamed into an ATM card. I think that's what they call it now, where you put your card in, you enter your password. I still call it a MAC card because I've been around too long. You enter your PIN number, and all of a sudden money comes out of the machine. That comes out of your bank account. Something you have, something you know. You may have seen some RSA secure ID cards that people have had for the last couple of years. Again, something you have and something you know. Kind of keep that in the back of your mind. So kind of keep these things in your mind. You know, that's the concept, something you have, something you know. It's not new. Keith sold Mac cards. Yes, Keith, I could see you doing that. I knew you would remember Mac cards with me. Love that, money access cards. I still think it was much simpler, but it was the blue Mac card than before they turned into these Visa things and credit card things, debit things. Mac cards were so much easier. So, you know, so how does it work? The organization sets up an authenticator app, which is basically a device with a key. The authenticator device will create a one-time password which changes every few seconds, like an RSA Secure ID key. When the user logs in with their username and password, AWS will provide a challenge asking for a one-time password. And if the user provides the correct one-time password, they're authenticated. Maybe you guys have the Google app on your phone or use the old RSA Secure IDs. Key is something you have and something you know. Let's look at multi-factor authentication in action, because I always love multi-factor authentication, something you have and something you know. Here we go. We got the user Billy Bob who logs into the system. Now the system says, hey, Billy Bob, what's the special one-time password you have? Billy Bob provides that user and he's allowed in. Now next, we got somebody bad. We call it Joey that's impersonating Billy Bob. Now Billy Bob signs in and Joey compromised Billy Bob's password. So Joey tries to log in. And when he tries to log in and pretends to be Billy Bob, but he's really Joey, Billy Bob gets sent this one-time password request because it's sent to Billy Bob. And Billy Bob says, I didn't try to log in, doesn't provide the access, and then Joey, the bad hacker, is not allowed in. That's really why we're using, you know, multi-factor authentication. That's why you'll notice in recent years, your banks, your phone companies, your cable companies, they've almost mandated it. It's due to the security issues. Well, let's talk a little bit about identity federations. Identity federations enable management of access of identities in a single place, like Microsoft Active Directory. And the key components of an identity federation are as following: an identity, a user, Mike. An identity store, a place where the users are stored, like Microsoft Active Directory, or Facebook, or LinkedIn, or Apple, or Amazon. And then we typically have something called an identity broker, which is an application that's going to check with the identity store and provide access to the AWS resources. So, you know, not that complicated what we're talking about. Now I'm going to give you the complicated, ugly steps of how this works. We're going to get into the complicated, ugly steps. Here's what's going on behind the hood. The user is going to log into an identity broker using their corporate credentials. The identity provider is going to authenticate the user against an LDAP-based directory store or identity store. The identity provider will then establish a security assertion markup language token with all the required information, and it's going to submit that assertion to the identity broker. The identity broker will then call the assume role with SAML, Security Token Services API, and that's going to pass the SAML assertion to the role and for the Amazon resource to basically assume. And if the API response is successful, it's going to include AWS temporary security credentials for the associated permissions. And with the temporary credentials, the client application can perform operations on AWS resources. So why are we using identity federations? Well, why don't we just use AWS IAM? Well, scalability. Are you going to have a person log into IAM console on AWS and type all this stuff? No, that's just too much work. It's unnecessary work. So you're going to establish a trust relationship with a known identity provider. Google's a known identity provider. Amazon's a known identity provider. Facebook's a known identity provider. Apple's a known identity provider. Twitter's a known identity provider. LinkedIn. Hey, have you ever been, use Pay using your Amazon Pay account because it's pulling your information from Amazon? It's really the same thing we're talking about here. No different. And identity federations can enable organizations to connect their AWS VPC to internal identity management applications, most likely Active Directory or some kind of an LDAP directory. AWS IAM functions are connected to the identity provider. When a user attempts authentication, the request is passed to the identity provider. The user will get their IAM authentications and receive their privileges based upon their job role, organizational cost center, and so many other providers. And this enables singular and granular control of your users. All right, thankfully we got through that. I know that's a little bit ugly, but it's definitely something you need to know. And there's some questions going on with regards to networking in the chat box. They're not exactly correct. If there's some networking questions, we'll answer that at the next time we actually get through things. Let's talk about single sign-on. When we're dealing with single sign-on, it's really an authentication method that enables users to securely authenticate with multiple applications and websites. So normally, it used to be you'd log into your systems, and when you'd log into your systems, you'd have to then log into the next site, the next site, the next site. And then maybe you noticed a couple years ago, things got a little smoother. You logged into your systems once, and then you had access to everything. That's single sign-on. And single sign-on is a service that allows your users to sign into one place and then access resources in your account. So instead of logging into every system, you log into one. Typically used in a federated environment, and it integrates with Active Directory, Azure Active Directory, Salesforce, and other identity providers. It basically enables your user to authenticate once, and they don't have to authenticate again and again and again. When they authenticate once, their privilege is determined and their roles are assumed. Going back to this environment, you can see what's going on. We've got an on-premise Microsoft Active Directory server, which is then accessed or connected via direct connection or VPN, which provides network layer reachability and communication between that and the AWS single sign-on app. And by logging in that way, users can access everything. They don't need to log into S3, they don't need to log into DynamoDB, and they sure don't need to log into the EC2 instance. Identity federations. Amazon Cognito is a great service that provides authentication, authorization, and user management for web and mobile apps. It provides a means to connect to identity providers. Cognito enables organizations to synchronize identity management and data across multiple devices. Cognito users can basically sign in using a directory like username and password with a third-party provider such as Facebook or Google. And the way it works is a user or app authenticates against Cognito and gets a token. The token is then used to provide access to AWS resources. Visually, graphically, I'll show you what that looks like. Got a user that logs in and gets a token. They then trade their token for credentials. And then they then use those credentials to access whatever services that they've been assigned. That's really what's going on. We're dealing with identity federations with Cognito. Now, when we deal with Cognito, we're dealing with the concepts of user pools and identity pools. And a user pool is a secure directory within Cognito that enables you to manage users in one place. That happens upon successful authentication. Cognito will issue a temporary set of tokens, also called a JSON, which is really a JSON token. A little bit more about Amazon Cognito identity pools. Amazon Cognito identity pools provide temporary AWS credentials. Cognito identity pools work with authenticated and unauthenticated identities, and Cognito can work with guests, which are basically unauthenticated users and authenticated users who have received the token. A little more about Cognito. The way Cognito user pools work is the user logs into the identity provider, and after they've been authenticated by the identity provider, basically they get a session key for the user. Then what will happen is this, using the session key, the application will place a call to the Amazon Cognito GetID API, and it's going to get an identifier for the user. And then what will happen is Cognito will validate the session key from the login provider. And if the session key is valid, it'll get an API, GetID API, and return that for the user. The user will then send the unique key, identity, to Cognito. Cognito will validate the session key against the identity provider. And if that key is valid, Cognito will call the AWS Secure Token Service, provide a token. And of course, Cognito will return a temporary token to the application so they can access the users. Now, next thing we're going to talk about is the directory service. Directory service provides a hosted dedicated service for Windows Active Directory servers, basically Windows AD servers. So you could manage yours like most businesses would, or you can use the AWS pre-managed services for you. Either case is your option. Basically, they're theoretically high availability servers that are in 2 availability zones by default. And, Microsoft AD is necessary for the most part for Microsoft Direct-based workloads. So you can either maintain your own and federate that to AWS and not have to worry about any of their stuff. And that way you can use your same AD servers in AWS, Azure, Google in your data center and never have a problem. Or you can use the AWS pre-managed ones for you. It's your choice based upon what your business needs are, what your goals are, your availability requirements. And they're basically hosted servers that can be used by any of your systems, your EC2 instances, your relational databases for Microsoft SQL Server, AWS, and computing. We get back to the content and we'll talk about some firewall stuff where we're starting to get into the fun of security. Now we're going to talk about AWS WAF, and there are times where AWS WAF is perfect. AWS WAF has a fine, traditional non-next generation firewall, and it protects against common attacks. Typically your man-in-the-middle attacks, your DDoS injection attacks, your SQL injection kind of attacks, cross-site scripting attacks. It's a fine basic firewall. And for a small business that doesn't have a lot of critical requirements, it's completely fine. Your developers can customize a rule to block or monitor web requests, and it's a totally fine, generic, basic web application firewall. The only problem is it doesn't adapt. Now, in reality, you're going to be using 2 clouds, and the second you use proprietary AWS WAF, you're going to be in trouble because you're going to need the same security policy on AWS and Azure, which means you can't use any of these proprietary services. You're going to need something like a Palo Alto firewall, a Cisco firewall, a Fortinet firewall, a Checkpoint firewall, which all have much more robust security features and functionalities. But let's talk about WAF. WAF is a basic firewall that users can create rules and place limitations on which IP addresses can be reached, which protocols and port numbers can be reached. Benefits of WAF are that it's very simple. And, it basically will look at the IP addresses where they originate, the country where they originate. It can validate requests. It can look in strings that appear as requests, or the length of requests. It can look at some bad SQL code that's in a request, and it can block it. So it's really just a firewall that protects against web application attacks. It looks for common exploits. You can put it on your CloudFront distribution, which is your content delivery network, which we'll talk more about. You can put it on an API gateway or a REST API, or of course your load balancers. And it'll sort of block your connections at edge locations before they get onto your network. And there's nothing to preclude you from using WAF with a full next generation firewall as well for additional layers of security, and that's totally fine. And WAF will give you somewhat granular things. It's basically it's basically like a stateful ACL, where you create web rules and rule groups, and you're either going to permit stuff or not permit stuff, and it'll provide the ability of traffic metrics. So let me show you how they put it, and then let's do a walkthrough. The way WAF works is you're going to enable it on your device. You're going to create a policy that provides access or filters to the device. WAF will look at the policy and say good or bad, and if it's good, it'll allow the traffic through, and if not. So let's realistically look at how this works on AWS, and then let's whiteboard it out so you truly understand a firewall. Here we put WAF on our CloudFront, which is our content delivery network. We'll get into that. We'll put it on our load balancers, our API gateways. We'll set our policies and keep stuff from getting into our systems. Now, how do we combine it? For example, we'll talk about Shield, which is some DDoS protection. And basically every content delivery network gives you DDoS protection. The AWS branded one is Shield. And we can put this web application firewall. So this will keep unwanted traffic out of your systems. And then you'll keep unwanted traffic out of your subnets with the difference between an access control list. And then we'll use a security group. So realistically speaking, what are we really talking about? We're talking about this. So let's say you've got your load balancer over here. Here's your load balancer. Behind your load balancer, you've got some web servers. Obviously being a private subnet. On an additional subnet, you'll have your app servers. And if there's more than one app server, what are you going to need? You're going to need another load balancer. So let's make these things a lot smaller. Three-tier web environment. Typically, you've got a load balancer. You've got your web servers. You're going to have another load balancer. I'll put this over here. You'll have some app servers. And you'll typically have a database back here. And what you really want to do is before your load balancer, because this load balancer over here, if it's a web app, is going to have a public IP address. And in front of this, you're going to want to have an access control list. Actually, we're going to want to use a security group before we get to the load balancer. So let's pop in a security group over here. And we're going to pop in a network access control list over here. And in front of this network access control list, we'll have a firewall of some kind. Now, usually it'll be from the marketplace and there'll be next generation firewalls, or it could be WAF. But this is really how the pieces and parts are going to fit together. The firewall is going to keep unwanted stuff from getting into your systems, which is going to be further blocking the subnets with access control lists. And then after this, we'll have a security group protecting access to the load balancer. And then our web servers will also have a security group, but most likely we'll have an access control list between them. And then we'll have another security group for this load balancer and vice versa. So that's typically the way that we tie the pieces together. Now, the next thing we're going to talk about is preventing DDoS attacks. And let me tell you, when it comes to preventing DDoS attacks, we're actually dealing with a lot of things. So there's no one thing that protects against DDoS. You know, just adding a firewall, 2 next generation firewalls fronted by more next generation firewalls fronted by IDS IPS systems, that's not going to stop it. It takes a lot of work to stop a DDoS attack. So let's talk about what a DDoS attack is. A distributed denial of service attack. I want to make sure you guys understand this. So let's say over here we've got a web application, okay? And let's say this web application, which is on the right side of the system, can handle 100,000 web requests per second. 100,000 web requests. So it's a big, big, big server, lots of servers. Now, normally we've got 50,000 web requests. The server can handle 100,000. Life is good. Now, where does it break? There's a DDoS attack that can happen by accident. Let's say the company says Christmas sale 80% off, and they get hit with 300,000 web requests when their server can only handle 1,000. The company effectively DDoS themselves by taking in more requests than the web server can handle. The web server crashes, and that's a DDoS attack. But that's when organizations make mistakes. Let's talk about the more traditional DDoS attack, which is what goes going on here. And these DDoS attacks are getting big, big, and even bigger. In a DDoS attack, you got a hacker as specified by this red guy over there that looks real mean. The hacker has his server or her server and uses that server to hack into 20, 30, 40, 100,000 servers on the internet. And then those servers are used to create web requests for the web application. So the server can handle 100,000 web requests. We now control 100,000 servers, and each one of those 100,000 servers does 50,000 web requests per second. And now we can see our servers getting hit with 1 trillion web requests when it can only handle 100,000. The server crashes, potentially buffers are overflowed in that server. Maybe people get inside of our systems, or else they just shut us down. So all a DDoS attack is using multiple servers to completely overload your systems. And there's a lot of things that can go into preventing these DDoS attacks or improving them. For imagine, take this web application that could handle 100,000 web requests. Now, if it was in an auto-scaling group and it could then auto-scale out to 15,000 servers, well, that could help the organization mitigate the DDoS attack. Maybe the DDoS attack can be blocked by the firewall. Maybe it can be blocked by the content delivery network. There's lots of things that get involved in mitigating a DDoS attack. It's not just one thing. It's not just one thing. So let's talk about preventing DDoS attacks. When it comes to preventing a DDoS attack, we're talking about a full security posture. We're blocking unwanted traffic out of subnets with regards to ACLs. We're keeping unwanted traffic out of servers with security groups. I talked about auto scaling and how we can do that. Firewalls will keep unwanted traffic, and WAF can help. Now, typically speaking, here's where we can make a big difference, and that's on our content delivery network. See, the content delivery networks will only forward legitimate web requests to a server. And one of the ways you kill a web server with a DDoS attack is you send an overwhelming number of half-open TCP connections, for example, requiring the server to open up, and they never close these connections because they're waiting on something. So by using a content delivery network, the content delivery network can recognize the web requests being bad, which is usually bad requests in a DDoS attack, and they don't let them go to the server anyway. So there's lots of wonderful content delivery networks out there, and they all have some massive DDoS protection, whether it's the Akamai, which is kind of the king and queen for most people that consider of content delivery networks, or whether it's Cloudflare, or whether it's AWS CloudFront, or the Microsoft CDN, or the Google CDN. There's lots of content delivery networks out there. So when you have a content delivery network, they enable you to put some DDoS protection. And you put the DDoS protection on the content delivery network. And that DDoS protection will not forward the requests to the systems. They'll recognize problems and they'll block them. Now, every content delivery network provider has a DDoS attack, a DDoS prevention system, and AWS has quite a good one for their content delivery network. They use Shield. Shield is the AWS branded DDoS prevention service. And Shield Standard provides very basic DDoS protection. It's about as basic as AWS WAF, but it comes free if you're using WAF. And then there's Shield Advanced. Now, Shield Advanced is much better. Shield Advanced you can put on your EC2 instances, your load balancers, your CloudFront, your DNS, global accelerators. And it does a lot more. So when you're using Shield Standard, it's free. And it's going to protect you against the most common attacks. Common attacks. AWS says 96% of attacks. That's what they say. It protects against your main things, your SYNAC floods, your reflection attacks, your HDFS slow read. But it works based upon a policy. And it's static. And I hate static when it comes to security. It's not good enough. And here's why it's not good enough. Once you've been hacked, you've been hacked. You've been hacked. You've been hacked. Great. No adaption, you're still getting hacked. Now, you've got better option with regards to your DDoS protection on AWS. You can use Shield Advanced. And now we're starting to get in the range of good DDoS protection. Now, of course, you're going to pay for this. And it's an additional cost. And you provide this protection in your load balancers, your virtual machines, CloudFront, Route 53. And now we've got intelligent attack mitigation. So now you've been hacked, and now Shield says, I don't like this, and that's going to stop the attack. Kind of like the way Pac-Man would eat the dots on a video game. I know Keith West remembers Pac-Man, and a few others do, but not everybody. So kind of keep that with what you're dealing with. This is what we're going on with regards to DDoS, and this is what we're dealing with Shield Advanced. Shield Advanced will look at traffic patterns, deploy an ACL to mitigate the attack, for example. It allows visibility into your notification layers for 3, 4, and 7. And AWS Shield Advanced customers have access to 24/7 DDoS people, assuming They're using business or enterprise support options. Now, because some of these solutions are kind of weak, and security takes a ton of other things, there's some other things that you can use. Some AWS proprietary security services include GuardDuty, which is a service to monitor your AWS accounts, and it'll look at your CloudTrail logs, DNS, VPC flow logs, and it'll look for patterns of behavior with compromised systems, and it'll send you a notification, hey, something doesn't look right. So you can use systems like this. There are also industrial grade systems, SIEM systems that really do this and do this really well. Big industrial quality systems that you can use the same systems across multiple clouds. While we're at it, you've got something called Amazon Inspector, which is a security assessment service that helps improve your security posture and compliance of applications. It looks and constantly assesses for applications exposure, vulnerabilities, etc. And after performing an assessment, it produces a detailed list of findings, and then it'll give you some recommendations. Again, automated services are automated services, which are automated services. They're no substitute for having professionals look and see what's going on. You also have Amazon Macie, which is a fully managed data security and privacy service that uses machine learning and pattern recognition technology to protect your data. It's going to look for your S3 buckets and unencrypted buckets and publicly accessible buckets, and it's going to make some recommendations. And Macie will apply machine learning, for example, and pattern matching techniques to identify you with an alert. Of course, there's many better things that you can do. You can find things that are notified and create some event-driven security with some Lambda functions to go fix this. But these are basically services that are designed to assist you. Let's look a little bit about the service catalog. Now, this is pretty good stuff here. Pretty good stuff. Now, what we're actually dealing with is, when I was a little boy, a little bear, getting into networking, and I was a young kid, they called me Sniffer Boy. Why was I Sniffer Boy? I was plugging in the sniffer or protocol analyzer, and I'd find, hey, wait, this person opened up the firewall so they can use Napster. This one was downloading the entire internet library of porn. This one opened up a port on the firewall so they could do stuff. And we would find systems that were vulnerable. People would put their FTP servers on the network or their client servers on the network, and we'd get hacked because of other people and the things they did. We'd have systems that weren't properly patched. Joey's stuff was out there. It didn't comply to security policy. And we had the sniffer boy me that was running around trying to figure out what the traffic was on the network. Now, in those days, it was pretty hard to lock down your systems. Now, in today's world, we can use the service catalog. Talk about a great service. The service catalog can help you control what's placed on your systems and make sure they adhere to an organization's security policy. Now, this is good stuff. The service catalog will help you control what's placed on the network. This is really, really good stuff. So what happens is you create a list of approved things, approved virtual machines, approved servers, approved software, approved databases, approved application architectures, anything. And you pop them in the service catalog. And you only allow systems admin people to use stuff directly out of the service catalog. So this is why I love this stuff. So the user can access something in the catalog. They can deploy it with an infrastructure as code strip. And poof, it'll automatically deploy your things. And you're sure that they guarantee with security policy. And here's why. You've already approved them ahead of time. This is one of these transformational things in the cloud. Infrastructure as code, deploy things practically at the speed of light, and make sure they're exactly what you need. So there's some real digital transformation here. This is excellent. Let's talk about some more security services. And I hope you're gathering that security is about using a lot of tools from a lot of people. Some of these great AWS tools, some tools from Microsoft, some tools from the security vendors, some tools from identity people. It's a combination of everything. It's like an onion where you keep pulling back the onion. Let's talk about the Systems Manager Parameter Store, another very cool security service. And it's a key component of a strong security posture because A lot of things that we have to deal with are licenses, password strings, database strings, and it's probably not good for you to have sticky notes all over your desktop with everybody's password. I've seen it. I know Keith West has seen it, and I know Chris has seen it. I know many other people have seen it, like Alonzo. I'm sure he's seen that too. Some of the younger people may not have seen that. And what we're dealing with here is if your information is compromised, like a password, it could be a bit of a problem. And AWS provides a solution for securely storing your secret information. That's called the Systems Manager Parameter Store. I don't know how they make up that name, but it's a good service. Now, the Systems Manager Parameter Store is a scalable, hosted, serverless environment that's designed to store your passwords, database strings, license codes, and API keys. To kind of keep that in the back of your mind. If you've got extremely sensitive information, stick it in the Systems Manager Parameter Store. It provides a means to store and encrypt your encrypted data. And it's a great way to store and manage your instance receipts. It's going to separate your code from your passwords. It's going to provide an excellent means to audit access. And it's going to provide a method for you to track your password use. Let's talk about some more AWS security services, the Security Hub, which is a service that provides users with a broad scope or extensive view of user security posture and facilitates AWS environment's compliance with industry standards. Okay. It simplifies how users understand and improve their cloud security posture with automated security best practices checks by collecting, prioritizing, and securing data across accounts. Automated system, make sure you got real security people that understand how to do real security. And this is informational that they can use to give them additional information in addition to the other things that you may need to be doing. Provides a central view of security and compliance posturing. The AWS Security Hub is an aggregated and analytical tool that works across AWS Services accounts and some third-party tools. That's the key, some third-party tools. This tool tracks data against best practices and standards to identify oversights. Look, there are really good tools that you can use out there that are not proprietary, that work with everything, that are going to work on all your things. But if you only had a customer and they were only on AWS and they had a small budget and they were using only AWS services and they didn't have a lot of security, things like this are excellent because they give you additional information. Let's talk about the Firewall Manager. It's a security management service that allows users to essentially run up and control their WAF, their shields, security groups, and to some degree, some third-party marketplace firewalls. It ensures new users and applications can be operated automatically under procedures. Basically, an administrator can apply a rule across an entire organization and limit policies to a single group, users, or specific applications. Users basically set up their projections once, and the service automatically applies new things to your accounts and resources. Firewall Manager can basically be used by companies that are operating in a highly regulated environment to say you've got some stuff and you're doing some analysis. Service integrates with WAF rules to protect things. Can also be used to automatically patch and protect systems. Like when you're dealing with next generation firewalls, many of them have their own platform that can be used to manage across multiple clouds all at the same time. And when it comes to availability and performance, 1 is none, 2 is 1, and 3 is greater than 2. A single cloud, no matter how many regions and availability zones you use, there's a single point of failure because the control plane goes, the cloud is dead, the cloud gets hacked, the cloud can die. If there's a serious network issue, the cloud can be down. So there's lots of systems that you can use across platforms to really do this. Now we're going to get next into the AWS Applications and Services, which has got some really cool stuff, by the way. So please give me a hashtag AWS Certified Solutions Architect Associate so I know you're awake, alert, and oriented. Keith, no acronyms. Full word. And I know you know. In fact, in my course, I think I'm going to have a swear jar. Anytime somebody uses an acronym, they owe $20 in the swear jar, and we'll donate it to charity. Because acronyms create communication nightmares, and we don't want to use acronyms as architects. Tyrone, we're going to have to get you into that swear jar as well. And Tyrone, you're pretty solid and rock star. I know who you are. Okay, let's get involved into AWS Services. We're first going to start with SQS, or Simple Queue Service. Now, this is a wonderful proprietary queuing system. In a multi-cloud environment, you would not use this. You would use Apache Kafka. But here's what we're dealing with. It's a message queuing service that provides temporary message storage. I love this. Now, queuing systems enhance application availability by providing a means to store and keep messages from being lost. Now, the standard SQS queue, you typically think of it being used in a database, and we'll get back to that in a minute. And it's going to be used for transient storage. In fact, the default queue retention time is 4 days, but it can be configured for up to 14 days. SQS, or any queuing system, enables right sizing of your applications. It'll facilitate auto scaling, and SQS mitigates the need for middleware messaging systems and multi-tiered applications. So what is it? It's an AWS proprietary queuing system. It's typically high availability. It scales well. And the whole point of it is to decouple your system's environments. Simple queuing system will help you decouple your environments. And let me show you exactly what we're talking about. Let's say in this environment, for example, we have a web server and a sale comes in, right? It hits the app server. We temporarily hold the message and the Amazon SQS server until the database is ready to receive it. So web server, app server, queue on the way to the database. Now, the reason we're doing this, if the database was full, we'd be losing the messages. But if it's in a queue and the database is down for 30 seconds, it's no big deal. We're all kinds of happy, right? And the reason we're all kinds of happy is as follows. The message is still stuck in the queue. So queuing enables right sizing of our systems. Now, in this case, DynamoDB is serverless, but let's pretend it was a server-based database. What if all these messages comes in at one time? And then no messages come in for a half an hour? That's pretty normal. Things aren't like slow and fast. There are all kinds of weird patterns of traffic. So queuing enables you to smooth systems out and have the exact right size. So when we're dealing with queues, we're going to have the option for standard queues and FIFO queues. A standard queue is this. As fast as the stuff enters, it leaves. Every message is going to be delivered once, best for delivery. Now, what if we had an application that needed something specific? We'd be dealing with a first in and a first out queue. Now, in this particular way, message 1 gets delivered before message 2, which gets delivered before message 3, which gets delivered before message 4. Now, this is going to slow it down. And the reason it's going to slow it down is, what if message 1 is big and message 2, 3, and 4 are slow? 2, 3, and 4 will wait for message 1 to be delivered. But it really doesn't matter. What we're really talking about is as follows. We're talking about what's based for the application. Let's talk about the next thing called the dead letter queue. Message comes in, doesn't make it into the database, and we store it so we can go back and take action on it later. Kind of like the mail. Ever notice the mail it gets delivered to you, you send it back, and they store it somewhere? It's called the dead letter queue. So how does queuing work? Messages are sent from the computer to the queue. They're held into the queue. As soon as the receiver can take it, the messages are drained from the queue, and then new messages can come in. I showed you this before on the first day when we talked about databases, but I want to show it to you again. Here we've got in the same queuing system, messages come in, they're stored in the queue, they're drained from the queue if and when necessary, and then they're given to the receiver. So when would you use SQS? Well, if you're using a single cloud, you would use SQS. If you're using multi-clouds, you would use Apache Kafka. But you would use SQS to assist with capacity planning and application scalability. to make sure messages are not lost. Messages meaning orders, usually as it relates to sale, as opposed to systems being overloaded. SQS is fantastic for cost optimization because instead of having to purchase your servers for their maximum capacity they might read, we can base upon an average capacity and store those messages inside of a queue. And SQS can be very effective for auto scaling with its ability to provide a trigger. So, for example, you could have messages in a queue of a certain thing, of a certain idea. When the messages are in the queue, you could say, add compute capacity if it's necessary. So kind of keep that in the back of your mind. It can help you handle spikes on platforms without having the scaler make changes to the platform. SQS is good for handling, what are we talking about? Increased traffic and write capacity. Second, guys. Now let's talk about message queue. Amazon Message Queue is a fully managed open source message queue, message broker type service. Kind of like Apache Message Queue or RabbitMQ. It's a fully managed service for that. Amazon Message Queue makes it easy to set up and operate message brokers in the cloud so your users can mitigate messaging and applications without rewriting their code. Enterprise level customers could benefit the most from using Message Queue because they no longer have to re-engineer applications to use SQS. Of course, if they are using Rabbit Message Queue and they had their own systems on a virtual machine, they could just migrate them to the cloud and have the same things on all three clouds and not worry about it. But this is a proprietary Amazon managed service. But managed means you don't have to worry about the systems, the virtual machines. Enterprise level customers can use it because they don't have to re-engineer things, but they didn't have to re-engineer things anyway by moving the virtual machines. But because Amazon's managing it, you don't have to manage the maintenance, security, updates, monitoring, and troubleshooting of the message queue. Amazon Message Queue gives pay-as-you-go pricing, meaning users pay for what they use. Every time the message broker instance runs, the system is used. Storage is billed monthly, though. And AWS will calculate the number of gigabytes that are used each hour, and it'll divide it by the number of hours in each month. And the result will be a value of gigabyte months with data transfer fees charged separately. Now let's talk about SNS. SNS, or Simple Notification Service. It's a managed messaging service used to deliver message between systems and people, between systems and people. SNS is used to decouple messages between microservice applications. It can be used to send an email or a push message or a notification to mobile devices, like a message, hey, you've been hacked. Or a message that your CPU is 100%, go do something about it. SNS is great for this. SNS basically facilitates communication between senders and receivers using a publisher-subscribe model. So when you subscribe to a mailing list, for example, and you get an email, publisher-subscribe. So a publisher-subscribe messaging model enables notifications to be delivered to clients by using a push notification. You ever get a push notification from YouTube about a video? Same kind of thing with using a service like SNS. SNS will consist of two components, publishers and subscribers. The publishers send the message, the subscribers read the messages. I always like to use the term mailing list. To me, it makes sense. SNS is also used to do something called fanning out messages. What does that mean? Here we've got a publisher, but with subscriber, and we send that same message to multiple systems. And we could have a single message that could be sent to SQS, which could also be sent somewhere else or somewhere else. That's the fan out. But here's the point. Publishers send to a topic. The people subscribe to the topic, and they're there. But it could also be used to fan out message. We may have a message which would then go into a message queue, as well as a notification, and then there's terrific. Kind of keep that in the back of your mind. And all kinds of stuff. Chris, I just got your message. You're going to have to tell me after this class who was hired. I'm totally excited. Every day we get a new cloud hired, and I haven't had my cloud hired yet today. So super excited. Can't wait to hear. You know, we had 2 yesterday, so another one today. I'm thrilled. let's talk about SNS platform functionality. Sorry, I didn't realize I was behind my slides over there. SNS is a high availability platform that by default runs across multiple availability zones. And SNS can be used to fan out messages as I described before. So basically, you've got a message that's going to a Lambda function, an SQS queue, a notification. And SNS allows you to the creation of filter policies so you only receive notifications you're interested in. That's great, right? You only want to see what you're interested in. So let's talk about some use cases for SNS. SNS can send applications and systems alert. Hey, CPU is 80%. I have more capacity. SNS can take incoming messages and send them to multiple systems at the same time. That's called fanning out. SNS can be used for mobile notifications. I love this. Imagine an application that's being pushed to realtors, for example, that's while they're driving, that says, new house for sale right now. Go show your clients. So we're dealing with some pretty exciting stuff here. Let's talk next about elastic MapReduce. So when you're dealing in a big data environment, what you're really dealing with is taking an environment where you're going to take data from one source and move it to another source. Now, in the big data environment, typically somebody writes a Python Spark script, and it's used for mapping and reduction. So, example, you may have Mike. Mike may be spelled in all capitals. Then next it may be spelled in all lowercase. Then it may have a capital M and a lowercase IKE. And that obviously would be a problem when we're analyzing the data. So we need to normalize the data. Now, normally what happens is somebody makes a Python Spark script, and they do this automatically, but AWS has a service for doing it as well. Now, if you write a Python Spark script, you can use that same script across your 3 cloud providers. But if you don't have somebody in the big data environment that's good at writing that Python Spark script, you can use the AWS pre-managed service. And that's what Elastic MapReduce is. It's an application for processing large amounts of data. It's a managed cluster and service for managing big data frameworks. And it's really a pre-built framework that's going to facilitate big data analysis and processing without the need for server management, application installation, or configuration. And it's built upon open source tools such as Apache Stark, Apache Hive, Apache ASpace, Apache Flink, Apache Guido, or Presto. And it typically offers some higher performance than traditional solutions. And it could be less expensive if you don't have to code it yourself. Or if you've already got your scripts, that's cheaper to use your own scripts. And that's the key, is to determine what's best for you and the organization. Now, when it comes to NoSQL databases, I mentioned previously that DynamoDB wouldn't work in a multi-cloud environment. It won't, because it's proprietary. And it's not like we can have Cosmos DB, Google Cloud Bigtable, and DynamoDB across our 3 clouds. That's not going to work. But we could use a standards-based database, like Apache Cassandra or MongoDB, across all of them. So because of this, AWS came up with Amazon Key Spaces. And it's basically a serverless, fully managed Apache Cassandra compatible database. Now, the good news with this is you can take your data straight out of your Apache Cassandra database and put it directly in here. And there's no systems to manage. Of course, if you had an Apache Cassandra database, you could just take those virtual machines, move it to the 3 clouds, and have them synchronized and not have to worry about any of this. But, this is good for organizations that don't want to manage their own systems. The service is provisionally patched for them and deployed. And because there's nothing to worry about, it can be helpful because organizations don't need as sophisticated of an IT staff. But remember, when it's serverless, you have less to worry about, which is great. But you have less customization and capabilities. So serverless is simpler, but simpler doesn't mean better. It means different. If you need max control, max performance, don't go serverless. If you need simplicity and elegance, go serverless. all based upon the business case. By key spaces is a managed Apache Cassandra service. Again, excellent, excellent, excellent. So when you deal with Apache Cassandra, it's fully managed. Like I said, so there's nothing to manage, so it's much easier for you to deal with. You basically have two kinds of capacity and throughput modes for read and writes. On-demand mode and provision capacity mode. On-demand mode means it's basically what you think you need. And provision capacity mode is you tell it exactly, I need this much performance, and you're going to get it. Now let's talk about lake formation. If you need a data lake, there's two ways to do it. Your data architects can architect it their own way, normalize your data, and create their own data lakes, and that takes a level of sophistication. But with that level of sophistication, you get something very special. But it takes a level of sophistication. That level of sophistication gets expensive because now you need data architects, potentially even some data scientists. But if you didn't want as many of them and you wanted a simpler team, AWS has this service called Lake Formation. And Lake Formation is the managed service that facilitates the rapid deployment of a data lake. And a data lake is effectively a repository that holds large volumes of unprocessed and processed data in the same location. And this information will come from a variety of sources. Unprocessed data is going to be captured very quickly in its raw format. It'll be tagged with metadata, which will provide some information about the raw data. Conversely, processed data is going to be assigned to tables, fields, or other elements before storage. And while this will slow data capture speeds, it creates an environment that stores an unlimited amount of data in various formats. So, pretty darn awesome. Now, what happens is form these data lakes quickly and accessibly. And then we can use any kind of analytical, machine learning, or pattern matching techniques we use. See, that's the whole point of a data lake. Create all this data, store this data, and then use this data at some point in the future to make better business decisions, which can improve profitability, reduce costs, or improve information. And that's what we're talking about is actionable data. If an organization has data and they analyze that data and they mine that data, maybe they know that use this price and you're going to maximize sales. Maybe they know that at this time of the year, they don't need as many employees. Maybe they know this time of year, hire some temporary employees. The ability to make better predictions, otherwise known as inferences, is really how big data can do things. Big data can tell a customer, can tell a company their customer's desires. They might find out that I like cat things. And when they've got a new cat product, they might send me a cat email, as opposed to sending me an email every day, which is going to cause me to unsubscribe from the mailing list. So data, and more data is a really cool thing. Now let's talk about Amazon TimeSpring. Amazon TimeSpring is a fully managed, auto-scaling, distributed, fault-tolerant relational database. Uses basically, it's an SQL-based database, and the service specializes in storing and quickly tracking data variables that change over time, such as time series data, user data, IoT data, and it's capable of ingesting millions of events over a time interval from various device sensors, etc. Now let's talk about CloudWatch. CloudWatch is just an event monitoring or logging service. CloudTrail, auditing. CloudWatch, logging, because we'll get to these and people confuse them. CloudTrail, auditing. CloudWatch, logging. It's just a log. Now, CloudWatch is a monitoring service that's going to monitor your AWS resources and applications on AWS. It's going to provide you system metrics, like CPU usage, by the way, or disk usage. It can monitor applications, give you custom metrics. So, I mean, let's look at it realistically speaking. It's just no different than logging than any other organization would have for their business. With Amazon CloudWatch, it'll collect information. You can monitor that information. You can analyze the information that you get. You can act on that information and make changes. And then you can remonitor, react, and then reanalyze until you get it right. And this is going to be a constant state of flux. It's never one thing where it's always going to be the same thing. CloudWatch can monitor a lot of things by default. It looks at CPU utilization, disk read write in terms of input and output operations per second, and network utilization. Now, that's not a lot. The default is disk I/O, CPU, and network. But if you need better logging, you can use custom metrics. Maybe you want to look at your memory utilization or your API performance or other metrics. CloudWatch also has a notification system that notifies you when things are there. Ding, 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 tell your systems administrators your systems are at 80% load. Maybe add capacity. And a CloudWatch event that sees something good or bad can then trigger auto scaling, increase your capacity, kind of cool. It can trigger a Lambda function to remediate something like that, to remediate something like, wait, it found an S3 bucket that's not doing what it's supposed to be. And then you can do something about it or act upon it. AWS CloudWatch is available in 2 versions for EC2 instances, basic monitoring. And with basic monitoring, your data is going to be available every 5 minutes, and if it's accessible to you at no charge, let me tell you, capturing your data every 5 minutes is not often enough to give you the peaks and troughs and to really see what's going on. Many times, if you really look at it, you'll see that for 3 seconds, the CPU hits 100% and you got a problem, and then it's averaging to 30%. So 5 minutes default, probably not good enough. When you use the detailed monitoring, you can get your data at least once a minute, but then you're going to pay extra for it. And detailed monitoring must be enabled on your virtual machines, otherwise known as your EC2 instances. CloudWatch events deliver a near real-time stream of system events that describe changes in your account. You can set up a rule to match events, route them per a particular function or stream. CloudWatch events will become aware of the operational changes in your system as they occur. And CloudWatch will respond to these events and changes by taking corrective action, sending messages, respond to something like activating a Lambda function. Any kind of logging you can do is always a good thing. Now, I mentioned CloudWatch does logging, and CloudTrail does auditing. So what do you think we're getting next to? CloudTrail, everybody. CloudTrail is an AWS service that assists with the auditing process. It provides an audit log that assists you with risk management. So manage your in healthcare or finance, and you need to know exactly what your people are doing. Here you go. Completely go. So that's what we're actually dealing with. You can find out who does what and tracks it. CloudTrail can track changes made to an AWS account by a user, which means a person, a role, which typically means a system or a service. When CloudTrail is enabled, is enabled automatically as soon as your AWS account is created. But then if you want to monitor, you're going to create a trail at the CloudWatch console, CLI or CloudTrail API, and it will record events, and these events are going to be visible in the CloudTrail console under your event history. Your CloudTrail event history will let you view events that have occurred in the last 90 days. Additionally, CloudTrail can be configured to store logs in an S3 bucket for long-term storage. Long-term storage, long-term logs, machine learning on your logs, analysis of your logs, HIPAA compliance on your logs, banking compliance in your logs. That's what you store in that story. Now, when we create a CloudTrail, we can create 2 kinds of trails. We can create a CloudTrail that is local to one region, and a one region only CloudTrail to give us the information from one region. And it's going to store the CloudWatch log, the CloudTrail logs in a single bucket. And this is the default option when CloudTrail is configured via the CLI or the API. By comparison, we can create a CloudTrail that applies to all regions. And this will provide the most comprehensive logging and auditing option. It'll provide a record of all events that exist inside of the organization's entire infrastructure. And this can help correlate problems across global organizations and global infrastructures. And that's the key. You may find something that happened in one part of the world and then something else that happened in another part of the world. And if you couldn't correlate the events, you wouldn't know that they were related, when in many cases they are related. All of this stuff is about event correlation. How does one thing impact something else? Okay, let's talk about CloudTrail a little more. Here you can see we've got our virtual machines, EC2, our identity and access management, our database. And it uses cloud. And it's storing all these logs into an S3 bucket. And that's the key. That's the key. And it's all done for you. And it's all done storing all your information for long-term storage analysis. Okay, let's get involved into AWS Config very quickly, then we'll take a break and answer some questions. AWS Config is a service that enables the assessment, auditing, and evaluation of configurations in AWS. It provides an opportunity to see what changes were made and by whom. When a change is made in AWS Config, it can send an SNS alert to systems admin. How cool is that? Somebody does something and you get notified, hey, by the way, somebody made a change. Pretty helpful if they're not supposed to be making changes. In like a production environment, for example, people don't make changes during the day unless it's an outage or during high periods of use. And knowing when somebody made a change when all of a sudden you have a problem is pretty great, so you know how to revert that change. So config is going to provide constant monitoring of all configurations. It's going to check these configurations against an organization's policy. And that way, if a change is made that violates the policy, you can get an SNS alert. Remember those notifications? And a CloudWatch event will occur. And because the CloudWatch event occurs, we've got options. We can basically set up a Lambda function to remediate that event should we need to. It can tell us that something was done, so if there's a problem, we can go fix it. And we can integrate this with CloudTrail, so when a configuration changes are made, we know what it is and we can fix it should there be a problem. Okay, before we get back to the content, if you can give me a hashtag AWS Certified Solution Architect Associate. And if you've not liked it yet, please like, please subscribe, and please hit the bell. And before we do this, we'll answer questions like Cash. Like Cash's real quick question, do I need to learn Apache Kafka? Well, it depends. Are you an architect? You need to know what Apache Kafka does and how to integrate it and its strengths and weaknesses, but we don't touch the tech as an architect. Now, if you're going to be a big data engineer, then yes, you need to get real familiar with Apache Kafka. Okay, I'm seeing it. I'm not seeing enough subscribes and likes yet, though. Maybe help us out with that. I'm looking to check and see if you guys are paying attention to us. We work pretty hard. I'm doing with laryngitis, drinking a turmeric and a ginger tea, trying to soothe the throat. So give us some likes and comments, please. Okay, now let's talk about CloudFront. CloudFront is something I love because it's a content delivery network. And I love content delivery network. Why? They improve performance and enhance security. Nothing better than improving performance and enhancing security at the same time. Plus, content delivery networks in many cases can even cut your costs down. So improving performance, improving security, cutting costs. Can you imagine how awesome this stuff is? Love it, love it, love it. It doesn't get any better than this. So when you're dealing with multi-clouds, you're going to need multiple content delivery networks. Why? A single content delivery network is a single point of failure. Don't believe me? The entire country of India was nearly taken down because it was relying predominantly on a single content delivery network. That went down. Half of India's internet access went down. Real businesses that are high availability use multi-clouds and multi-content delivery networks. But we're on your certification, we're going to talk about the CloudFront. And CloudFront isn't exceptionally good, just like these other content delivery networks. It's the Amazon branded content delivery network. And what is a content delivery network? Everybody's going to tell you that it's a geographically distributed group of servers. It is a group of servers, but it's also a network, which means it provides private network access, high performance network access, and user caching with the servers. So this will provide caching and many other optimizations. Now, CloudFront or any content delivery network can dramatically improve your web hosting performance. Now, CloudFront's integrated with a lot of AWS services, making it simple and elegant on AWS. Here's what's going to happen when a request is made. And I'm going to graphically show you this in a minute. What's ultimately going to happen is it's going to hit the CloudFront content delivery network. So here I go. Here's an example. Today I want to go to www.cindythecutecat.com. And when I go to www.cindythecutecat.com, I go to the CloudFront distribution. Mine is in Miami. And there's nothing there on the CloudFront distribution. So I hit the CloudFront distribution. It goes to the Cindy the Cat website. It gets sent back to CloudFront. And then it gets sent back to me. Now my wife wants to see Cindy the Cat's videos. So my wife uses the computer in the other room. She goes to the CloudFront distribution and Cindy's photos and websites right there because I just accessed it. Now Child comes and visits me in Florida and she wants to see photos of Cindy. So she's at our house in Florida. She goes, she gets instant access to photos of Cindy. And we're all happy. And the only time the website actually have to answer the request was for me. And that's why we love these things. So what happened is if I get 100 more requests in Florida, the cache will answer it 100 times. So that took 99 of those web requests off of me, and they sent it to Cindy, 99 requests off of the web server. So you can see huge amount of scalability here. So what will happen is the CloudFront servers will speed content, they will reduce loads, and in many cases, they'll reduce costs. Because what will happen is, let's just walk you through it in the graphics. So in this graphic that I'd like to show you, here we go. Now, here we go. Your first person makes a web request, and it hits the CloudFront location. If it's not at the CloudFront location, what I'll actually go to is the regional cache. And if it's not on the regional cache, what's going to happen is it's going to ride the Amazon internal network, not the public internet, to that S3 bucket, which is the source of my static website. So request immediately hits CloudFront. CloudFront, if it has it, it's going to send it back to me. But if it doesn't, instead of using the public internet to get to the website, it's going to jump on the express highway lane, the private network that AWS controls, and go straight to the S3 bucket. So it's going to get off the internet onto a better network. Now then, what'll happen, the asset will leave the S3 bucket, it'll sit on that CloudFront cache, and it'll be sent to me. Now, the second request you can see on the user on the bottom, the user requests the same thing as the previous person, and it goes to CloudFront and it's answered. So now think about this. In a DDoS environment, if I had 100,000 requests to that Miami CloudFront location, and they were all valid requests, CloudFront would handle the 100,000 requests, which means my web servers don't. You see how that helps? Now, what if we were dealing with inter-regional charges, like AWS bills you in between regions? Guess what? We don't have to worry about that either. And why do we not have to worry about that either? Because the content's cached and it's not constantly transferring across the inter-regional divisions. So we can save a huge load on our servers, and at the same time, we can increase security and cut our costs. So when we're talking about these things, what are we really dealing with? We're really dealing with website scalability. We're dealing with increased security. And we're dealing with things. Now, when does caching not help? If all of our website stuff is dynamic and changing every minute, and every user is accessing different information, now caching will actually increase latency and reduce the effectiveness. So like all architectures, we must know what is our usage patterns prior to deploying any piece of technology. Hence the reason the most critical skill for the cloud architect, solutions architect, is communication skills to find out the customer's business pattern. Because the business requirements drive anything. It's not, the tech doesn't drive the business. That's like the tail wagging the dog. The business determines exactly what technology we use as architects And engineers, we hand them a piece of paper. They're geniuses that say, build this, and they build it. Different job, different role. So CloudFront's going to integrate with a whole lot of AWS services. It'll integrate with your basically S3 if you had static website content, your EC2 instances and load balancers for dynamic content. It'll work through Route 53 for your DNS. Again, if you're using multiple cloud providers, you're not going to be using Route 53. CloudFront could be used as a front end to a static website. It can also be a front end to an EC2 based website, assuming a load balancer as part of the architecture. So realistically speaking, what are we actually dealing with? What we're dealing with is the following. We're dealing with CloudFront being the front end to static content on an S3 bucket and the dynamic content of our website. And why might we do this? Well, we may have a bunch of pictures and videos, and the cheapest place to store them is putting them on the object storage. And for example, you know, what we're dealing with regards to the front end, the EC2 instances, that's for our dynamic web pages. Let's talk about some key concepts with regards to CloudFront. We're going to talk about distributions, origins, and cache control. A CloudFront distribution is as follows. It's basically identified by your DNS name. And it's going to look like abcdefg111.cloudfront.net. In fact, if you were here the day before, I'll do it one more time in case you guys didn't remember the other day. Bear with me a second. Chris, I'm going to try and share something in a second. When I do so, please share the window for me. Okay, Chris, share this window from my Mac. It's my terminal window. And here we're going to do an NS lookup. We'll identify our name servers, and we're going to do www.amazon.com. Here, what you can see over here is we actually have this ugly name. And look at which CloudFront they're using right now, which content delivery network they're using right now. They're not even using their own content delivery network. Who knows, maybe something's going on with CloudFront. And you can see that Amazon.com is actually using Akamai's content delivery network. And you can see this Echo 15316-Delta Sierra Charlie Alpha.akamaiedge.net. So right now, Amazon is using the Akamai's content delivery network. 2 days ago, it was using CloudFront. And in this particular environment, maybe CloudFront's down. And that's what we're dealing with. So this is actually the new URL of your company once you use a content delivery network. Now, clearly, we want to use Amazon.com and not this ugly thing. So what ultimately happens is we'd create a CNAME record that'll map Amazon.com, which is user-friendly, to this ugly-looking thing, which is on the Akamai network, and here's its IP address. Oops, not what I was trying to send there. Okay, thanks, Chris, for fixing that for me and reading my mind. Chris, you're fantastic. So
I know, man. Thank you.
Thank you. Seriously, Chris is my chief operating officer. He's amazing. He doesn't need to be producing my stuff, but he makes sure that we're successful, and I feel extra safe knowing he's behind the scenes. So let's talk about the CloudFront origin now. When you set up CloudFront, you really have to specify an origin. And an origin is really the location of where your content is coming from. Whether it's an S3 bucket, the load balancer that's front ending your website, where's your content coming from? That's the CloudFront origin. And anytime you're setting up a content delivery network or dealing with a cache, you're going to have something called cache control. The whole point of CloudFront is to cache or temporarily cache the information. But let's talk a little bit about caches and cache control. By default, your information is cached for 24 hours. 24 hours. Now, why is this done? Well, if I post a photo of my beautiful Cindy the cat, she's the cutest thing I've ever seen. Of course, I'm a little bit biased. and you see the photo of Cindy the cat. Now, if we cache it for 24 hours, for the next 24 hours, the cache will hold that Cindy the cat photo so the website doesn't have to respond. Now, this is good if the website doesn't change more than once every 24 hours. More scalability, faster web load speeds, all great things. But what if Cindy likes to post on her website 4 times a day? She's got one where she's laying on her back with her hands in the air, another one where she's sleeping. There's a video of her doing a flip to chase a bird outside the house. And there's another photo with a little lizard in her mouth that she just brought in to surprise me. Now, if we cache it for 24 hours, the only people who are going to see the first photo, nobody's going to see the second. And Cindy the cat will be angry that nobody's seeing her new photos on her website. So then we would reduce the cache to change more frequently. So longer cache times out, more scalability, but the people won't see new updates on your page. Shorter update times mean lower performance, and the cache is going to time out more frequently and more workload for your servers. So what drives this? Your usage pattern. Like everything else, it's based upon your business requirements. So part of the things the architect would have to interview, let's say Cindy was the actor and actress here, we'd have to have a conversation with Cindy. What's your publishing schedule? What's on here? How many times a day do you want people to see your new photos and videos? So that's where you'll have to get it from your customer. Find out your customer's business pattern for your page, and then determine the appropriate cache control, which is also called the TTL. Now, if any of you guys and girls have ever worked with a cache before, or dealt with anything, you know, periodically systems get corrupt. And if you have bad data in your cache, you could be spending bad data for upwards of 24 hours to your customers, and that would be real bad. So you can always clear the cache. Keep that in the back of your mind. So let's talk about setting up the CloudFront distribution. How would it be done? Well, basically you set up your web servers and put your content on them. After you set up your web servers and you put your content on them, you're going to create the CloudFront distribution. AWS will give you one of those ugly, ugly, ugly domain names. And you can either accept that domain name, or you create a CNAME record like AWS did, and they will provision your edge computers. Like I said, never use a single content delivery network. And as you can see, when we did this 2 days ago, Amazon was using the Amazon Content Delivery Network a few days ago, and today they're using the Akamai Content Delivery Network. So even they use multiple service providers, as do we all. So now let's walk through CloudFront one more time. It's something I showed you on the first day. Here's basically the architecture. You got your regions, which are your giant geographic areas. You've got your data centers inside of each geographic area, called availability zones, and then we have your edge locations. Now, how's it going to work? Let's do it one more time. Let's take the user in the upper right-hand corner. Hi, I'm a user. I request a web page, www.gocloudcareers.com. I hit the edge location. It's not there. So my request hits the edge location. It hits the regional cache. It's on the AWS private network backbone, their content delivery network backbone. It gets sent to the source. It gets sent back to the regional cache, which gets sent then to the edge location, which then gets sent to the user. Now, the subsequent users that hit that same edge location in the top corner will basically get it immediately. Now, if a user on the bottom edge location requests a photo from www.gocloudcareers.com, if it's not on the cache, it'll go to the cache, the edge location, hit the regional cache, ride the private network from the content delivery network back to AWS, come back to the regional cache, put it on the edge location, and then give it to the user. And that's how these things sort of work. And that's how they help. Let's talk a little more about what we're dealing with. CloudFront, as we mentioned, can increase website performance dramatically because it caches your content. At the time we made this, there were 217 points of presence for CloudWatch. I'm going to tell you right now, that's always going to change and grow. It helps with your routing efficiency for the following reason. Normally, your web requests would traverse the public internet. but there's no guarantees of performance on the public internet. So what you really want to do is you want to use CloudFront, either hit the cache, jump off of the public internet, jump onto your content delivery network, use that higher speed content delivery network to go back to the source. So no matter what, it's going to increase systems. Now, you can help with your routing efficiency, as I mentioned, because you're going to traverse the AWS network, not their content delivery network, not the public internet. And CloudFront also maintains persistent connections to the source. So you're not starting a new session with the web server for every request. So that, that TCP SYN and ACK and SYNACK that were necessary to open up a connection, it's already maintained. So it's further going to reduce the latency. Content delivery networks are excellent, but you need multiple ones. CloudFront, you can obviously put your web application firewall there, but you can also put your shield there. In this way, your DDoS protection can be straight on the content delivery network. Before they hit your firewalls, before they hit anything, block all bad requests before they ever get to you. So all content delivery networks dramatically increase in distributed denial of service attack prevention. And by being able to put shield directly on the content delivery network, you get it. Then again, Akamai's got their own DDoS protection. Microsoft's content delivery network has their own DDoS protection. Cloudflare is another content delivery network. They've got their own DDoS protection. So this is normal functionality with regards to a content delivery network. But again, that ability to terminate your SSL HTTPS connections on the CDN without even hitting your servers reduces load. The ability to make sure that the servers don't have to answer to everything, only new responses reduces load. So increased speed, performance, and in many cases reduces cost. Now CloudFront can also provide your encryption in transit because it can enforce SSL/TLS protocols. It'll integrate with many services such as the certificate manager, and CloudFront supports server name identification and custom certificates. Now, normally speaking, use CloudFront for a public website. But what if you wanted a private website, for example? Paid website subscribers, private applications. There are a couple ways to do this. We can set up an origin access identity, and we can restrict the data to, say, an S3 bucket to certain individuals. We can use a signed URL, or we could use some signed cookies. And that's where we're at for right now. Let me very quickly do something about some Lambda functions. And after Lambda functions, we'll take some questions. So let's talk about Lambda next. Lambda is a serverless computing service, and it's used for micro things. Basically, you upgrade the code and the Lambda function works. It's the same thing as an Azure function, for example. And there's no need to manage servers or operating systems. It's basically quick and dirty things. C#, Java, Node.js, Python. Basically, it's a way for you to automate simple things. The way we're going to use Lambda is as follows. The user is going to update their code. And when something happens, the function is going to run. And we're going to pay every time that Lambda function runs. Lambda is stateless, which means it doesn't track anything. Functions performed and completed. If you need another function, you're going to have to set up another function. It's not looking at a multi-step function without doing something else. And therefore, Lambda is useful in many situations where automation can create an increase in efficiency or decrease manual intervention to process data across multiple systems because your S3 buckets, for example, got hit by a security event, patching of an operating systems, for example. Now, a Lambda function can respond to an event. You misconfigured S3 bucket, ding, 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 run, fix something. A user can, or for example, we could create our own thing. For example, let's walk through something that here would be a great place for a Lambda function. Let's say, for example, I wanted to upload a video to S3, and I had a multi-step video process. I could create a Lambda function to have the video transcribed, and another Lambda function to basically have the video converted from, say, raw video to H.264 or H.265. I could then even have another Lambda function to send me an email that says, hey, Mike, your video is ready. It's been processed, transcribed. Go download it. So Lambda is really about automating. These compute Lambda functions are exceptionally good for digital transformation. One of the things we absolutely love about the cloud or something like this. It's complete. Now let's talk about Lambda at Edge. Since we just talked about CloudFront, what if we wanted to run a Lambda function basically right next to the user? Well, we use Lambda at Edge. It's completely serverless, and it works with the CDN. So let's talk about Lambda at Edge. And Lambda at Edge, basically you upload your code, and it'll run directly, basically by your CloudFront location. Very simple and elegant. While we're tying Lambda together, we're going to enter step functions, and then we're going to go to questions and answers, and we probably should end right there. So let's talk about step functions. If you've got multiple Lambda sequences, I mentioned they're stateless, you're going to need to schedule them. And that's where step functions comes in. It enables you to create step 1, step 2, step 3, step 4. So execute step function 1, execute step function 2, execute step function 3, execute step function 4. So how's it going to work? You design the steps of the application. We create individual Lambda functions. We're going to configure the workflow in step functions. We'll connect the workflow components to the individual Lambda functions. Each function will execute its step, and it will optimize and evolve the data functions as needed. Here's a graphic for how that works, and then I will take questions. Basically, step 1, step 2. So step 1, Lambda function, step 2, Lambda function, step 3, Lambda function, step 4, Lambda function. Good to see you. So the first thing we're going to talk about today is the certificate manager. When you're dealing with websites and HTTP and HTTPS, what you're really dealing with is you want to make sure that it's encrypted. And you have to identify that the website is who they claim to be. For example, if I was going to a website to go buy cat toys, right? If I thought I was going to a cat toy website and instead it was a hacker's website, that hacker could steal my credit card information and my beautiful cat Cindy wouldn't get the cat toy. So two things would happen. My credit card would be compromised and my cat Cindy would be really sad, and we don't like my cat Cindy to be sad. So we need to know that we're connecting to a website that they are who they claim to be. And there's not a hacker in the middle. So that's what we do is we put a certificate on a website. The certificates on our website enable us to determine who they are, help us do our encryption, verification, and things like that. And the AWS Certificate Manager is a service to help you do that. And Certificate Manager adds protection to websites by using certificates to establish safe and secure connections. Now, Certificate Manager itself is an AWS proprietary service that enables for the simple provisioning, management, and deployment of your certificates, both public certificates and private certificates. What's the difference? A public certificate you put on your external website. A private certificate you might do on your internet, which is accessible only from your internal network, not the internet. And Certificate Manager allows users to deploy certificates on AWS resources very quickly and efficiently. And Certificate Manager provides free and public certificates to services like our load balancers or our API gateways. Now let's look, graphically speaking, for about a moment what Certificate Manager actually looks like. You can see in this environment, we've got a Certificate Manager that we can put on our Elastic load balancers or our CloudFront content delivery network. Mind you, in reality, many organizations will use many content delivery networks, at least one or two, but we can definitely put it on the CloudFront distribution. So Certificate Manager is going to help you with security by making sure you can identify and use basic encryption, HTTPS type encryption, or SSL-based encryption, otherwise known as TLS encryption, for your website. Let's talk a little bit more about Certificate Manager. There are two options when deploying certificates, and there's going to be the public and the private CA. And private CA is used for communication inside of your organization. Now, private CA certificates you have to pay for. And these are basically what happens. You can issue a certificate, put on specific users, computers, applications, or servers, and that way internally your users can authenticate a system and the users can be authenticated. Now, with a private certificate, you can't use it on the internet, right? Because it's private. Now, public certificates obviously are public and they're free, and you can use them for your external facing websites. Now let's talk about Kendra. Kendra is another service, and it's a fully managed service managed by machine learning. Now, Kendra lets users search through structured and unstructured data. And what happens is Kendra uses natural language processing to understand the context of a user's query and find relevant answers. What'll happen is Kendra will index your documents, whether it's unstructured text such as HTML, PowerPoint file presentations, Microsoft Word documents, plain text documents, or PDFs. Kendra is capable of indexing structured text, for example, frequently asked questions. Now, document attributes can be used to with Kendra can be used to filter responses as well as queries. And of course, we can set up custom attributes that can be added to documents as well as very specific searches. Now, with Kendra, our queries can be directed towards more relevant results by increasing or decreasing the importance of an individual field in the index. How tight do you want to search is really what we're talking about. And if the user adds more weights than the importance of the highest replies or views, users can see postings that are more popular or hot on forums. So it gives us the ability to use machine learning to parse through a fair amount of information. And the type of machine learning we're using in this particular case is natural language processing. Now we're going to get into Kinesis. And Kinesis is a streaming service. Now it is a proprietary streaming service. So many organizations can't use it. Again, Kinesis to me feels like something that you could toss away and replace it with Apache Kafka. And many big organizations in the cloud have done so because they don't want to lock themselves into a proprietary solution. But this isn't reality. This is an AWS Certified Solution Architect Associate and/or professional help training. And when you're dealing with an AWS certification, it's designed to make sure you know the AWS product set, kind of make you excited to go recommend it and sell it. So we're going to talk about it. Again, this is in a multi-cloud environment or a real critical high availability situation. You're going to be using Apache Kafka, not Kinesis. Now, Kinesis is a service for collecting, processing, and analyzing streaming data. Now, Kinesis can collect information in real time, and that's kind of nice, but you can do this with Kafka as well. And typically we use it for video or application logs or website click streams or IoT devices. And normally there's two ways of collecting information. You could just collect information in system logs and store it, and then analyze it later. Or you can use a streaming service like Kinesis or Apache Kafka, and you can connect the data in real time, and you can kind of analyze the data in real time, visualize the data in real time, and think about it this way. What kind of a competitive advantage could you absolutely get? If you have historical information, you can make data after the fact. But if you have real-time information, you can make much better decisions. Let's talk about Kinesis. Kinesis is ideal for situations when large amounts of streaming data need to be processed and rapidly moved. Think of it this way. If you had weather sensors all over the Caribbean and Florida, and a hurricane is coming, how cool would it be to have access to be able to look at that information, visualize that information, and analyze it in real time? That's what we're talking about. Or a bunch of airplanes flying around where you want to get their status and make sure they don't bump into each other. It's high traffic when you're actually in these airplanes. We don't realize it in our seats, but the pilots will tell you it's like a congested highway over there. Kind of keep that in the back of your mind. Now, when we talk about Kinesis, we're going to talk about 4 platforms, and they're going to be Kinesis Video Streams, Kinesis Data Streams, Kinesis Data Firehose, and Kinesis Data Analytics. Let's talk first about Kinesis Data Firehose. It's a managed service to load streaming data into data stores, data lakes, and analytic services. Kinesis Data Firehose can capture streaming data and put it into S3 or Redshift, as well as many other services. And it's fully managed and auto-scaling, and it'll scale as you need to for the throughput with auto-scaling. And of course, you can monitor what's going through Kinesis Firehose. Now, when data is going through Kinesis Data Firehose, or Kinesis for that matter, the throughput is going to be measured in shards. And a shard is basically going to be 1 megabit per second. Now, that doesn't sound like a lot when you're dealing with video, because it's not. But when you're dealing with little text files from internet sensors, those kind of things, that's a lot of data. Now, when you're going to do, you obviously could use multiple shards. And the pricing is going to be based upon the number of shards. So like anything else, prior to use, your organization should determine the required shards in terms of capacity. And of course, you can increase it when capacity is needed. A little more about data firehose. We can use up to 10 shards per region per account. And if we need more than 10 shards, no big deal. We just contact AWS support and they can enable it to work. We could also set up an auto-scaling policy to auto-scale the number of shards based upon utilization. Now we can set up Kinesis Data Firehose from the console. Setup is essentially setting up the sources and the destinations for your data. Now we're dealing with Kinesis Data Firehose. Streaming data is captured by the Firehose, and we can send it and store it in S3, and we can also analyze the data tools with analytics tools. So let's look at what this typically could look like visually. In this environment, you can see we've got multiple data streams coming in. We've taken these data streams in, and we've popped these data streams into Kinesis Firehose. From the Kinesis Firehose, you can see that we're putting it into an S3 bucket. And from there, what we're actually doing is we're using analytical tools to kind of look at it. Maybe something like Tableau or Tableau or Power BI. Those kind of analytics tools give us the ability to parse through large amounts of information and actually visit them. Now let's talk about some Kinesis Data Firehose concepts. With Kinesis Data Firehose, we basically have a delivery stream, which is data coming in, and you set your Kinesis Firehose by creating a Kinesis Data Firehose delivery system, and then we get a record. And the record is the data that's ingested. Record can be as large as 1 megabyte. A few more things as we talk about Kinesis Data Firehose. We've got our data producers, right? That's the stuff that's sending you the information. Our IoT devices, for example. We also may have a buffer size and a buffer interval. And what is that? Well, when we're dealing with Kinesis data coming in, it buffers incoming data streams to a certain size for a certain period of time before delivering it to the destination. Makes sense. Bundle up your data, send it, bundle up your data, bundle up your data. And it's not a lot of time that it's going to be there, but it's a short buffer interval. Now we talked about Kinesis Data Firehose. Let's talk about Kinesis Video Streams. Every connected device, such as a smart car, smartphone, camera of any kind, we can use that data with Kinesis Video Streams. So we can pull information from all kinds of video devices. We can store the information, convert the information, and encrypt it, or we can analyze it in real time. And Kinesis Video Streams automatically scales to handle any amount of data, and it's used by analysts, AI, machine learning, and that way we can look at what's coming in and analyze it in real time using tools. A Kinesis application specifically for video streams. So video streams enable the ingestion. So it's really about pulling things in, as are all of these things. And one advantage of streaming through this platform is that users can collect, save, and process and analyze data. So let's look a little bit about Kinesis Video Streams. Here you go in this environment. We can be taking in data from a lot of different places, analyze it, and use it for media processing. Let's look if we wanted to crowdsource a video thing, for example, and we wanted to basically enable 1,000 users to be streaming their video so we could create a movie based upon cell phone information. Imagine using Kinesis Video Streams. Pull information from a variety of sources, and wow, you can do something very cool. So Kinesis Video Streams is a nice concept. Now we've talked about Kinesis Firehose, we've talked about Kinesis Video Streams, let's talk about Kinesis Data Streams. Now Kinesis Data Streams is a scalable platform to capture real-time streaming data. And it can capture data in real time, and you can actually analyze it within 70 milliseconds, which is pretty darn fast. Imagine capturing capturing gigabytes from hundreds of sources, or hundreds of thousands of sources, and instantly making a decision. Financial transactions, location tracking. So Kinesis Streams can ingest data and then export it to a business intelligence tool. What's happening is the streaming data is going to be captured by Kinesis Data Streams. It's then sent for processing, and it can be sent to a tool like Power BI. So let's look at what this actually can be used in concept. and we'll talk about some Kinesis data streams term. Here we go. We've got our data coming into Kinesis data streams. Now that our data is coming into Kinesis data streams, it's sent to Kinesis. Now we could be using, say, Power BI or QuickSight or some tool like that. And we can look at our data and do something about it in real time. Now, when we talk about Kinesis data streams, there's a couple things which could pop up on your exam. So let's make sure we talk about it. We've got the data producer, which is the application that emits the data records. And what will happen is the data producer will assign a partition key, and the partition keys will ultimately determine which shard is going to ingest your data. And of course, we're going to have the data consumer. What is the data consumer? It's what's receiving the data from all shards as they're generated. Most data consumers are receiving the most recent data in a shard, and that's going to be used for real-time analytics or handling of your data. So let's talk about when we would use Kinesis data streams: large event data collection, real-time data analytics, capturing gaming data, for example, or capturing mobile data. Quite useful in a lot of cases. Now, let's talk about Kinesis data analytics, a new service, or a different service. Now, Kinesis Data Analytics is going to be a managed service that's used to transform and analyze streaming data in real time. Kinesis Data Analytics uses the built-in Apache Flink to process data, which is what many organizations use for big data processing. Kinesis Streams is auto-scaling, which means it's going to scale the needs to meet your organizational needs. And data on Kinesis data streams can be queried via standard SQL type queries. Sorry, I'm trying to call it data analytics. I'm calling it data streams. Apologies for that. So let's look graphically at Kinesis data analytics. You can see we have a data stream that's going into analytics, and then it's going to a business intelligence tool so we can analyze the information and have better business decisions in real time. Now, AWS knows most people would not use this. They use Apache Kafka by building their own Apache Kafka servers. So now they're trying to make a managed streaming platform for Apache Kafka. And now that's exactly what managed streaming for Apache Kafka is. It's a fully managed service that allows users to build and run their own applications and use Apache Kafka for data stream processing in AWS. Of course, you could build your own and not use any of these managed services and use those same virtual machines in multiple clouds for high availability. But if you want a managed service and you don't want to manage the server, the operating system, and patching it, here's your option. So managed streaming for Kafka is a fast, scalable, durable, and fault-tolerant streaming platform. And it's going to provide a unified, high-throughput, highly distributed messaging system. And it's a low-latency platform for handling real-time data feeds. It's distributed, partitioned, and really basically gives you a good logging environment. It provides a publish subscribe message bus that can be used to build real-time data pipelines and streaming applications. Managed streaming for Kafka is a distributed platform designed to handle large amounts of data. It can be used to store and process large amounts of data. Let's talk about another service which could pop up on your Certified Solution Architect Associate or Certified Solution Architect Professional exam. AWS Outpost. And what is the AWS Outpost? It's basically, AWS would define it as a fully managed service that uses EC2 instances or a series of EC2 instances configured inside of your VPC in an appliance. What is it really? You go buy a server from AWS, you store that server inside of your data center, and AWS manages that server, and now you've got EC2 instances inside your data center. Now, the reality is you just put your own server here and manage your own systems, and you don't have to buy that server from AWS, but you have to manage it. So that's what it is. It's a fully managed server that's got your own virtual machines that you stick in your data center, and they manage it for you. The AWS Outpost appliance acts as a virtual part of your VPC. Yeah, part of your VPC, even though it's sitting in your data center, which is placed in your data center. Now, why would you put this AWS Outpost in your data center? Because the latency to the cloud is long and slow, and even edge computing is not that great. So by putting the server in your data center, now you've got a beautiful environment. Of course, you don't need to buy Outpost at all. You could just get a server from Dell, for example, and it'd probably be a lot cheaper, Of course, you'd have to manage it yourself. But if you don't want to manage the server yourself, you can get the server from AWS. And because that way is part of your own EC2 and your VPC, you could use the cloud tools to manage it as opposed to the standard tools to manage a server, whichever is easiest for you. So now let's talk about Comprehend, another machine learning service from AWS. And Amazon Comprehend is a natural language processing service. And what happens is natural language processing is a machine learning artificial intelligence service that gives computers the ability to interpret text or speech, similar to the way the humans do, but not exactly. What happens is human language will be dissected into pieces so that the grammatical structure of the sentences and the meaning of the words can be evaluated by machine learning. From there, natural language processing will extract critical elements from the data. Natural language processing can identify patterns as well as recognize the sentiments of the context, which is pretty cool. But we've got a long way to go. With the intelligence to mimic human abilities or understanding language context, natural language processing can help save businesses money because it can automate processes. For example, recognizing client behavior and the preferences of voicemails and text, mining data from various sources, making it easier to extract useful information so that businesses can have a better understanding of the insights of the customers they're serving, for example, dissect the meaning of videos to see if there's any negative content that needs to be flagged, categories of documents. So a great way to use technology to look through your video context and all your things and text context to see if anything's offensive, not good, get a sentiment of your customers. It's great. These are great tools. Now, AI tools are not a replacement for humans. They are supporting humans because the humans have the ultimate judgment. No machine learning tool has ultimate judgment, but it can parse through large amounts of information and help provide decision support so the humans can actually make better business decisions. Let's talk about Elastic Transcoder. Now, this is a service for converting videos between various video formats in the cloud. It's easy to use, cost-effective, and highly scalable way to convert videos that somebody stores in S3 to some other version. Now, you can do this on your own servers. It can be done in the CPU and the GPU, but it's computationally expensive. So what is this really about? I could actually shoot uncompressed video and have a 1 terabyte file after 15 minutes of video. Now, I can't stream a terabyte inside of 15 minutes because most users don't have the internet bandwidth for that because they don't have a 10 gig internet link. So what happens is we take our video and put the video into a compression algorithm, typically called the codec. And the codec, which is not exactly a compression algorithm, but it's mostly a compression algorithm, will change that video format to, say, an MP4. And by doing it, it can take video that might be a terabyte and make it maybe 10 gigabytes or 20 gigabytes. So it's packageable and streamable and distributed. And Elastic Transcoder can do it for you on the cloud. So you don't need big Xeon systems or big AMD EPYC servers to do it. And these things, like I said, they're very computationally expensive. I can tell you internally, when I need to transcode a video, I use a system that's got 64 cores and a $2,000 GPU in it and a half a terabyte of RAM. So you could buy a system like that where you could pay to use a service like Elastic Transcoder. What's going to be the determining factor whether it's good for you or not? How many of these things you need to do and how often you need to run these systems. So Elastic Transcoder is easy to use because it's got a very clear workflow and predefined video formats that can be selected for lots of output devices. It's available in various AWS regions, and users can just transcode their content wherever it's stored. And users are paying only for the minutes needed to transcode the videos. Let's talk about Poly. Now, Poly is a cloud service that's going to transform text into lifelike speech. Dozens of voices are available in different countries, and it gives the user the ability to create a web page with somewhat realistic speech. We've all been to websites where it's got like some robot that's trying to read you an article, and it sounds sort of human. That's what we're talking about here. Poly's text-to-speech technology uses artificial intelligence to create natural-sounding human sounds. Now, Neural text-to-speech is a service that can improve the quality and get better with advanced speaking styles. It can be used to help people read through a document at a faster pace or even narrate a book while on the go. This can vastly improve productivity. Many people can read much faster than they can listen. Other people can listen faster than they read. So this is your mileage may vary. Now, Poly can return audio as a real-time stream. And this is going to make it ideal for a call center because that way we can use reactions for prompts during phone calls. Poly can be used as an announcer or public transportation system, perfect for that kind of application. Giving it up-to-date schedule information that would be beneficial to the user or someone visually impaired. From games to interactive media, it can be used to basically react to tailored speech responses. Chris, did we reach 20 minutes where I should open some questions?
Continue going. You've got about 2 or 3 more language things to do, and then it changes.
Okay, let me do a few more language things. Let's talk about recognition. Recognition is a way to analyze videos and images using machine learning. Now, this is kind of a cool tool. Amazon Recognition is used for identification of individuals in a video, analysis of emotional state based upon facial expressions, identification of unwanted content in videos, the ability to search a video for a different person, labeling of images, detecting anomalies. Now, this is pretty cool because in real life, there's lots of times where you get a lot of information. Think of it from a security perspective. You're in England, they've got London has cameras everywhere, and there's a threat. They can use something like recognition to kind of go through this. Or think about your business. You want to make sure there's nothing in your business from your users that could be brand damaging. So recognition is quite helpful. Let's talk about Textract. Amazon Textract is another machine learning service that can extract text, handwriting, and data from scanned documents, JPEG, PNG, PDF, TIFF. It's kind of like the old school optical character recognition with machine learning to make it smarter. Amazon Textract works by reading and processing millions of documents using machine learning, which is a combination of various application programming interfaces plus learning all the stuff that's there. After reading context, Textract can extract text, handwriting, and information. Textract can automate document workflows using AWS Lambda functions by making API calls. Now, using Textract makes it easier for companies or businesses that deal with a lot of documents to automate the processing and extracting of critical data in an easy and cost-efficient manner. Textract is useful when it comes to the ability to extract critical business data such as applicant names, mortgage rates, and invoice tools, I should say. Let's talk about Translate. This is a service that can provide translation of 25 languages from one form to another. It's an automated language translator. Some things don't naturally translate for real, and we humans actually have to basically come up with things. Like if I were to say to Chris, open the lights, he'd look at me like I have 4 heads. But if I said to him, turn on the lights, he'll know what that means. Remember, some things don't naturally translate, and that's going to be your weaknesses with these kinds of things. Keep that in the back of your mind. So it's a service that'll provide translation. It uses artificial intelligence, machine learning to try and translate as accurately as possible as time and demand permits. People of different languages can communicate despite their language barriers. Translate uses neural networks that identify and intelligent translate languages it supports. This helps in converting one language audience to another language audience. Basically what happens is you've got an encoder, and the encoder is going to read through the text word by word and then theoretically intelligently translate that and process that data so what the text is supposed to mean. It's aided by a neural network node called attention mechanism best to understand the text. And then it's got a decoder, and the decoder is going to use the semantic meaning to translate the word in the text for the intended output. Now, Translate is a service that can be used to detect an input source language and tell the user, realistically speaking, what language they are using to aid that, to enable a multilingual user experience in your application. Translate company-authored documents such as meeting minutes, technician reports, knowledge-based articles, and posts. So let's open it up for some questions. Actually, I'm going to talk about Alexa, and then we're going to go to the question and answer session. What is Alexa for Business? Alexa for Business is going to improve the usability of conference rooms and offices by providing a more streamlined method of accessing your company's schedule, tasks, and information. By utilizing Alexa for Business, companies can develop Alexa skills curated to their staff or clientele. Alexa for Business enables IT to centrally manage and deploy Alexa devices for use by employees in shared spaces, etc. You can put it in a conference room, a huddle space, a phone booth, a lobby. Any physical person in possession of a shared device can use it. Now let's go back to the AWS service. And actually but it's a good question, Summit. So before we go back to the content, if you guys can give me all a hashtag AWS Certified Solution Architect Associate. Alonzo's perfect. Consider the cloud a timeshare. I like to view it as a hotel room inside of a big hotel. Exactly best way to look at it. Again, I'm seeing this AWS Solutions Architect Associate, more AWS Solutions Architect Associate. Watching from Cambridge, I love that. I haven't been to Cambridge in a little while. Alonzo, AWS Certified Solution Architect Associate, and Shimeless. There you go. You're down there using an abbreviation. No abbreviations for architects. But we're thrilled to have you here, Shimeless. And Shimeless, I actually had some injera yesterday. And some of my other favorite things. So let's talk about Elastic Beanstalk. Now, Elastic Beanstalk is one of those automagic things, and automagic makes people like me terrified. Basically speaking, Elastic Beanstalk provides the necessary tools for web deployment. What'll happen is it'll automatically deploy your tools. So what happens is you'll write some code in either Go or Java or .NET or Node.js or PHP or Python or Ruby. And what happens is Elastic Beanstalk is going to manage and provision the environment for you. Then it's going to monitor the health of your systems and scale or not scale for you. Now think about having something that's done for you. It's never going to be optimal. It's never going to be smooth. It's going to be whatever the computer is determined for you. So it's like going to McDonald's and saying, I'd like a Big Mac, fries, and a Coke. It's never going to have that degree of customization as if your grandmother made it for you, or you made it on your grill, or your wife made it for you, or you made it for your wife. So keep that in the back of your mind. All these automated systems are great because they save time, but you also lose something along the way. So let's look at the concept of Elastic Beanstalk. You basically put in your code and poof, it automatically deploys a fully redundant, at least in a single cloud environment for you, for your web applications. Now let's talk about Amplify. Now Amplify is a service for the quick deployment of full stack web and mobile applications. And what happens is full stack applications are made in the front end, in which the user basically sets up their interface, and the back end refers to servers, code, and databases that make the app work. Now, a developer can create the application without needing to manage services, virtual machines, or storage. Yes, you don't have to do it, but what happens when you don't do it yourself? So let's talk about Amplify. and includes three main tools for development and testing. We've got the AWS Amplify Studio, which is a web browser-based visual deployment interface. It allows for simplified drag and drop configuration of the application's front end and back end. And then, of course, we've got the Amplify CLI, which allows command line development of the application's back end. And of course, the developer can choose from up to 175 of AWS services to build and support their application just by writing a few lines of code. Amplify Hosting. It can push new updated applications to the internet. Code can be retrieved from a Git repository or Amplify Studio and for place, and then deployed in CloudFront's content delivery network. Now let's look at App Discovery. App Discovery is a service that helps enterprises migrate their on-premise applications to the cloud. This service reveals about the business case creation and application migration planning. Look, business case creation is going to need to be done by somebody that knows business. This can give the people that are going to do this some insight, but no application can build a business case for you. Some of the data will be, the cost of operating in cloud versus on-premise, but look where the data is coming from. The cost of migrating information to the cloud, the cost of leaving your current infrastructure, the benefits of being in the cloud, the cost of doing nothing. Now, when I learned how to practice medicine, they were very careful. Look at the source of the information. If you're dealing with a drug company funded study, chances are the study is going to be supporting things that's funded by the drug company. When a cloud provider is making something that's going to build a business case automatically for you, it's probably going to be biased towards them, meaning they may use overly high pieces of information for they think you'd have cost it for run your own systems, which may be accurate or may be totally off. Now, app discovery makes migration easier by allowing enterprises to make better decisions because it's a tool. From this data, companies can rapidly organize, track, and shift applications to the cloud and what it predicts is the most efficient way. Again, analysis by the human mixed with app discovery magic. One application by itself, not so good. Not looking at data, not so good either. So it's a combination. It should never be gut. It should always be data plus human intervention. And when we deal with AWS Application Discovery Service, it collects information like CPU, disk space, and network usage performance. Now, captured data can be used for the analysis of network efficiencies and deficiencies in between your systems. A little more about application discovery. Basically speaking, it's used to collect detailed information about an enterprise's on-prem data center. It then uses this information to form the most efficient and cost-effective migration strategy to the cloud. Keep that in the back of your mind. It's from the cloud provider telling you how the cheapest way to do it. From this data, enterprises can determine total cost of ownership, benefits, etc. Let's talk about app flow. Now, app flow is a bidirectional service, meaning it goes in two directions, that moves and synchronizes data from third-party applications. Software as a service, for example, like Salesforce or Slack, to AWS services without having to write code. It's a synchronization service. We've had these for a long time. All that's needed to do is to configure your data transfer requirements, and AppFlow will take care of moving your data between SaaS applications. SaaS meaning software as a service. Think about Microsoft 365. Think about, for example, Salesforce.com, software as a service. Zoom, software as a service. By aggregating data from multiple sources, companies can make observations, create hypotheses, and draw conclusions based upon the information that's been consumed. AppFlow can help determine the total amount of money a customer is spending on a user's business as products during their lifetime. AppFlow can improve operational efficiencies by connecting application services and processes and devices to automate workflows. And anytime we can automate workflows, theoretically speaking, you can reduce real-world errors and reduce the overall cost of business. Now, AppFlow modernizes data governance and clarity of the movement of your data between these applications. Usage for AppFlow is to quickly integrate your applications, to transfer your data at a massive scale, and to automate your data security. Let's talk a little bit about AppSync now. AppSync is a simple solution that enables multiple applications to be connected and synchronized with data from multiple sources, including databases, Lambda functions, and OpenSearch. Now, AppSync automatically manages and updates the data in web and mobile applications in real time, and updates the data for users for offline users as soon as they connect. By doing this, it combines all the data from multiple applications and simplifies the processing of transforming data to the cloud. AppSync uses a publisher-subscribe model method to push or pull data from multiple sources. The template is used to define what data is going to be pulled and from what sources. A little more about AppSync. AppSync is a simple solution to really just move your information. It can synchronize your data from databases, Lambda functions, and open source. AppSync will automatically manage the updates from your web and mobile applications. Now let's get into Cloud9. Cloud9 is an integrated development environment, which is software that pulls together common tools that is used to build applications under a simple graphical user interface. Now, Cloud9 provides 40+ programming languages and provides developers within an environment with all the tools necessary to build, run, and test and debug applications and software releases. Cloud9 offers the ability to develop, deploy, and debug applications using a simple browser. You don't even have to deploy the application delivery environment. Now, this integrated delivery environment will help save time in developing new applications because there's not so many tools that need to be configured separately. They have automatic code generation and intelligent code completion features, which help cut down on the time. Just like when you send a text and there's a predictive text that finishes your word for you, this is what Cloud9 is doing, and it can really save you some time here. Now, Cloud9 will also identify bugs in real time. It'll highlight certain things in your syntax, and this way developers are not going to have to switch between tools because they're in a simple graphic user interface. This is kind of a very nice tool. These features enable developers to have an organized workflow and solve problems when they arise. Now we're going to talk about a service called CloudFormation, which has no place in today's modern world. Terraform has replaced it by using Terraform. You can deploy something in AWS, Azure, Google, OpenStack, and Nutanix all at the same time. By creating CloudFormation templates, which we're going to talk about next, you are locking yourself into only AWS and making it harder to create a high availability multi-cloud environment. But it's on your exam, so we're going to talk about it for the purposes of the exam. CloudFormation is an infrastructure as code service. It provides a means for you to template known good configurations of your systems, meaning you've got a web server with a certain level of patching and a certain amount of information in it, and you can use CloudFormation to basically provision that server exactly, or provision all your things. Now, CloudFormation would be great if it was worked on multiple clouds like Terraform, but it doesn't. But CloudFormation templates can be made via simple text files or via any of the supporting languages. Look, it's the Amazon proprietary version of Terraform. Here's what it's going to look like. You're going to code your information, infrastructure. You're going to store your template in S3. You're going to launch that template, and it's automatically going to deploy your information exactly where it's supposed to be. Exactly where it's supposed to be. CloudFormation templates are available for a multitude of options. You can write them from scratch in either JSON or YAML format. YAML format, you'll recall, is typically used in Kubernetes deployments. The code is either stored locally or on S3. The code is either used by the CloudFormation. You can use it in the console, CLI, or of course the API or programming interface. CloudFormation will provision your systems based upon the template. CloudFormation can deploy your templates across your infrastructure. And CloudFormation also has a couple of stacks. All resources managed by the template, the CloudFormation template, are called stack. Briefly, we'll talk about a new service called Code Artifacts. AWS Code Artifacts enables users to store software packages used during application development. The software packages are stored in a repository like GitHub, so they can be accessed for future reuse. The packages can then be simple files, reports, or logs. Why your company needs AWS Code Artifact, it reduces delivery time by encouraging code reuse, just like Git would do. It's a fully managed service by AWS, so it takes the stress off the management, and there's no limit to the number of packages you would like to store. CodeStar is a service that assists in the creating, managing, and deploying software applications. This service facilitates using a central console that can be used to assign project team members to specific roles needed to access certain tools and resources by a centralized console. CodeStar offers a single dashboard that integrates software development tools, thereby making it easier for managers, developers, and team members to collaborate on projects so they can use the console to track software development. Data Exchange. AWS Data Exchange is a data subscription service that allows the exchange of data between organizations. Customers can subscribe to various published data through the console. Data can be used to make data-driven decisions by using analytics or machine learning. With AWS Data Exchange, data providers can host data such as payroll information, debit card transaction, healthcare and demographic data for the use of AWS customers. Now, if it's going to be healthcare data, it's going to have to be de-identified data, because otherwise HIPAA rules will get in the way. You can't say Mike's medical record is this, but you could de-aggregate the data and find out that you had 600 people that had heart attacks, for example, and try and figure out what's going on. A little more about data exchange. The data is produced as a data product that customers can subscribe to in the data exchange or the marketplace. Data in the AWS Data Exchange can be organized in these 3 ways. Assets, which is just a piece of data. Revisions, which is a container of 1 or more assets. And data sets, which is a series of 1 or more revisions. Data Exchange allows customers to migrate to the cloud with existing subscriptions by approved third-party providers. Some more new services that are part of the new exams: Associate and Professional. Device Farm. AWS Device Farm allows developers to test their applications by using visual devices available on the service without the need to buy physical devices. So basically using virtual devices. These virtual devices can cut across platforms, including iOS, Android, and other web platforms. So instead of buying an iPad, you can use a virtual iPad to test your code. This is nothing new. We've been using things like this forever. AWS Device Farm allows testers and developers to test their applications in the following ways: automated app testing, remote access integration, for example. Automated app testing: users can upload and choose the application to test, select devices and operating system versions, and the number of devices that are going to be used for the test. Users can select as many virtual devices as possible, different operating systems, as well as to get to the desired outcome. Users can then remote access integration. Users can set up a virtual device, interact with it while remotely achieving real-time outcomes. So if any of you have ever seen what some QA testers do in real life, you deploy something and then they create a fake 10,000 users and use Ixios to generate traffic and use other scripts to generate users. That's what this is doing. It's a nice way to simplify the testing across a wide variety of platforms. Let's talk about Forecast. Forecast is a machine learning tool to assist with business forecasts. It works in a time-based environment by analyzing data, oldest data first to the newest data, to help businesses make predictions. That's the whole point of machine learning in the first place. Amazon Forecast works by using machine learning algorithms to combine historical time series data with other variables to build accurate forecasts with the aim of predicting business outcomes accurately. To create a forecast project at Amazon, users work with the following resources: imported data sets, training predictors, and generating forecasts. Amazon Forecast is used when you want to predict business outcomes accurately, useful in fields like healthcare, retail, finance, hospitality. These things are useful anywhere when you want to take information, aggregate it, and monitor it. So let's talk about where we would use it. With regards to operational planning, it can support business applications to predict amounts of web traffic, AWS usage, IoT sensor usage. We can use it for supply chain planning, for example, to allow business to predict how much goods and services they need to purchase when they need it. We can use it for retail demand planning. It'll give business the opportunity to predict demand based on historical data and associated data. So businesses can adjust inventory and pricing, for example. And it allows businesses to predict requirements for staffing, energy utilization, and marketing. Now we'll briefly talk about Global Accelerator. Global Accelerator is the way to get your stuff and data quicker. And what happens, Global Accelerator will use a built-in health check to make sure your endpoints are healthy. And what happens, it's a means to connect to the system. So let me whiteboard this out, how these things work. Typically speaking, these are done with like an Anycast environment. So let's share this. So I want you to think of this in the concepts of routing. Let's say you're here, the user. Let's say this is the user. And you want to connect to an endpoint with AWS. Now let's normally say this is your closest endpoint. And this endpoint is going to have an IP address of 3.3.3.3. That's where you're going to connect. And then let's say this is going to bring you all on to the AWS cloud. Now what's going to happen is we're going to create an IP address that's 3.3.3.3. We're also going to use something called Anycast. Typically speaking, when we do something like this, and when you do something like this, let's say you have another 3.3.3 over here. And the other 3.3.3 is also going to be connected to the cloud. So the way this works is if your user's over here, what's going to happen is your user is going to connect to this 3.3 because it's closer to them. Let me move the user up so you can see the user. So if the user's over here, they're going to use this 3.3.3. But what happens if this 3.3 goes away? Delete. Now this user is going to connect to the cloud over here, which is going to get them to the cloud. So what these endpoints are doing is they're using a single IP address, and this is called Anycast. You'll see it widely used in IP multicast routing. You'll see it used in DNS, and it's creating multiple devices with the same IP address. Now, because we're using the same IP address for each one of these devices, which is really cool, we'll only be able to reach the closest one. And what's going to determine the closest 3.3.3 for us? Let's move this stuff up. Oh, let me move some of this stuff over a little more to try and make it a little more clear to you. Because let's say there's a couple of 3.3s. Sorry, I'm on the wrong screen when I'm trying to do this. I want to make this picture clear for you guys. And we're typically going to have multiple endpoints when we deal with a global accelerator. And the goal is to get us to the closest one. Now, if we happen to be over here, this then in this particular use case, this 3.3 is here. But what happens when this 3.3 dies? Trust me, all technology dies. Then we want to go to this 3. Then we're going to be taking this to, this 3.3 will go here. And if this was dead, we'd hit the other 3.3. So that's really what we're talking about global accelerator. We're finding an entry point to get you onto the AWS network. And we want to find the closest entry point. But we also want to do it in a high availability manner. And that's why we're using Anycast. Because if any one of these goes, that's going to be there. Now, how are you going to determine what's the closest 3.3.3? Well, if you're on your computer, you're going to have a default route. Your default route's going to take you to your internet router. And either that router is going to have a default route and use your ISP's information, or you're going to have two internet service providers, which you should be, have BGP, and BGP will determine what's the closest 3.3.3 for you on your routers. So that's kind of be the way this kind of works. So let's get back to the content. We've got an ambitious agenda for another hour and a half today. If you can give me a hashtag AWS Certified Solution Architect Associate, and for Brent, who just got a new keyboard, maybe you can give it to us twice because you weren't able to type for the rest of the week, and so happy you have a new keyboard. So let's get into Managed Grafana. Grafana is a service that's used to enhance productivity while making use of Grafana applications by taking away a burden of self-management, because it's a managed service. Grafana is an open source analytical platform that's used to visualize, query, and understand metrics stored anywhere in your production data center environment. It's going to be serverless, which means you don't have anything to manage. And so they say it's serverless and secure. Users can instantly query, correlate, and visualize operational metrics and traces from multiple sources. Now we're dealing with managed Grafana. It's going to be highly scalable. And because it's managed for you, you don't have the burden of upgrading your platform. Now, Managed Grafana provides a single dashboard containing all of your resources and tools. It's a highly interactive data visualization service for monitoring of real-time data. It allows for the easy integration with open source tools like AWS tools, third-party tools, and common data cloud sources. Now, Managed Grafana supports SAML, security assertion markup language, which is widely used everywhere, like Active Directory. It's highly secure, assuring data privacy and protection. It eases the stress of licensing and removing periodic licensing with Grafana because they manage it for you. Now remember, they manage it for you. OpenSearch Serverless. OpenSearch is an open source service that allows users to search, analyze, and monitor large volumes of data from multiple sources. It's going to incorporate visualization tools that provide information into unstructured and semi-structured data. In addition, OpenSearch integrates well with analytics, machine learning, and other mining tools. When data is captured and fully loaded into OpenSearch, it's going to use built-in services such as Kibana, full-text querying, autocomplete, or scroll search to search, visualize, and analog DOMs and get real-time insights into your data. And it can reduce operational overheads because it's open source, it's somewhat managed for you, and it's easy to use. Let's talk about another AWS service, a new one called Proton, which is an automated application delivery service that focuses primarily on containers and serverless workloads. Proton enables platform teams to enforce and control best practices in your underlying infrastructure. Proton is a service that separates the infrastructure and its code to promote effective collaboration between infrastructure teams and development teams. Proton provides the offerings of infrastructure as code, CI/CD monitoring in an efficient way for dealing with containerized and serverless applications. These templates can be used to replicate across various development, staging, and production environments, and users will have full capacity to manage, update, and troubleshoot as appropriate. This deployment is really a workflow tool for modern applications to help DevOps engineers achieve more organizational agility. Now we're going to get into something that's really cool. VMware on AWS. Now there's VMware on all the cloud providers. And this is really an infrastructure of a service platform that it basically offers a complete software-defined data center on AWS, on Amazon bare metal servers. So realistically speaking, you got two options when you go to these clouds. You can use their management console and all their stuff, which for many people is new to them. Now, most data centers for the last 20 years have been using VMware. They're fully virtualized, fully hyper-converged, just like a cloud. And everybody knows how to use them. And we're all comfortable with using them. And then when we go to the cloud, our cloud providers make up silly terms such as Elastic Compute Cloud, Compute Engine Instance, and all these things, which confuses customers. So now AWS and the main cloud providers say, hey, you could just use your same VMware stuff on our cloud. So basically what happens now is you can now use VMware on the cloud, use the same beautiful, elegant VMware interface that all your people have known for the last 20 years, not have to deal with any of those AWS management consoles or CLIs anyway. And while AWS can say, hey, we made a light mode, a dark mode, who cares? We're trying to do these things. This is basically letting your users use the stuff they've used with all the control they've been using forever. When they take their virtual machines from their data center to the cloud, they don't even need to convert them now because they're going to just move them directly in basically. So now it's the simple VMware user face, that same vSphere, all these kind of wonderful VMware tools that the people have used. And now they can easily push this on multiple clouds, all at the same time with an interface that's known. That means no real retraining of your users because they're going to do the same stuff they've ever done. And this means they're going to use the same VMware servers, the same vSphere, the same VMware Virtual SAN, the same VMware NSX virtualization technologies, all in the data center, directly in the cloud. Nothing new to learn. So VMware on AWS, as well as VMware on the other clouds, will enable enterprise IT operations to continue to use their great services now on the cloud. So now they don't have to buy their hardware, but they can still use it the same way they always have. This is really great service. The offering enables customers to quickly and confidently scale up or down their capacity with minimal friction and simplicity of ease. The service is optimized to run on dedicated bare metal servers. So you'd be using the VMware hypervisor as opposed to the AWS hypervisor. Very simple migration, very fast disaster recovery, flexible in every way. And basically, hey, you get to use your same VMware now in the cloud. Nothing to learn whatsoever. Kind of makes learning all these services somewhat irrelevant because now you can do it all in VMware the way you always have, but without buying the servers. So that's what VMware is on all these clouds. Simple and elegant. Lots of customers are going to take advantage of this. Of course, if it's a new customer, they could go straight to the AWS EC2 versions. But if they've got this and it's deployed and their team knows about it, it makes it simple and elegant. They don't need to hire or cross-train new people to do the implementation. Let's talk about AWS Wavelength. And that typically exists outside of an AWS center. So with Wavelength, users can create their virtual machines, otherwise known as EC2 instances, block storage, otherwise known as Amazon Elastic Block Storage, and Amazon Virtual Private Cloud subnets in AWS Wavelength, and use services that orchestrate Elastic Kubernetes Service, for example, and Amazon Cluster Services. What we're going to be dealing with is infrastructures are going to be deployed on 5G communication provider networks. And this is going to be useful when you've got a low latency environment, such as streaming applications and things that are going to be out there. Wavelength is really an infrastructure deployment embedded in telecommunications facility like a 5G network. So this can be compared to a local zone that works with an availability zone, but with low latency. Part of AWS Wavelength, what you would have had it done is application traffic would have to travel from the device to a cell tower, and then a metro aggregation location, and then it could go to the internet before it could reach AWS. These network hops, anytime we're dealing with hops, could add milliseconds of latency. And by doing it this way, it's going to be closer. So think of an internet IoT devices that are going to go straight to this wavelength thing, pushed on the 5G network and back to the cloud. So there's lots of use cases for this. Amazon X-Ray. X-Ray is a tool used to troubleshoot and identify root causes of performance issues with AWS services. X-Ray looks at your application programming interface requests as they travel through your application and produces a map of your application. Developers can use AWS X-Ray to analyze and debug their applications. X-Ray will provide a full picture view of the request passing through user services, and it helps see who made the request to the service, when the request was made, and when the request came back. X-Ray was going to work by collecting data from the applications or services running in your system, and it will then aggregate or combine that data to form traces of each system. Next, what will happen is X-Ray will create a service map or visual representation that can be used to trace or debug or even troubleshoot each service. Users will be able to further drill down on each service to identify the root cause of any issue facing their application. Some benefits of using X-Ray are for auditing purposes, to trace requests made by your applications, to create a detailed service map of the applications running in your system, to help find bottlenecks in your architectures to improve performance, to help us identify the security posture by encrypting all traces, and to identify all traces. Okay, so now let's get into something funner. And yes, I know funner is not a perfectly good piece of grammar. So wake up, everybody. We're going to go talk about containers and container orchestration. So before I know that you're awake, I just want to know you're awake. Give me a hashtag solution architect or a hashtag cloud architect, and then we're going to talk about containers, which is one of my favorite things. Because virtual machines and containers are the basis of all computing in today's world. And while we're waiting for that to come in, Anakin, this question in there is quite real. All this machine learning, how fast has become Skynet and the Terminator movies? Well, it depends how fast these things get used, whether they get used, whether they get checked, whether people get wild and crazy away with them. But automation can be great. Effie, to me, is cloud architect. Good to see you. Gavin, I'm loving this. I'm seeing solution architect, cloud architect. I know you guys are awake, alert, and oriented. And I do like containers. And actually, before we get to containers, I've got the perfect visual for a container that's going to explain the concept. And then after we deal with the visual for the container, we're going to start talking about containers. But let me get my container visual real first, because I had a really good container example before. So let's talk about containers before we get into containerization. I'm going to just share my perfect representation of a container. Okay, so here we go. So before we get into containers, here's what a container is. Normally speaking, with a virtual machine, what are we going to have? We're going to have a server. It's going to have its own operating system. It's going to have the application dependencies on the application. Here, before we get into containers, here do we have? We have an application. The application is represented by the beautiful Cindy the cat who's sitting inside. Now, if you notice, the cat put herself in a basket. The basket is the container. So basically, what container, and we'll talk more about it, is we're going to steal parts of the operating system or libraries from the operating system, and it's a fully contained application sitting inside of a container. Now I can take that container from one Linux system and pop it on another Linux system by using the same Linux libraries. This is how I view a container. My cat Cindy demonstrates containers everywhere. And let's talk about containers. And everybody give me a hashtag Cindy while I start talking about containers, because Cindy is the best container teacher I've ever met in my entire life. So while we talk about containers, there's going to be 2 or 3 ways we can orchestrate our containers. Now, the first one I'm going to give you is AWS proprietary, and you probably should never use it in reality, because if you do, you're going to be in trouble when you have to use Azure and Google and Nutanix and OpenStack. Now let's define a container. It's a newer, more modern, lightweight version of a virtual machine. See, in a virtual machine, we have the entire operating system. Every time we've got a server, I showed you on the first day, we have our hypervisors, and then we have a virtual machine. Each virtual machine has its operating system, application dependencies. Now, a container is just like Cindy, beautiful little Cindy there sitting in the container. It's just the application, so that's all we're doing it. So by using containers, they're faster, they're lightweight, and we can use much less computing power. Now, when we deal with containers, something needs to orchestrate these containers. And we need to separate them. So we'll talk about container orchestration in a minute. But what are we really talking about? In this particular environment, we've got our physical server, we've got our operating system, and then we've got a container on the operating system, a container on the operating system, a container on the operating system, another container on the operating system, and they're all isolated on the same operating system. So let's talk about the strengths and weaknesses of this approach. If container 1 crashes, it's completely isolated from container 2. So if container 1 crashes, guess what? We've got no problem with containers 2, 3, and 4. Now, everybody in the chat box, I want you to tell me this, because I want you to understand this. What do you think happens if the host operating system crashes to the 1,000 containers that are sitting inside of this system? Everybody tells me in the chat box, what's going to happen if the operating system crashes and I've got all these containers in this system? I want to make sure you understand this very critical concept. Good job, Alex. Boom, all containers are gone. Lady Godiva, you're gone. Abigail, bye. Yes, all data will be lost. Everything is dead. That's the whole point. So, containers, every technology we use has its strengths and weakness. Containers are beautiful because they're lightweight. But if that host crashes, everything else is dead. So kind of keep that in the back of your mind. It's good. We love them. There's a strength and weakness to every approach. If a virtual machine's operating system crashes, guess what? We only lose that virtual machine and its application. If we have 1,000 containers on a big giant server, they're all gone. But containers still make sense in most cases. Now, I'm going to tell you right now, when they do certification, they'll tell you can just migrate a container everywhere. Well, if you develop a container on a Macintosh, you can't put that container on a Linux machine. And you also can't put it on a Windows machine. If you have a Windows container, you can't put it on a Linux machine. If you've got a Linux machine, you can put it on any Linux server, or you can actually put it on a Windows system that's running the Windows subsystem for Linux, because the Windows subsystem for Linux is an Ubuntu kernel that's added to Windows. So keep that in the back of your mind. Containers are portable, but containers borrow things from the operating system. And therefore, a Windows container must be deployed on a Windows system. A Mac container, a Mac OS container must be deployed on a Mac. And somewhere along the line, we've got to orchestrate these containers. So if we're going to have containers, something needs to determine whether the containers need to grow, size, or control them. So let's talk about this, where you're at. One way that you can manage them, which I strongly don't recommend you ever use, is the AWS Elastic Container Service. And the Elastic Container Service is a 100% proprietary, AWS only, fully managed container service. Now they'll tell you it's high availability, which they call 99.99% available. That means that you'll have 1 hour during the year expected, 50 some minutes a year, where your systems won't work. And that's best case scenario. Assuming the cloud provider doesn't crash. Now, Elastic Container Service is going to be deployed in your VPC, which usually means since it's in your VPC, you'll be able to use access control like NACLs and security groups to protect your systems. And Elastic Compute Cloud can work with Fargate or virtual machines, and I'll explain to you what they are. So here's the way you would typically build your containers. And this is the same with a Kubernetes environment or this proprietary AWS Elastic Container Service, ECS, which locks you into AWS. If you use this Elastic Container Service, it's going to manage and orchestrate your containers, and you're going to have to build your containers. You're going to have to put your containers on a virtual machine. You'll manage your virtual machines, and then you'll manage your applications and then containers, and you're going to pay for your virtual machine. Now, if you wanted to run this in a serverless environment, which you could also do, you could run your Elastic Compute Cloud with Fargate. And what is Fargate? Fargate is an AWS-managed serverless environment that hosts your platforms. Because it's serverless, it means you don't need to manage your virtual machines. Now, potentially when you go serverless, it can often be cheaper because with a virtual machine, you may be buying more capacity than you need. Where when you go serverless, you're not. So, but also when you go serverless, you have much less control over your systems and your performance and your security. And you're now part of a shared service where if the shared service gets hacked, you get hacked. For example, Microsoft was just hacked. And what was it, 65,000 of their customers' information that was hacked? I mean, lots of information, because in one of these serverless cloud managed things, if the cloud gets hacked, you get hacked too, or at least it's a possibility. But with serverless, you don't have to manage it, which can make it simpler. So it's an architectural trade-off. Do I want more control? Don't go serverless. Do I want more performance? Don't go serverless. Do I want simplicity and elegance and lack of control? Less work to do? Go serverless. So Fargate is kind of that environment where it's serverless container orchestration or serverless container hosting. So instead, if we wanted to use Fargate versus a virtual machine, we've got the same Elastic Container Service, which is proprietary, which means you probably shouldn't use it, managing your virtual machines, and we'll build our containers, define the required compute capacity, and it'll be just managed in this serverless platform. So potentially cheaper, much more agile. Now we can put our containers in a traditional virtual machine called an EC2 instance here. It could be the same thing if we were on Azure. We could put them on an Azure virtual machine. On Google, we can put them on a Google Compute Engine. It's the same concept. And if we need more control, obviously put it on a virtual machine. If you're looking for simplicity, stick it in a serverless environment. You and your business can determine exactly what's needed. Now, if Elastic Container Services is a proprietary service that I strongly don't recommend you ever use, what would I recommend you use? Kubernetes. Why? Kubernetes is an open standard. You can build your beautiful Kubernetes clusters with your own servers. Stick one server in your data center, one server in Azure, one server in AWS, one server in Google. You can have your multi-cloud container orchestration. Single cloud goes down, who cares? You're still up and running in your 3 other clouds. Multiple control. Your cloud provider raises your rates. Guess what? You can leave and go to another cloud. Your cloud provider kicks you out. And we've seen cloud providers kick businesses out of their business, nearly bankrupting them overnight. If you're using Kubernetes, no big deal. You can pick up your containers and move it to any cloud at a moment's notice. Now, if you didn't want to build and manage your own standards-based Kubernetes cluster, but you still wanted to use a standards-based process, this is where the Elastic Kubernetes Service is. So it's a fully managed Kubernetes container management service, which means you don't have to build your own cluster. Now, Elastic Kubernetes Service is now in a single cloud. So if you use multi-cloud and the single cloud goes down, well, you got nothing. But if you're looking for simple and elegant in the AWS cloud, and you're looking for something that can work that's standards-based for your future, the Elastic Kubernetes Service is still a very, very good option. It's an open, Kubernetes, as you know, is an open source container management platform. It's the standard container orchestration platform in the entire world. And Elastic Kubernetes Service is similar to the Elastic Compute Service, which we just talked, container service, which we just talked about, but it's a standard, it's not proprietary. And whenever you want innovation, never use proprietary, because now you can migrate to different clouds should anything happen. Now with Elastic Kubernetes Service, we can host our containers in two places. We can post it on a beautiful virtual machine if we need extreme control, or we can post it on Fargate and there's nothing to worry about because it's giving us a pre-made platform. So let's look a little bit about the Elastic Kubernetes Service. We create an EKS cluster, Elastic Kubernetes Service cluster. This cluster is our orchestration platform. And from there, we can stick it serverless, which is Fargate, or Amazon EC2, which means virtual machines. And all cloud providers have the same service. Of course, you could build your own Kubernetes thing. Now, if you build your own Kubernetes thing, what's the weakness? Well, the weakness is this. You got to manage the Kubernetes cluster, which means you need to have someone smart enough to know what Kubernetes is and how to manage it. But when you do that, you get much, much, much more control over your environment. And you can create a higher availability system by using an unmanaged Kubernetes cluster where you've got your own servers and multiple clouds all at the same time. Now let's talk about another cool Kubernetes thing, Elastic Kubernetes Service Distro. And this is a service that's going to enable users to run containerized applications in their data centers. What is it? It's Kubernetes. Now this enables users to create a Kubernetes cluster with the exact version of Kubernetes used in AWS, EKS. The main difference between EKS and EKS Distro is that EKS is fully managed on AWS, where EKS Distro is basically a download of the AWS version of it. By using EKS Distro, users can deploy clusters in their data centers that exactly match AWS. EKS Distro can be used for hybrid clusters. If users want Kubernetes clusters that span their data center in the cloud, for example, when you need to use the cloud for extra capacity, you can use EKS Distro. EKS Distro could also be used for disaster recovery. You could set up AWS EKS to be the backup data center if your own data center goes down. Of course, you don't have to use anything proprietary like this. You could create your own EKS or your own Kubernetes environment with your own servers and not get locked into anything. You just have to know how to install Kubernetes and set it up, where EKS Distro gives you a very beautiful, simple, like click, button install. So it's removing the need to actually understand what you're dealing with. Now let's talk about Elastic Containers Registry. You may have been familiar with the interface of, say, Docker and Kubernetes, where basically speaking, we had Kubernetes managing the container and Docker as a host, as basically a container runtime module. Docker to some degree is being phased out by Kubernetes, but let's talk about what this is. The Elastic Kubernetes Registry is a product that stores, manages, and deploys Docker images that are managed clusters of EC2 instances. The Elastic Container Registry allows developers to save configurations quickly and migrate them to a production environment, which is going to reduce workload, overall workload and time. The Elastic Container Registry provides a command line interface and APIs to manage repositories and integrated services, such as the Elastic Container Service that manages the infrastructure for its containers. The Elastic Container Registry is a secure, scalable, and reliable service that accesses and distributes your application images faster, reduces downtime, and improves the availability of your containers. When to use EKS Anywhere. Basically, you're using EKS Anywhere, Elastic Kubernetes Service Anywhere, because it's going to simplify customers' on-premise Kubernetes deployment via management configuration to provide auto-scaling. It offers a consistent, reliable Kubernetes cluster environment with your on-premise, better than self-managed. I don't know that it's better than self-managed. They will tell you that it's better than self-managed because they manage it for you. Personally, when you self-manage things, you can always do better. Again, it goes back to, can you cook a better steak than you can get at McDonald's? You know, mass volume can never be done as nice as precision one-on-one things. But precision one-on-one things take a lot of time, effort, and money. And when you use EKS anywhere, it's going to reduce your support cost because it's going to help you reduce third-party application tools. It's open source, and it's going to make it a lot easier when somebody else has done the hard work for you. A little more about EKS Anywhere. It's a customer managed service that's going to allow customers to create and manage Kubernetes clusters with optional support. It's deployed as an installable package that simplifies the creation. It then automates the management of these clusters. Okay, we're going to get next into IoT services. I think I talked about some AWS services, and I think I talked about some Kubernetes things and container things. So now let's get into IoT services. Wow, I've been working with IoT stuff for 15, 20 years now. When I was at Cisco, we were starting to work with all these little IoT-enabled sensors that were going to be out there. There were going to be weather sensors, all kinds of plane sensors. Now IoT is everything from your refrigerator, which is IP-enabled, to your cable box, which is IP-enabled, to little sensors where you can watch the beach and see what the beach things are for things like that. So AWS accordingly has a bunch of IoT services. So let's begin with AWS IoT Core, which is a cloud service that acts as a communication gateway, message broker, and device application interface for internet-connected IoT devices. It's the foundation for Amazon's solution offerings that come to deploying, managing, and analyzing and maintaining an Internet of Things infrastructure or architecture. As we discussed IoT Core, it's going to provide a scalable and fully managed solution that's going to supply and secure connectivity from devices, rule-based IoT, traffic manipulation, command control. Really what it's doing is it's going to enable your back-end fleet of cloud services. It can reduce the operational burden for your IoT devices by providing a platform that supports the communication and management. This service facilitates the communication from device to cloud services, applications, and other devices. What's going on is it has a built-in authentication and authorization RESTful API, which is basically a programming interface for command and control capability. Multiple IoT communications protocols are going to be supported because these things use lots of communication protocols. And you can create an access list to determine who or what can access the systems. And it's going to provide a registry to store the data. A little more on IoT Core. The service is going to be beneficial to a situation where there's a need to connect a fleet of IoT devices. Think weather sensors or airplanes that are constantly transmitting their information to back-end cloud services. This kind of access can give users the ability to process, analyze, and make actionable decisions from the IoT data quickly within a millisecond time frame. Now, this service can be handled by a device fleet ranging from a single device to billions or trillions of devices. When we're dealing with these kind of IoT devices, we're dealing with stuff coming from everywhere. Let's look graphically at what some of these pieces work like together. We've got an IoT device over here on the left. We've got some RESTful APIs that are sitting up top. We've got some internet-connected devices, and they're all going to be talking to each other through the IoT Core environment. Let's talk about device management. IoT device management is a device inventory and management service for Internet of Things connected devices. Organizations using the AWS Internet of Things device management service can easily register device information, configurations, and organize and inventory their devices, monitor them, and remotely update their software and firmware. IoT device management helps to track, monitor, and manage an entire connected fleet. And by doing so, it can ensure that all IoT devices work properly and securely after they've been deployed. The device manager provides the ability to access securely and get information about device health, defects. And by getting this, you can remotely troubleshoot problems while you're managing software updates. talk about opportunities to use IoT device management, remote fleet monitoring. Let's say you want to monitor your equipment's metadata and set a policy to change like a service alert so you can see what's going on. You want to perform bulk updates or control the deployment velocity, do some over-the-air updates like firmware and bug fixes. You want to define steady jobs for automatic updates. Let's say you want to create logical groupings of devices for, say, sensors in a specific area to organize and target a fleet of remote actions with a few clicks. Now let's talk about IoT events. Now this is going to be a cloud service that continually monitors data and applications and equipment for any changes in daily operations. If an event's going to occur, it's going to trigger a response. IoT events run in a serverless environment, so there's no host. IoT events monitor ongoing data from IoT device sensors and applications to integrate with other services like IoT Core and AWS IoT Analytics for early detection. This will help you gain insight and take action against your data. This service will help manage the state of your devices. A little more on IoT device events. It's going to monitor equipment for failures and operations. And if you've got a device that fails, it can trigger an event. So you know what to do about it. Users will be able to take input from multiple sources and will be able to move the device from using like IoT Core and collect analytics from IoT Analytics. So it gives you kind of things that are going on. Analytics can take the input and run that data on at the edge of your systems. Users can also route sensor data to IoT events. So realistically, IoT events are consistent with processing messages and consistent with real-time reporting. Actions take place in real time, and IoT events simultaneously monitor multiple applications and sensors to detect critical events. IoT events also makes it easier to deploy, detect, and respond to events that happen across multiple devices, equipment systems, and applications. IoT events will assess the behavior and performance of the devices and identify issues based upon what industry it's being used in. IoT can help an enterprise, therefore, understand the conditions of their equipment. It takes more than a single sensor to get this kind of information, obviously. IoT events can learn new insights that will help you automate your operations faster. And by automating things, you can reduce costs. Potentially reducing costs and making better decisions faster can increase revenue and decrease expenses, which can enhance profitability. IoT events can help identify root cause analysis with device sensors and applications. And IoT events will enable organizations to really focus on their business operations and less about the IoT because it's a managed service. Let's talk about the IoT of Things graph. AWS IoT Things graph is a service that's to enable non-developers to visually create workflows between physical sensors, physical assets, and web services. By doing so, we can basically build a network across physical and virtual things. With IoT Things graph, we can quickly build IoT applications by connecting devices and web services from different vendors. And of course, when you're dealing with IoT devices from different vendors, they're going to speak different protocols, and IoT Things graph can help do that. Basically, IoT Things graph gives you a visual editor that we can use to wire things together, such as web series and a workflow. Web series and web services in a step called the flow. I like to call things workflow. And because it's basically a hosted environment, you're going to pay for what you use, as opposed to just paying to have a system, like if you built it yourself. Now let's talk about IoT Analytics. This is stored data. Why are we using it? We're using IoT Analytics because it's a fully managed service that enables users to collect, manage, and ingest data from millions of sources. It's going to provide us a solution for collecting, processing, and analyzing data in real time. Anytime we can analyze data in real time, we can make better business decisions, which mean potentially greater profitability. IoT analysis can help enterprises and device manufacturers quickly and easily gain insights into their data by collecting, filtering, and transforming things. So let's talk a little bit more about AWS IoT Analytics and the benefits of why we might use something like this. It's going to help by storing data in an optimized manner so we get faster response times. It can prepare data to be easily processed and analyzed. It can be managed as a pay-as-you-go service, which some people like, because that way they don't have to buy anything ahead of time. It's going to help the organization build applications that monitor in real time. it's going to be able to help monitor the efficiency of different processes for improvement. Okay, now we're going to get into cost management, at least as it's taught in the context of an AWS certification versus cost management in the context of reality. Because this is what you need to know for your exams in real life. We would obviously teach you how to do this in an architecture program, but this is a certification course, so we must do it the AWS way. When it comes to managing costs, we must understand that moving to the cloud can have a profound impact on a customer's costs. In many scenarios, going to the cloud will be cheaper. In some scenarios, going to the cloud can be far more expensive. So what's going to determine that? How the user, the systems they have, the capability of their systems, the performance of their systems, the engineers they have, the architects they have, the technology people they have, and where those employees actually are. In most cases, moving to the cloud is generally cheaper, but not always. And that's why you're seeing a lot of organizations that first went all to the cloud, and now they're pulling half of that stuff on the cloud, putting it back in their data center, and they're still using the cloud, but they're building their own clouds and they're creating multi-cloud solutions. Now, I want you to understand the difference between the two. There is definitely a capital structure change. And here's the capital structure change. When you have a data center, you have predominantly CapEx. Capital expense is something I buy. A car is something I buy. I buy it once and I can keep it 4 years, 10 years, 20 years, depending upon how good the car is and how well it's maintained, right? That'll determine how long I can keep my car. Now, when you rent a car, if you were to go to the rental agency every day, it might be cheaper. It might be more expensive to rent the car because the cloud is just renting. Now, what'll determine if it's cheaper for you to buy the car and maintain it yourself or rent the car? How much do you drive the car, for example? What kind of car is it? What the rental agencies change versus what you cost to buy it, the kind of deal you get when you buy it. So these things are not simple. But you need to understand what we're talking about is a shift from a capital expense to an operational expense. And many people think this is a good thing. It could be a disaster. So for example, in our case, it was $10,000 to buy our stuff that the cloud providers were looking for around $11,000 pre-discount for us to do. Now, I just wrote a check and paid for the $10,000 of servers. It was no big deal. But businesses don't write checks. They finance things. So when you're building a business case as an architect, which is something I can't teach here, we have to teach it in our architect program, you're going to have to look at the organization's weighted average cost of capital and what it costs to finance it versus what it costs to use the cloud, which is effectively leasing. So this is going to be that lease versus buy decision. Now let's talk about why the data centers are so capital intensive. Well, there's a lot of stuff to buy, a lot of it. So first with a data center, you got to buy the real estate, right? So now you got to buy a big building. Now, the buildings aren't designed immediately to be data centers. You're going to have to buy your servers. You're going to have to buy your routers. You're going to buy your switches. You're going to buy your firewalls. You're going to buy your load balancers, your racks, your power environment. And look, data centers don't have power failures because you're going to be bringing in multiple power transformers, ideally 2 power companies. We're going to be having generators. We're going to be having backup generators, UPS systems and battery backup. We're going to be dealing with data center cooling equipment, and it's a lot of things. So when we go to the cloud, we don't have to buy any of that stuff. Of course, we pay far more for each service, but we don't have to buy it. Now in the data center, we have a big staff. You need a bunch of expensive Cisco certified internet experts like me to make sure the network actually works. You need a lot of people to manage the physical servers themselves. Lots of people to do parts replacements when something happens. You don't have to deal with that stuff in the cloud. There's no parts replacement in the cloud. Somebody does it for you. Now in your data center, trust me, these things generate some sky-high scary electric bills. things that you can't even imagine. And then, of course, we've got to buy our wide area network connections. I've worked with customers that have spent hundreds of millions of dollars a year just for their network going from point to point. Now, in the data center, the majority of our costs are equipment. That's why the capital expense heavy. We still have operational expenses related to running the stuff and our people, but the primary cost for the data center is capital cost, purchases. And when we go to cloud, the cloud, there's nothing to purchase, but we pay far, far, far more for the use of everything we use. And on the cloud, we pay for everything. Like in the data center, you don't pay for data transfer charges in your wide area network in the US. You got a 10 gig link, you don't have to pay to use it. On the cloud, you get a 10 gig link, you have to pay for the link, you have to pay a daily fee for the link, and then they charge you to use the link that you just paid for. So, you know, the costs are different, so it requires somebody with real business acumen to make a decision whether the cloud makes sense or not make sense, or whether part on the cloud, part on the data center. But for the purpose of your exam, in the cloud, there's minimal equipment to purchase, which means there's low capital expenses because there's nothing to purchase, or almost nothing to purchase. But remember, the ongoing costs on the cloud are sky high. So for most organizations done properly and architected properly, which I'm going to tell you I'd say 2/3 get wrong, the cloud will have a lower total cost of ownership, because even if you're paying so much more for the tech, you're paying so much less to operate it, house it, maintain it. Now, when it comes to managing costs, here's the thing. Provision only what you need. See, here's where we can gain some benefits on some applications in the cloud. In the data center, we must provision for the worst case scenario. In the cloud, we can purchase on average use and use auto scaling. So that auto scaling thing and the agility of the cloud, being able to take a virtual machine and create it in 6 seconds, as opposed to calling Dell and ordering a new server, that agility is pure transformation for business. Step 2, properly size your resources. So use whatever the minimum amount that you need is, and then use auto scaling to scale out as needed. Don't over provision. Now, how else can you further reduce your costs? Decouple them whenever possible, decouple your systems. So we showed you how using an SQS queue or an Apache Kafka queue can reduce the need for bigger databases by smoothing out things that are going on. We showed you how using caching can reduce the load on your servers, so you need less of them. So by decoupling things in your architecture, you can put them together in an environment that can totally reduce your costs, many of the time. Now, step 3, use the right platform. What I mean by this is, you know, when we looked at our 10 cloud server and we paid 10 grand for the servers versus 11 grand a month, that was on demand. Now, we could have reserved them and committed to buying them 3 years in advance, and instead of paying $360,000 or like $380,000 for our systems, instead of the $10,000 that we paid to do it ourselves, potentially speaking, we could have got a 40% discount, knocking it down to say $200,000. Now, we have to understand that just because I built the cloud for 10 grand and it would have been several $100,000 on the cloud doesn't necessarily mean my 10 grand was cheaper. Because why was it cheaper? Because I have the firewalls here, I have the networking gear here, and I don't need to hire anybody to do it because I did it in a couple hours and I thought it was cool and fun. But if it was a production environment, you know, we'd have to hire the people, and then it might be cheaper to the cloud. So these analyses are based upon the people you have, the technology you have, what you need, what you don't need, what's modern, what's not modern. So how do you structure your costs? Well, if you know your system use, reserve it and get a big discount. If you don't know your systems, use on-demand capacity. And as soon as you figure it out, go reserve it. Now, basically, you can reserve all your stuff based upon what your needs are. Use on-demand to scale as needed. Now, let's talk about the spot instances that we talked about the first day when we talked about computing. Spot instances are the kind of things that you use to bid on unused capacity. So let's think about bidding on unused capacity. You can get a very cheap rate for batch computing by using spot instances, but spot instances can get shut down. So the key is, when it really comes to cost optimization in your compute environment, It's going to be a combination of on-demand, reserved, and spot instances. How else can we manage costs? Well, it's often cheaper to use a managed service or serverless, because with the server, we probably have to over-provision. But once you go into managed service and serverless, guess what? You lose negotiation and bargaining power, and here's why. Your cloud provider knows it's going to be really hard for you to leave, and it may have costed you millions and millions and millions of dollars to restructure your applications to go serverless, and now you're trapped. You're locked in. So managed service and serverless can be good. It can be not good. It depends on how you use the managed servers and how you use the serverless, or using industry standards, which can get you to go to multiple places. Now, step 5 is let's look at your data transfer costs. If you build your own wide area network, you basically buy for the links, but you don't pay to use them. Now we're on the cloud. They charge you to actually send data over your own links or over the cloud. So how do we minimize the amount of data we're sending off the cloud provider? Well, if we've got an S3 bucket or an object storage bucket in 2 regions, maybe we just replicate the data so we're not traversing the entire WAN. Maybe we use CloudFront so the web requests don't go across the cloud each time, or another content delivery network like Akamai. And then maybe we look at what is our connection to the cloud. If we have limited data to send to the cloud, it's cheaper to use over a VPN. But if we've got a lot of data to send to the cloud, it might be cheaper to have a direct connection. Because remember, in a normal environment, you pay for the link and not to use the link. In the cloud environment, you pay for the link, a daily fee to have the link, and then you pay to use the link. And in many cases, it's more expensive to use a VPN than a direct connection. You've got a lot of data to send. The next thing you can do is you can set up a budget. And a budget can help by basically alerting you when you're spending too much money. So you can create a budget that says, hey, when I spend over $20 million, send me a message. And $20 million for an organization's cloud is going to be nothing. But I recommend you set up a budget when you're doing labs. Set the budget for $25. And when you hit $20, it's going to send you an alert. For $25, you hit this alert, or 50% along the way. And that way it's going to alert you if you've done a lab and forgot to shut off a virtual machine. So you don't get one of those multi-$1,000 bills at the end of the month that people do when they're training for certifications because they forgot to shut off a virtual machine. So create a budget and set an alert. Businesses can do this, and they're going to find out, hey, wait, spending lots of money here, do something else. How does the budget work? Well, basically you create your budget, filter whatever you want, and get your notification. Now let's talk about Trusted Advisor. Trusted Advisor is a tool made by AWS to help you save money. It's a tool made by the cloud provider to help you save money, which means pay them less. Is it in anybody's interest to sell you less stuff? No. It's kind of like when a drug company sponsors a study. Again, it's not objective. But so Trusted Advisor is an AWS tool designed to help you make better business decisions on how you spend stuff in the cloud. So it's a service, and what's going to happen is the Trusted Advisor service is going to look at your infrastructure. It's going to then compare your infrastructure to what it thinks is right based upon AWS best practices. And then it'll give you advice. Now, the good news, it can give you advice that you did stuff wrong from a budget perspective. It could also maybe tell you that you made some risks, things that you should fix too. So it's good to use a tool. The tool provides information, but the point is the tool is not the be-all or end-all. When you're using the Trusted Advisor, there's basically 2 versions. There's the kind that comes with the basic and developer support plans, where customers are going to get access to 6 security checks and 50 service limit checks. Or customers that are on business support plans or AWS enterprise support plans are going to get 115 Trusted Advisor checks, of which 14 are related to cost optimization, 17 are related to security, 24 are related to fault tolerance, 10 are related to performance, and 50 are related to service limit. Here's another tool that the cloud provider is trying to use to help you spend money, which means spend less on them, which is damaging to their business. So take it for what it's worth. Compute Optimizer is a free management tool that recommends AWS resources to increase the efficiency and reduce your user costs. Compute Optimizer reviews previous resources activity to use to distinguish between your platforms, like where your data is stored, for example. Compute Optimizer will compare your user activities levels to similar users or similar activities and give some recommendations. And Compute Optimizer will take on comparison and prevent graphical data, and it's going to explain its recommendations, what it thinks you should do to optimize performance, reduce cost, and errors. But it's a tech device that's giving you information. Now with Compute Optimizer, clients are given the opportunity to use the look-back option to review 3 months of long-term data history and make recommendations based on that. This service will enable users to utilize resources that theoretically reduce cost and improve performance. When users enable these suggestions, AWS will configure the resources to deliver optimal performance based upon business needs. Let's talk about service quotas. Service quotas are going to give the ability to view, log, and set limits on several services that integrate with the AWS dashboard. Service quotas will help users scale various workloads as workloads increase. Users can adjust service quotas or service quota values and monitor them by setting up alerts. And these alerts will inform users of pending limits. This will help keep users from having unintentional spending that's going to negatively impact the company's overhead. Service quotas is a good resource to kind of look at your logs, and it's going to determine if there's a need or a place where you can save in a certain area. Theoretically, this can help control costs. Another tool, a well-architected tool, which is a free cloud service that's going to give you general guidelines and best practices. It's going to theoretically help plan to create better workloads. Here's the thing with a well-architected tool. It's going to recommend AWS services. And there may be many good reasons to not use them, such as you need good security way above what you can find, like next-generation firewalls. You're going to need some more robust applications that are provided by AWS. You're going to need a more robust content delivery network. Look, right now, AWS isn't even using CloudFront. They're using Akamai right now. And that's part of what goes into a well-architected system, putting in the best tools from the best resources to deliver the best business outcomes. And, we have to be careful where we're getting this information. And a service like this is not necessarily going to give us exactly what we need to. Now here you can see now Amazon is using another content delivery network. Now they're using Fastly. And that's the point is, when it comes to high availability and when it comes to good architecture, everybody should ever use a single cloud. It's a single point of failure. Nobody should ever use a single content delivery network. It's a single point of failure. Amazon doesn't use a single content delivery network. We've gone through 2 content delivery networks in 2 days. So now we're going to get into building high availability architectures, at least what we're supposed to cover for the certification. So before I come back, if you give me a hashtag AWS Certified Solution Architect Associate. So now we're getting into the part of this program which I hate teaching because it gives me cognitive dissonance. Because I'm going to tell you what you need to know to pass the exam, and it's completely inaccurate. So I'm going to tell you the accurate thing first. When it comes to building a high availability system, never use a single cloud. I'm going to say it again. If it comes to high availability, never use a single cloud. When it comes to high availability, never use a single cloud, because the single cloud is a single point of failure. If a cloud, no matter how many availability zones and region you use, gets hacked, you're down. If there's a major network misconfiguration, there's down. You're down, the whole cloud. If there's a network outage, they're down. If the control plane goes down or gets hacked, they are down. So single cloud is a single point of failure. Every cloud provider has had outages in the last few years. None of them have gotten to 4.9's availability. And I want you to think about this. If you, your mother, your sister, your brother was in a hospital on life support, and AWS or Azure or Google was the only cloud, and they had a cloud outage, and cloud outages happen all the time, and your systems that were keeping your parents alive went down, your parents would die. Would you ever want that? No. If you had a bank, by the way, where billions of dollars of trades were going on and they were down and the bank could literally go bankrupt with your money, would you want that? No. So a single cloud is a single point of failure. So when I go to talk about this, What I'm telling you is the stuff that the cloud providers are telling you as far as the exam. But likewise, Amazon right now has used 2 different content delivery networks in the last 2 days from the times we did an NS lookup on it. And I'm sure they use more than that. So keep that in the back of your mind. What I'm going to tell you now is passing the exam only. So when you're designing for availability, you understand that the higher availability systems you get, the more costly it's going to get. And we typically talk about availability in terms of nines. 99 is 2 nines available, 99.9 is 3 nines available, 99.99 is 4 nines availability. AWS calls that high availability. 99.999% availability is what I've worked on for the last 20 years. These are critical performance systems. Banks, hospitals, internet service providers, they all need to be at 99.999, as does any business. Imagine how much it would cost Amazon if you went to Amazon to go buy something and it was unavailable. That'd be a disaster, right? Now, if Netflix goes down for 30 minutes, who cares? But if you try to buy stuff on Amazon and they can't sell you for 2 hours, imagine what it would cost them. So most organizations would consider 99.99% available, high availability. Real critical availability systems like a bank, a service provider, healthcare would consider 99.999% available. Now, when you build a high availability system, you have to think about everything. The networking connections to the cloud provider, because if you can't reach the cloud, guess what? You've got nothing. Something my grandmother would call bupkes and my other grandmother would call dipota or dipota, which is nothing. So you means if you're going to have 2 direct connections to your cloud provider, your 2 direct connections should be on 2 different routers. And each router should have 2 different power supplies. Each power supply plugged into a different outlet. Why? Because if the power failures in the rack or the outlet, you don't want your WAN connections to go down. Now, the routers connecting to the cloud should have 2 brains in them and multiple cards where your wires are installed. And that way, you have no single point of failure. Now, when you build a high availability system, you could feel comfortable with the cloud because they maintain redundant power. Well, AWS has had 2 power outages, which took down half of their system in the last year. But the reality is data centers, and you assume a cloud provider has redundant power in their data center, so they won't come up with outages, which means they have redundant power. They have redundant generators coming in, redundant power companies coming in. So if they came down to a power outage, you can think about what that possibly could have been. Now, a good cloud provider like AWS is going to have redundant cooling. Why? If an air conditioner goes down or 2 air conditioners go down, their systems will cook and you'll have no cloud, so we have to assume they have redundant cooling. We know AWS has multiple redundant connections to the internet, and their backbone is highly redundant. Their routers and switches are highly redundant. And for people like me, building these environments, that's what I did in my sleep. I've been doing it for 25 years. But many organizations don't know how to do this. So for organizations without a bunch of network experts, it's often higher availability for them to go to the cloud provider than doing it themselves because they don't have the sophistication to do it. But for organizations that need it, they can hire people like me that have been network architects and high availability architects for decades. So when you build a high availability system, don't use a single cloud. But if you do, at least use 2 availability zones, which is 2 different data centers. Theoretically, according to that, the cloud providers can get you to 99.99%. I don't think any cloud providers delivered 99.99% in the last 2 years. So, but theoretically, they can do that. If you need better than that, use multiple availability zones, which is data centers in multiple regions. But if you're going to put your stuff in 2 different regions and 2 different data centers, just use 2 clouds. 2 data centers and 2 clouds is a much higher availability solution. So anything that needs high availability, like your servers, should be put in multiple data centers. Your databases should be in data centers. Your load balancer should be in data centers. And of course, DNS or Route 53 is a single point of failure in a single cloud. Ideally, architect around it by using a real DNS service, the kind that you would get from F5 from the marketplace, and have your DNS servers in multiple places. Building a high availability network, make sure there's redundant connections, which means a direct connection, a backup direct connection, a VPN backup, minimum. or a direct connection and a backup connection. Now, if you're going to have two WAN connections, let me make this very clear. If you have two connections to AWS, this connection's on if this connection's on AT&T and this connection's on AT&T, you just architected a single point of failure. Because if you get a cable cut goes down on AT&T, you still got the other link. But if AT&T goes down, you got nothing. So for the last 20 some years, organizations building high availability systems always use two links from two providers, AT&T and Verizon and NTT. So when it comes to WAN building, you always use two connections. So each connection to the cloud should be through different people. So if you had an AT&T private line and an AT&T internet connection VPN, you just architected a single point of failure. Should AT&T have a global outage, guess what? You don't have any connectivity to the cloud and all your systems are down. So multiple connections. So if you're going to have direct connections, chances are you might want redundant ones. And that means you need to go to different direct connection location data centers. Because, for example, if you had your direct connection and it was going to a single direct connection data center, guess what? If that direct connection data center goes down, you lost your connection. So you always want to go to multiple connections, multiple places. Now let's talk about security. If your systems get hacked, they're not available. So use the principle of least privileges and IAM. Disable all unnecessary services in your systems. Regularly patch your systems. Micro-segment your system into multiple VPCs. Use things like organizations to reduce blast radius. Keep unwanted traffic out of your systems with access controls and security groups. Make sure you've got good security. So use a next generation firewall, for example, over WAF. Use some sort of a DDoS protection like Shield. Use strong physical security. If you've got a router over here and the router is connecting to the cloud and somebody can plug into the router, they can just plug an Ethernet cable into the router. Guess what? They got into the cloud like nothing. So make sure those systems are locked up. Make sure there's strong security around the wiring closet or data center. You need to use passwords. Use strong passwords. And template known good configurations for your team that are going to be deploying it in Terraform. So they can redeploy things that you know to be good fast. Make sure that your systems are backed up constantly. Backup should be stored in one location. If you're in AWS and you back up your data to AWS and AWS goes down, you're in trouble. Back up to another cloud, for example. Take your virtual machines or your service, create machine images of them so you can launch them somewhere else if you ever needed to. Now, how do you build some availability and performance? Well, use auto scaling. Why? You're under a DDoS attack and all of a sudden you get a multiple requests whether you can handle your systems with high capacity on demand. Decouple your application architecture components. If your database fails, but you've got a queue in front of the database, the queue can store your messages. Use caching. What happens if my website to www.gocloudcareers.com goes down? But I had everything cached on a content delivery network. You might be able to get to my website and see it while my web server is down because it's stored on the cache. Use DNS with health checks for load balancing. Use load balancers to increase performance and reduce single points of failure by sharing the load against 10 medium servers as opposed to one gigantic server. Constantly monitor your system so you can figure out what's going on. Look at the logs, look at the auditing events, monitor for security events, monitor your IDS IPS system for security breaches, monitor the usage of your system, and monitor for performance. And lastly, change management. In a real high availability system, here's what it's like. Alonzo says, Mike, I want to change the configuration. And he sends a message to me. Who sends it to Chris? Who sends it to Leo? Who sends it to Chow? Who sends it to Manuela? Who sends it to Eddie? Who sends it to Anselm? And part of that change management request is, hey, if I change this thing at 3 o'clock in the morning, will this affect your system? And we can all analyze the change to see if it's going to cause a problem. And if we all say, go ahead and do it, then after Alonzo makes that change, he needs to check in with all of us and we need to retest our systems to make sure he didn't break anything. And if he did, we need to fix it. And that's why all these things are done, typically speaking, in the middle of the night. That's why I have lots of sympathy for engineers, because cloud engineers are doing work in the middle of the night. We architects are buying dinners and drinks. It's a little easier, but those cloud engineers, we got to have a lot of respect for them. 2 o'clock in the morning, they're doing work like this. Now let's briefly talk about passing the exam, and then I'll answer questions. The AWS exams are not difficult, but the way they ask questions can be brutal. They ask questions in a very wordy environment. There's typically not a winning answer, so it's select the best answer. The less you know about tech, the easier these exams are going to be, because if you know a lot about tech, these exams are going to be complicated because they're going to give you a question and there's going to be 4 answers. One might be the way Cisco would do it. One might be the way VMware would do it or Microsoft would do it. One would be the AWS way. So if you don't know a lot about tech, this is going to be a very simple exam. If you know a lot about tech, forget everything you know when you took this exam and just try to pretend that you just read this book and you just took this class and you don't know anything, and then it'll be very simple to get to the answers. But if you know a lot, it's going to work against you. So you almost want to shut your brain off and think exactly what is only on the AWS curriculum and take that exam and then be done with it. Now, I recommend that you look at this, watch this presentation again. You carefully look at all documents. You read the AWS white papers covering the services listed in this book. And here's the reason why. The AWS white papers are designed to convince you to go use and sell AWS stuff. What are these certifications? Certifications in today's world are designed to get you used to thinking about using the brand terms and helping to sell their stuff. So read those white papers. You're going to see a lot of questions from there. I strongly recommend you get a practice test. There's 2 companies that make practice tests that I like. Haman Sharma is the CEO of Review and Prep. He's a good friend and he's got excellent AWS practice exams. I also love Andrew Brown's content from ExamPro. He focuses on certification. I focus on getting people hired. Andrew and I are good friends and we recommend people back to each other. He sends me people for career stuff. I send him people for certification stuff. He also has some free AWS training. And I think for less than $20, guess what you get? You can get his practice exams and they are really, really, really good. Now I suggest you take a practice exam. And when you take a practice exam, you retake these exams until you can get a 95% or better on a practice test. Here's the reason why. It'll make sure that you are used to taking exams. And when you get used to taking exams, these exams will be silly easy. Trust me, they're nothing compared to some of the more complicated exams like a CCIE. But I will tell you one more thing. Because the way AWS writes these questions, they're ugly the way they're written. So the night before the exam, get a good night's sleep, eat healthy. Don't go drink a bottle of Silver Oak with your buddies or have a bunch of scotches. Don't drink any alcohol. If you're in California, don't use any of the other substances that are illegal that can affect your thinking either, or Colorado or one of those other states. Keep your brain fresh and sharp the day before the exam. Arrive for the exam early, whether it's in person or not. I promise you, tech problems are going to occur. There's going to be some tech problem that occurs. Your system will freeze up by the security software they're putting in there. So be early. And if you drive there, be early. Don't try to be cheap on parking. When I had no money, I'd still pay the $20 for parking. Now it's probably more because I wanted to be there, relaxed, not worried to find a parking meter, worried about who was going to ticket me. And make sure you've got a valid photo ID for the exam. This way, you're out there, you're relaxed. And why am I so concerned with you being relaxed? I'll give you a little bit of the neurological reasons why. Right now, we're talking, we're having a good time. We're using the prefrontal cortex part of our brain. It's the thinking, the logical reasoning, the intelligent part of our bodies. Now, when we get nervous, what happens is the prefrontal cortex shuts down. This nasty thing called the amygdala kicks in. The amygdala is responsible for freeze, fight, or flight, and we get dumb. So be relaxed, be calm, be good to go. Regarding the amygdala, if you don't know what I'm talking about, let's say you're with your wife and she says something that would normally be no big deal, you deal with it. But if you're angry, you say something and you say something you regret, then you're in the doghouse for the next 3 years. Husbands can do it, wives can do it, best friends can do it. It doesn't matter. So kind of keep that in the back of your mind and you'll be good to go. It's been such a privilege and an honor to be with you this week. I hope you guys all learned a lot. Make sure you download a copy of that free book. Make sure you learn the AWS labs and sign up for them. They're completely free. And join me on Thursday on the How to Get Your First Cloud Architect Job webinar. I look forward to seeing you there. Take care, everyone, and have a wonderful day. I'd like to tell you about some free things we do to help you get your first cloud architect job or transition into tech. 3 times per week, completely free on YouTube. I will answer any type of cloud computing questions you have. Come and ask questions about how to build your career, and I will answer them completely free. Every Thursday, we have a completely free How to Get Your First Cloud Job webinar. People come from all over the world in this webinar. I will tell them the following: how to leverage their life experience so the hiring manager they're ready. I'll go over the job, the cloud architect job, in depth. I'll go over the things that hiring managers desire. I'll teach you how to bypass HR and get your resume directly in the hands of the hiring manager so you can get hired and not auto-rejected by HR when you lack experience. And it'll be a great time, and you'll learn so much, and by the end of this, you'll know exactly what you need to get hired. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, and I look forward to seeing you in another video. Take care.